Hello, everyone. Thanks for joining. We're going to be starting very shortly, so sit tight. Hello, everyone. Thanks for joining.
Hey, Carlos, can you hear me okay?
Yes, I can, Matt. Loud and clear.
Awesome.
Hello, everyone. We're going to get started in just a few minutes. We're just going to give people maybe a minute or two to register and log into the webinar, and then we'll get right started. Thanks for your patience. Hello, everyone, and welcome to VeloCON 2023, the second annual VeloCON. My name is Carlos Canto, and I am extremely honored and privileged to be here today and be the host for this event. We have an absolute banger of a lineup for this year's VeloCON, and I can't wait to get to the presentations. I first and foremost want to thank the IT and event staff here at Rapid7 for helping to make this event happen. There are a lot of moving parts, and we can't thank them enough. Also, thanks to the executive sponsors for this year's event who helped us acquire all the funding and buy-in to really make this a memorable day. But most importantly, thanks to you, the community of amazing contributors, testers, and enthusiasts who have helped Velociraptor grow into the premier open source DFIR platform on the planet. This event is by you and for you and is a true testament to the power of community source development. So without further ado, let's get on with the show. First, a quick look at the agenda. I'm just going to share my screen here. Okay. So we have the day pretty much broken up into chunks of presentations. We'll go pretty much 2 by 2. We'll have a break in the middle of the day. We'll break for a little bit longer for lunch, have another break in the mid-afternoon as well. And then we should be wrapping up at around, anywhere from 4 to 4:30. Keep in mind, this is a loose schedule in terms of the timeline. There may be presenters that go a little bit over. There may be presenters that go a little bit less than the time allotted. So if we have to make any adjustments on the fly, we'll do that. Just a couple of housekeeping notes before we get started. Here are some resources for you. They're available on the web and in social media, particularly for people that may not be as familiar with Velociraptor and are hoping to get a little, helping to brush up a little bit on the content ahead of today's event. Our main website, which is where all our documentation lives, is docs.velociraptor.app. Our GitHub, which is a repository where all things Velociraptor lives, all of our source code, all of our artifacts and plugins, those will all be on GitHub as well. You can just log in and join that repository. Our social media presence is most heavy on X, formerly Twitter. I still call it Twitter. You can follow us at Velocidex. We also have a pretty big presence on LinkedIn as well. If you just search for Velociraptor DFIR, you'll find us on LinkedIn. X and LinkedIn are probably the best ways to get kind of like, up-to-date news, event information, any place we'll be presenting at, any, tech talks we're giving. You'll usually find that information on Twitter as well as the website. And Discord is really where our community is most lively, most active. We have our own dedicated Discord server. If you just append /discord to that docs.velociraptor.app URL, it'll take you right to the Discord channel that we have set up. So definitely encourage everyone to join that today. We actually have a channel set up, a sub-channel set up within the Discord server that's called #VeloCON 2023. That is uniquely set up just for this event. If you have any questions, you can pop those into the Discord channel, and we'll try to answer them in real time as much as we can. Alternatively, and probably the best way to ask any questions during the event today is to use the little hand-raising icon at the bottom of your webinar screen. Anybody that's familiar with Zoom webinars probably is familiar with this thing. Just click on that little hand, click on the Q&A icon. Sorry, not the hand icon. Click on the Q&A icon. That'll open up a little window. You can you can enter in your question into that window, and then we'll be monitoring that chat or that window throughout the day, and we'll try to answer those questions as quickly as we can. So you have either the Q&A functionality within Zoom or the Discord server to ask any questions you may have. All right, and then additionally, this event is being simulcast on YouTube. So if for whatever reason you guys get kicked out of the Zoom webinar, you can't log in, you're having trouble connecting back to the Zoom, just search us up on YouTube. The whole event is being webcast live there as well. I will give you one piece of advice. Don't just search for Velociraptor whether you're searching for it on YouTube or anywhere else, you're just going to get a whole bunch of hits based on dinosaurs. Get a lot of dinosaur videos. So instead, make sure you search for the parent company for Velociraptor, Velocidex Enterprises. It'll be the channel will be the first thing that pops up once you search for it. Click into it, hit that subscribe button. You'll get alerted anytime we go live, anytime we have new videos that we've posted onto our channel. All right. And then there's something new that we're going to be doing this year. We're calling it the presentation of the conference. As you know, we have a whole panel lined up of presenters for today. We have actually 6 community source presentations, so presentations given by members of our community. And what we're doing this year, we actually want to have a contest for you guys to determine who the best presentation was. So at the end of the conference, we'll be sending out a survey, just as we did last year, a very quick survey, maybe 5 to 10 minutes, asking you various things about what you thought about the event. And then one of those questions will be who you thought had the best presentation in the conference. And you can use any criteria that you'd like to determine that, whether it's, technically informative or intellectually stimulating, or just overall a fun presentation. Whatever you want to use, you can use that as your criteria, but we will ask you to vote for your favorite presentation of the conference. And to kind of raise the stakes a little bit, we will be offering a prize to this winner in the form of a $200 Amazon gift card. So hopefully that does raise the stakes a little bit for the presentations today, or maybe just adds a little bit of extra pressure, who knows, but hopefully not too much. All right, with that, it is time to get to our first presentation of the day. I think you guys are very familiar with Matt. Matt has been a member of the Rapid7 / Velociraptor team for a while now. And actually, if I just give you a quick summary of Matt here. He's an endpoint and threat-focused practitioner who currently works in the threat analytics department at Rapid7. He's been an early adopter of Velociraptor and has been working with the platform since version 0.2x, which I think is just under 5 years, right, Matt? Something like that.
Yep, that's a really good intro. Thank you, Carlos.
So, Matt, take it away. The floor is yours.
Cool, thank you. I think you just need to stop sharing. There we go. Okay, bear with me. Okay, can you see that, Carlos?
Looking good. Thanks, Matt.
Yeah, awesome. Okay, so for this talk, I've kind of left everything in slides, which would be an interesting experience. My talk's probably going to be just under 30 minutes, I think, depending on how much I waffle. So hopefully we'll get a little bit of extra time back when I run through this. But it's titled Velociraptor Content Like a Boss. First of all, a little bit about me. My name's Matt, and I work at Rapid7, as was just announced. I'm into DFIR detection kind of stuff, and my claim to fame is I am an early Velociraptor adopter. The specialty I'm bringing to this talk anyway is I do lots of consulting IR deployments, and I think this description or this talk is something I would have liked when I was first starting out setting up Velociraptor. I never really had a DevOps team, and I had to do all this kind of stuff myself. So hopefully people will get value from the talk with that. The agenda for today is I'm going to talk about content management, obviously. I'm going to start really slowly and give some background on the why of content management and how we update. I'm going to kind of show you how we used to do it, which I'm not sure how many people know how kind of manual the process was. And then I'm going to kind of introduce Detect Raptor and give an overview of that. I'm then going to talk a little bit about the concepts and automation. And like I said, hopefully give you some ideas on how you can use these techniques in the field. So first of all, why content management? Now, this picture on the right-hand side is a picture that I've used in other slide decks before, and I think it kind of says what Velociraptor can do in a single image, right? Velociraptor can do so much so that for new users, it's a little bit disconcerting sometimes, where they don't necessarily know what keywords to search or what artifacts to run. So that's kind of the first big benefit of content management, is it lets you kind of run your own gear and standardize a workflow. And that could be workflow where you've got your own custom cape kind of artifact that you run, or it could be something very specific that you build your own context, but you build your own content based upon like threat intelligence and things like that. It's really up to your environment. We also have the option of doing things like versioning. So I contribute to the main project, and often I want to run that artifact. And the only way I really have to run that automatically across a whole bunch of environments is with content management, by deploying it out to servers automatically. So I don't need to go across to every box and kind of add things manually. So it really helps with that. And it's a similar story if you don't necessarily want to update straight away, yet you want like newer content, or there could be a slight tweak in content with the server that you're running. It really helps with versioning. Reduced deployment friction is an interesting point I don't think many people think about, where I kind of see like tech deployment as being really core to IR. And it's the most frustrating thing in the world, where you're waiting to deploy something, and even worse when the customer has to wait. And we can kind of alleviate like some of those issues with content management. That could be maybe building an offline collector, building an MSI automatically. It just is much nicer to do the work ahead of time and front load it, and then have the content created automatically for you. The second last point there about Git is something that I'm pretty passionate about, where a lot of people might be a bit uncomfortable to do a pull request into the main project. And if you've got like a private repo and the people to support it, you can really get some skills uplift with people learning and getting some good feedback if they don't really want to go public straight away. And finally, threat intelligence. I think I touched upon that before. To be able to consume intel and use it effectively everywhere is a really good use case as well. Essentially, we're looking to go from that kind of noisy slide to this situation that I'm sure people are familiar with when you run Velociraptor. Okay, so first of all, we'll go really slow and we'll talk about custom artifacts. So if you want to create a custom artifact, most people kind of know about this plus button, and then you're presented with the custom artifact view. Hopefully you're going to create an artifact that's a bit better than select star from info, but say you save that, it saves it directly to the disk. And what you can see on the screen is me on a Velociraptor server, and I'm just catting the artifact, right? And you can see the bits that I've highlighted is the data store, the definitions folder, and where the arrow is pointing is the artifact name and path. And you can kind of see it's just in a folder, and then the name of the artifact.yaml. And actually that was kind of how the old way of artifact management would be, right? You can kind of see in the middle, I've got a manual copy definitions, and literally, let's see if I can get my pointer. Literally, this is kind of similar to a deployment script that I used to run. The thing to kind of keep in mind, like this still works, by the way, but the thing to keep in mind is this part here. You need to restart the Velociraptor server, and that's kind of painful. And even with running this command as well, just pointing to a definitions path, the core problem is you still need to restart the server. Essentially, that's why Mike eventually implemented a VQL method, and things were happy. And this is what I'm going to kind of walk through now. Most people are kind of familiar with the artifact exchange, and it's kind of like, I think, the standard for artifact management. And essentially, it's a server kind of artifact, and we have a couple of parameters and a prefix here. The URL is essentially just a zip file that's publicly accessible via zip file. And then we move along, you can see on the left-hand side, we have the disk view, and then on the right-hand side, we have what we see in the GUI. Symbols or regex here to get that same kind of view as the disk version. But you can kind of see that artifacts are on the machine. That kind of happens with essentially two functions and a plugin. And I'll kind of walk through kind of how we do this here in the artifact exchange, because this is kind of how simple it is really. Essentially, we have a HTTP client function that we can download the zip file with. And then we use the zip accessor and we essentially glob for any YAML files inside that and then read them. And then finally, we set the artifact with that data that we extract. And it really is that simple. And you can kind of see the view that you get when you import from the exchange here, right? So really simple stuff. Similarly, we can delete artifacts, and it's a very similar kind of artifact, where in this case, we have down here the plugin for the artifact definitions, and we have a where clause for not built in, and that's pretty much just to stop errors. But we're taking this artifact regex at the top, and then we're using a filter for one of the fields we're extracting, name, from this plugin. After that, we essentially have like a confirmation item that you can just view, or if you really want to do it. And very similar to the artifact exchange, you can delete artifacts this way. And this is so much easier than using the GUI to be able to manage artifacts in bulk. And anything that you might want to do in terms of artifact management, you can kind of do using similar methods. I thought I would just print out some of the fields in the artifact definitions plugin to give you an idea. I don't really have much to say here. It's kind of self-explanatory, the sections, but what I want to highlight here is the built-in field here. And this is a non-built-in, but I've actually named it like a built-in artifact. And that's something to keep in mind, that you don't actually need a prefix. You can call artifacts anything you want in the more recent versions of Velociraptor. So it's always a good idea to use that built-in flag if you're kind of like messing with non-built-in artifacts, just to see what's out there, just to see that the user hasn't like created a short name or something that you're not aware of. The other thing I wanted to point out was, I think there was a question I read a little while ago about aliases, and this is how you can add an alias to an artifact. You simply add a heading aliases and then add what you want to have as the alias. In this case, we've got a generic network interface, and we want to add a Windows specific to that. You could also add like another dash and add Linux or Mac or whatever you wanted. It's a very generic artifact. But when we run that, you can kind of see it just adds another artifact, and then it just sets that is alias flag to true. Kind of simple. Okay, so we've gone over a summary. I've gone through the simple stuff with content creation and deletion and a couple of interesting features. I'm now going to talk about DetectRaptor and get into what I think is probably more interesting for people. Now, DetectRaptor, pretty much was a proof of concept that I wrote maybe a year ago to kind of show how we could generate artifacts for bulk Velociraptor detection content, focusing on like publicly available like artifact, IOCs and things. Essentially, I publish like a zip file here as a release, and the repo is updated kind of automatically every time there's a change really that's relevant. I'd like to point out like some of the contributors down the bottom. So you've got me, who wrote most of it, and it's kind of my repo, but Michael, who I worked with at Rapid7, and Zach, who I worked with at CyberCX, SVC host. A lot of this stuff is the kind of things that we've been using for years. And it's kind of like us messing around, and the content's changed a lot as we've moved ahead to make it more performant. But it's the same kind of ideas that we've been using for a very long time to optimize running VQL queries. Like I mentioned, there's several bulk artifacts, and it's published as a zip as a latest release. And the example I'm going to walk through is Windows Detection MFT. Now, this particular artifact I think it's interesting because typically MFT kind of hunting and artifacts can be very heavy, but I've done a lot of work to optimize this artifact. And it's a really good example of kind of customizing things to your workflow. And at the end, I'll show you some really cool notebook tricks as well that we've implemented. So the first thing I want to point out is this kind of resources configuration. So in this case, I've just configured kind of the timeout to 9,000 seconds because it is a big hunt. But I'll show you how to configure this like automatically later, but it's good to keep in mind that you can just set this in an artifact. We've also got parameters that are useful for workflow here. And specifically, one that I like that I've just started using is this criticality level, which can help you optimize your hunts with performance even more. And then the third part on the screen is the ISEs and context section. Now, ISEs is pretty big, and I'm not going to go through all of them, but I've extracted a few to kind of walk through some of the ideas. Now, just to note, like this is just an example, and you can kind of create like a CSV or an artifact that has anything here. But this is just kind of what I've used for this use case because I found it effective. But you can kind of see we've got the name here as detection. If you guys know the MFT, essentially you've got like an MFT object, which is typically a file name or top-level folder name. And when you search the MFT, it's very efficient to search for that top-level name. And that's what the keyword regex search is for. When you're searching for, say, a path, you essentially need to like enumerate the path of an MFT record. And that can mean lots of MFT records go into that. So that can be heavily resource intensive. So ideally, you're going to have a first pass that runs with this keyword regex. So you can kind of see it at the top for data transfer. Megasync is a pretty unique string, right? So you don't need to worry too much about that. Mega.exe, we've kind of anchored the mega part at the start of the string to make it a bit more efficient. Whilst at the bottom, the suspicious location, we're looking more at kind of extension, right? So that's going to pull back all executables or all DLLs, et cetera, et cetera. In this particular line, we're looking at having that second pass regex here of path to make it an effective detection, right? But in terms of performance, these top three are going to be much more performant than this bottom one. The third option here, or fourth, is ignore regex. And essentially that's like a whitelist that we can ignore things with. And finally, we have reference and a criticality for performance, right? And I'll say it again, this is just an example, but you can kind of configure any kind of thing. And what I think is the value of showing this is it will give you ideas of how you can do your own kind of automations. When I move along, now this is kind of the guts of VQL. And I tell you, I have stripped out a lot of VQL out of this demo, so I'm trying to limit it as much as possible. But essentially the first part here is we materialize ISCs. And again, this is a performance thing. And for people that might be new, materialize is this little kind of less than equals sign where we essentially put all the ISCs in memory. So it's really fast to look it up. We also remove keyword regexes. So anything that's accidentally gone in with a kind of an OR, we remove that because you don't want to be returning like a million MFT entries as a first pass, which kind of sucks. But then we've also got the option of using that parameter for criticality and being very targeted with only looking at, say, critical or high items. As I mentioned, we've got a first path. And in this case, we're just searching for the top level MFT name, right? File regex, but we're calling the Windows NTFS artifact. So we're using artifacts that already exist, but just kind of pulling out and querying what we want effectively. With the second pass, we're taking all of our hits that we pulled from the first path, and then we're running them through all of our ISCs and then doing our full filter. Interestingly, we're only returning one entry, and again, that's performance. And up here, I'm creating a dict that has all the detection context in it. And this is the results that kind of come back, or an example of results. And you can kind of see the bit that's highlighted now, we have an exe in suspicious location, vdump.exe in the public folder. And it's really cool because essentially I've built this artifact to kind of show me what I want to triage quickly. We've got information on the hit and then other things that are pertinent to this artifact, like timestamps and size and things like that. And from here, typically I'd pivot off and ask other questions, but this is an example of like taking artifacts that exist and kind of adding a calculator and doing kind of what you want. And the second example I've got is Screen Connect, which is an RMM program. And again, the idea of this artifact is to just have things bubble up to the top. It's not meant to be a perfect kind of detection thing. It's more what's interesting on the box that bubbles up to the top. Okay, so the next thing I want to cover out is notebook suggestions. And on the right-hand side, you can see me continuing the VQL of this MFT artifact. So you can get an idea of some of the VQL. And in the main picture, you can see kind of the path that you see this. And what notebook suggestions are is they're kind of like a workflow tool where you can append kind of set notebooks to an artifact. So when you're in the notebook and doing review of the results, you can click the little plus, you can then click suggestions and have a pre-built notebook ready to go. So in this case, we've got a detection summary that you can get a nice little stat summary of all of the outcomes that have come from the box. And I've also got a list here showing critical and high items. So like I said before, able to bubble things up very quickly. Someone that might not necessarily know how to use Notebook can get some interesting results. And the cool thing is you've got the Notebook template, so you can mess with it if you want. It just saves a lot of time typing. And I find it's a very effective way to deploy artifacts, to have this pre-built notebook ready to go for users. So in summary, we've got a whole bunch of artifacts in this repo that kind of do a similar thing, that build similar capabilities. And then we publish them out to a zip. So hopefully you're familiar with that. I thought I would cover off some of the CSVs that we have. And like I said, these are kind of things that we've used for kind of years, and we've kind of updated them as we go. The event logs one is interesting to look at, where it's a series of event logs, but it's the same kind of idea where this CSV is built to be quite performant, in that you can see I've got a column that has event log. I've got a column that has event ID and then raw, and there's also ignore lists, etc., and context to head that's off screen. But the whole idea is we run a query and then we use these fields to be very targeted in our collection. We're targeted so much that, like, from a performance viewpoint, a lot of the time, if you're running like EVTX Hunter, it can really chug down. But by using some smarts like this, it really improves performance somewhat. The other thing that's kind of interesting is these PowerShell entries. So if you go back and have a look at some of the other artifacts, I've got things like looking at PS read line, looking at like PowerShell ISE remnants. And what we do is we have a script that will pull out these ISEs and then apply it to those artifacts as well. So we're not just limited to like PowerShell event logs. We can leverage these in other artifacts. And this is the beauty of kind of automatic artifact generation. You're kind of only really limited to what your mind can think of. Okay, and this one, I accidentally left this in, but okay, so this one is the version information that we run in our binary rename artifact, and it just has a whole bunch of like file names and internal and original names, and we run this. It's actually very similar to the artifact that we have in the main repo, but it gives us a chance to, like I said before, version out things and add things early before we push them into the main project. So how do we generate artifacts? And this slide is introducing the scripts folder in GitHub. And you can kind of see there's a whole bunch of Python files, and I'll kind of show you how that works a little bit later. But the other side I want to introduce is the templates of each artifact. So in this case, I'm showing the binary rename artifact up here, and it's exactly the same as the published artifact, except we don't have any indicators or any interesting things in it, I've just got a string that I'm looking at popping all of my indicators in, right? And this is the beauty of automation, because it means that we can edit essentially a single point and then have all of our artifacts built automatically. In this case, I'm using GitHub Actions, and you can see the workflow file that I've highlighted. But say internally at Rapid7, we use other automation tools. And I'm sure if you've got a DevOps team, they are probably already doing similar techniques and you're using something like this, or it'll be really easy to have them help you out, set this up. I use GitHub because it's really lightweight and it's something that is kind of free. And because I don't need to worry about authentication because I'm in a public setup, it's quite easy. But you can see in blue, essentially we're installing the prerequisites, which is like setting Python up. So really straightforward. And then we're running our Python scripts. And like I mentioned before, we're taking the CSVs, we're merging with the templates by using that split me. And then we're kind of publishing those YAML files back into the project and generating that zip file. So it's really simple. And like I touched upon before, if you preload a lot of work, when you get to a stage of doing engagements, it's super amazing to have all this great content there ready to go. It is like the guy loving the Velociraptor picture that I showed before. So how do you deploy Detect Raptor? Now, I use an artifact called server import Detect Raptor, and this is actually on the Artifact Exchange now. Like I mentioned previously, I would actually use the same method as the Artifact Exchange, and I'd use a zip file. But I've recently, last weekend, I updated it to use this API link in GitHub. And this is super cool from a performance viewpoint, because I'm going to show you next how to do some monitoring and automatic updating. And what this enables me to do is kind of optimize, save resources when I'm updating. But say when I import it, you'll get a list of SHA-1s, and then we can compare those SHA-1s in the build script that I run just to make sure the content is updated successfully and everything's working. As I mentioned, part of the deployment is validation, and you can kind of see at the back we've got like a JSON thing. That's actually the URI for the releases that I showed you before for the artifact. And when I run the artifact, it actually adds some server metadata to the server, which is a way of kind of storing this last updated time. And then I also kind of take a hash of the zip file. So we've got a way to validate whether or not the content is recent or not. So how do we automate deployment? We've already got server import Detect Raptor, but what we can do is use a server monitoring artifact, or we can do like a server schedule to essentially monitor for new content. And what I use is an artifact called server manage content, and you can kind of see at the bottom, I am setting that up in the little I, which is the server kind of server events section. I'm using a schedule of 14,440. That's actually 4 hours. But what you can see highlighted now is all this artifact does is essentially at a schedule that you specify, it runs that same artifact. Really simple stuff. When I run that as a schedule, this is the logs. So you can kind of see the bit that's red. I'm fetching that API URI up here. And there's no kind of requirement to download it because the server metadata matches. But the blue, the server metadata is different. So you can see it hits the API, it then downloads the zip, and then it installs and updates the metadata there. And then it just goes on and on and on. I actually set this to every 10 minutes, I think, to run, just so I could demo it and get a screenshot for everybody quickly. But it's really cool. When this works and it's deployed, it's an amazing workflow. It means that I can just go edit my CSVs or edit if my script is reaching out to like a CTI platform, I can edit that and then just have everything update automatically. It's a magical experience. Here's the output again. So this is very similar, exactly the same as what I showed you before. And just with the validations of the SHA there, I found that to be helpful, but it's not really needed. It's kind of up to you. Okay, so next I want to touch on is hunt automation. And in DetectRaptor, we have a capability called Start Hunts. And what it does is it lets us run hunts by name. And by default, like this is one of the artifacts that I build automatically, and it automatically populates all of these names. But you can add in whatever artifact you want here. It's not really set in stone. All it's doing is looping through these artifacts. If you notice before in the MFT artifact, I actually had a prefix, artifact dot, and then artifact name. We don't actually need to use that here because the artifact does that when it runs the hunts. But in this case, you can set the artifact, you can set the resources. So I showed you the resources in the MFT hunt, and this will actually override the settings that the artifacts have by default. So you can kind of see here in the MFT, I'm using 9001, and then I'm using the IOPS limit. This is another talk in itself in terms of performance and hunting. But when you run bulk artifacts, I would really recommend thinking about performance and how it's going to impact your customers. For instance, sometimes there's customers that we just don't run hunts with because they might be really sensitive, or we might stick to maybe memory-based artifacts because we know they're going to be a lot more lightweight than heavy disk-based stuff. The thing to touch on is they are paused by default. But if you go back, you can kind of see up here, there is a just run. There's also a just targeting, so you don't need to mess up your hunt screen with a whole bunch of paused hunts. There's lots of flexibility with what you can run. You might have like a set pack you want to run every time, all the time, but others you want to keep paused so you can control when they run. Something else that I use regularly is I'll run an artifact pause like this, and then I'll just go and hit this copy button and then re-edit the config if I want to mess with it. And I find that works pretty well for a quick fire change. Okay, so what's next for DetectRaptor? I pretty much haven't done a huge much to it, but I want to kind of bring on more bulk open source themes, right? I've got a whole bunch of Yarra implementations where I build like Yarra artifacts automatically. So I plan to add them in with a bunch of open source kind of sources. I need to refactor some of the projects that are in there already, like LOL drivers and hijack libs. So if you've actually looked at those artifacts, they're pretty big, and some of them have they've changed the format. So some of the entries are messed up. It still should work, but it needs improvement. I also want to implement bootloaders.io because we have some really interesting content with bootloaders in Velociraptor that a user has put in. It's actually in Velociraptor 7 that I don't think it's been publicized too much, but yeah, there's a lot of opportunity there for bootloader-based detection. So I plan to play with that a lot. And also any other PRs that people might have or any other good ideas, reach out and we can have a chat. So in conclusion, I think like I've only just kind of scratched the surface of content management. Like there are many, many ways to add value to your deployments. I've really just shown like a little bit on how like automation and VQL can make things really easy. And like I said, reach out for any collaboration. We accept pull requests. And if you want to share indicators as well, we can look at like doing some sharing stuff and any other ideas you might have. Down the bottom, I've added links, and I will share this slide deck a little bit later. And I'll leave you with this guy. Thank you.
All right, thanks a lot, Matt. Great presentation as always. If anybody has any questions for Matt, go ahead and throw those into the Q&A chat at the bottom there. There's a little Q&A icon. You can ask him, just type those in right now and we'll try to get them to it. There is one question in there, Matt, if you want to tackle it. Looks to be a VQL related question. For VQLs such as IOC inside MFT detector, and this might be a question better for Mike, but for VQLs such as the IOC inside MFP detector, do you plan to implement a service that provides IOCs such as ISSP, MISP, or Open CTI?
Yeah, exactly. So for what I showed you in DetectRaptor, probably not, but yes, in short, yes, we do have artifacts that can do that. So yes, it's really quite easy. If you want to look at an example of like how to pull down a web, so like building the artifacts, the examples I've used are just Python, right? So you can go and have a look at maybe have a look at the hijack libs or the lol drivers one. And essentially what I'm doing is I'm reaching out to their site and pulling down like essentially a JSON that I'm then filtering and building an artifact with. So it's simple, yes, in short.
Excellent.
Yeah, and yeah, Robert, like, yeah, you can just like fork it and like steal it, mate. Like that's the whole point. It's on the internet and it's open to everyone.
I got a couple of questions in there as they're coming in. This is a little, maybe a little too vague. Is this already integrated in Rapid7 solutions? I don't know.
Yeah, like, so I would say I would influence some of the Rapid7 solutions. I don't think that would copy my public shanky stuff, but yeah, like not this exact detection, but I think that, yeah, we would definitely be looking at like implementing stuff. And for example, our IR, we use some of this stuff, some of these queries as well. We filter them. The whole idea is our IR team are experts in Velociraptor, right? So we use a lot of content from a lot of places and deploy them like with expert knowledge.
Got it. And then Robert Wiebner is asking, if I want to build my own detect raptor workflow, can I take the detect raptor workflow as an example?
Yeah, definitely. 100% open source.
Great. All right. Matt, I think you're off the clock. Thank you very much. Wonderful presentation. If anybody has any follow-up questions for Matt, be sure to throw those into the Q&A and we can forward those over to him. Thanks again, Matt.
Yes.
All right, before we move on to the next presentation, and we did finish this one just a little bit early, I just want to, kind of share some of the flavor of VeloCON with you guys. Just reading through the chat, just the places that people are logging in from: Nigeria, Switzerland, Argentina, Texas, France, Ontario, Canada, Detroit, Aberdeen, Scotland, Germany, South Carolina, Florida, North Carolina, the Czech Republic, New Delhi, India. We have someone checking in from Finland, another person from Algeria, that's two, Melbourne, Australia. I'm sure we have a ton of people logging in from down under, Virginia, Brazil, Bogota, New York, Estonia, Turkey. We have a comment here that Matt is the GOAT. So congratulations, Matt, on that. Ireland, Virginia. So keep it up. Pop into the chat, say hi, let us know where you're from. I love seeing the international flavor that we're getting from this event. There's another new question that just popped into the Q&A, and it's a common one that I'm seeing a lot. One, is there going to be a replay? Yes, there will be a replay. And is this streaming somewhere else? And the answer to that is yes as well. We are simulcasting this event all day on YouTube. So the easiest way to get it to it, I did share the link to the YouTube stream in the Q&A. It's one of the first Q&A questions that was asked. So if you go back in the Q&A, it should be there. But really, rather than kind of dictating a very long URL, the best way to do it is to just search for us on YouTube, search for Velocidex Enterprises. Do not search for Velociraptor. You're just going to get a bunch of dinosaur videos. Search for Velocidex. It'll be the first channel that pops up, and the live stream should be right there, right at the top of the page. All right, Mike, are you ready to go?
I am. Can you hear me?
I can hear you loud and clear.
Oh,
So
very good.
I'm gonna hand the baton over to you. I'm gonna give you a quick intro as if you needed one, but I'm gonna give it to you anyway. So as everyone knows, Mike is the brainchild of Velociraptor. This is his baby after all. He has over 20 years of experience in applying in developing novel incident response and digital forensic tools and techniques. Let me just bring up your intro screen here so everyone can see your beautiful mug. Your beautiful mug. Oh, sharing now. So never mind. I'll let you have the.
Oh, sorry.
It's okay.
I just
Mike has
shared this.
previously worked in the Australian Department of Defence as an information security specialist at the Australian Federal Police, specializing in digital forensics, network and memory forensics. And Mike now works with Rapid7 to support and develop Velociraptor, which, as you all know, is an advanced open source endpoint visibility tool. So, I'm just going to hand it over to you, Mike, the one and only Mike Cohen.
Sure. So, hi everyone. So I thought that I would speak today about just take an example of a CTF. As you guys know, we were doing the Black Hat training just last month, and one of the exercises from that was this CTF exercise, capture the flag, which actually Matt had originally written for us, and it was a big hit and quite a lot of fun. So we had a lot of fun, and so I thought I would go through it today on video so that you guys can see how to use Velociraptor, in a sort of a real case. It's kind of it's a little bit contrived, but it is. I mean, Matt has written it to be very similar to a real case. So so I've just got here as the CTF server, which is just so we're not going to go through the deployment too much. But I just wanted to also just point out a couple of things that are a little bit new with the recent version of Velociraptor, and some of the steps for installation that are a little bit different. So let's just start. So over here I've got our CTF server, and normally when you have like a lot of different Velociraptor servers, you kind of want to have a little bit of customization. As you can see here, this is the VeloCON org. I've got a different organization here, and if I look at the different orgs here, then you see I've got a whole bunch of different orgs, and I use that to separate out the different cases, I guess, in this case. And the way that we were doing the CTF in the training course was that the different teams had their own orgs, and so they could all interact with the same server, and then compete with solving the case. But I like to also always customize this, and I've shown this before, but I'm just going to show it again. And you just have to kind of click this, customize this welcome screen, and then it just takes you to the artifact editor here, and this is where you kind of can edit the artifact. And down here you can see there's the template which has the HTML, and then it creates a custom version of the welcome screen. So that is really helpful. I mean, even if it's just a word or something small, not just because it looks pretty, but because when you have a lot of different servers, you're like, which server am I on right now? It's just confusing. So it's good to be able to distinguish them and customize them just a little bit so you can tell. All right. And then the other cool thing is that when we deploy a new org, it's actually pretty straightforward. All we have to do is, so we create a new org. We have to switch to the root org. And then at the root org, we just run a server artifact that creates the new org, right? And then we just give it the parameter, which would be the name of the org, and it just creates the new org. And then immediately we can switch to it. And once we switch to the new org, so now we are in this VeloCON org, right? Once we switch to it, then we can now run another server artifact to create the MSI, because we used to have a very long, complicated process for creating the deployment packages, but now it's very easy. All we do is we just, in the respective org, we just create the MSI. We run this, just search for MSI, click create MSI, and just go, and it will just create one, and it automatically repacks it and repacks the config into the MSI, so it all just works. So then we end up with, a file here. And then what I do is I will download this file, right, like this, and then I can use that to deploy it on all the different endpoints. But just to make it even a little bit easier, then I take the MSI file from here, and if I look at the artifact, I've got this upgrade artifact, which is the admin client upgrade, which we can use that to upgrade remote endpoints. But we've got that tool setup screen here, and then I just upload the MSI into here, right? And then I get a URL. So as you can see, the URL here is kind of like a random number, but all I have to do is share that URL with someone, and then they can just curl that MSI over and deploy it. So it becomes a very easy way of deploying. Does repacking the MSI break the digital signature? So the MSI is not signed. It just contains the config file and the proper binary. So we don't really change the binary itself. The MSI itself is not signed, but then the binary is signed. But that's a great question. Yeah, cool. All right. So I just wanted to show this is a little bit different from previous times, and I just wanted to show how quickly it is to deploy a new org and a new MSI. It's all very streamlined now. All right. So we have a case. So let's say that we have a case and we don't know what's happening. Like, let's say we are new on this engagement. We don't know what's going on. So we've deployed the MSI. We have about 200 different clients out there, and we don't know much about it. So how would we start? And this is one of the interesting things with Velociraptor. There's just so much capability, and new users, they kind of get a bit overwhelmed. Like, where do you start? What should you collect? There's so much. So that's why I wanted to go through this example and just kind of like work through step by step and try and it's not necessarily the most complex example, but it's good to watch, people do this, right? So let me just put that over here. Sorry. And where was I? Yeah. All right. Okay. So first of all, let's start up. Oh, can't see them both at the same time. Sorry. Yeah, that's better. Okay. So I don't know anything about the environment. So the easiest thing would be to start scoping the environment. And one of the first things that I would do is just have a look at what users are on each machine. So the easiest way would be to just collect all the users from all the machines, right? So I'll know what users are on the environment, right? So I will create a hunt, and I'm just going to look for users, and I'm just going to run it everywhere. And it's telling me that there's going to be like 200, clients affected. That's fine. And I'm going to run it everywhere, and I'm just going to search for users. So I'm going to start off. It's a Windows environment, and I'm just going to get all the users. And this artifact collects the users from the registry, and also it uses the APIs. So it just basically tells me all about the users that are on this machine, right? So I'm going to go ahead and just do that. And I just do that just to kind of scope the environment and see what's happening. And so it's going to go off and it's going to get a whole bunch of users. All right. So it's doing this hunt. We've got 200 machines. It's going to take about this much. So now we have all the users from all the machines, right? So there's not too many users. There's a lot of machines. So, and typically in an environment, the users will be like, logging into different machines, and there'll be a bunch of different users. So what I want to do is kind of try and find the unique sort of users. So this kind of like stacking kind of operation. So this is all the users, right? But I don't really care about all of that information. So the first thing I do is just kind of like reduce that information. So I want to see the name of the users and maybe the UUID, which is the this thing, the seed. And then I want to see the M time because the M time here. So if the APIs, if it's coming from the API, then this doesn't feel it. But this M time is actually coming from the registry key of the profile in the registry, right? So it's a good indicator to when the user first logged in, because when the user first logs into a machine, then it creates the profile in the registry. So that's the last time the user logged in, right? So every time the user logs in, it touches it, so it modifies it. So that's an M time. And then I just want to, and I'm going to have the same users across all the machines, so I can just do stacking. So I'll just count it group by name, and some of them are empty, so I'm just going to remove the ones that are empty because it's not very interesting. So when I do this, it's going to go through and yeah, some don't have a name, but it's basically going to go through and group out all the different ones. So again, it's just looking at the results that are just collected and just doing processing. And straight away, I can see something like a bit odd about this environment, right? There's a lot of, in a normal environment, you're going to have a lot of users and they're going to be logged on into various machines. And then depending on, the environment, some users will be logged on to only one machine, some will be logged on to several. So you're going to have, a number of, different behaviors. But in this case, we've got this Win support, which is already just logged into one machine. It's not necessarily like super suspicious, but it's something to look at. And then with the list of users, you can then have a look and see whether these users are valid for the environment, or if it's local users or whatever. So this is just the first thing. It's kind of interesting, but the other interesting thing is let's try and find out when these accounts were created. Like, let's see when were these accounts created. Now, in this case, I might compare it to AD if it's a domain user and a local user. But if I wanted to just look and see, when the account was created, I would look at the SAM on the machine. So I'll analyze the SAM. So let's do the hunt. And, I can actually just tick this in. That doesn't, that saves us a click a little bit later on. But we have this artifact here that parses the SAM. And the SAM is for local users. So domain users don't really have information in there. So that's already interesting for me, right? And so here is the SAM, and it's going to parse it, and here's the artifact that parses it. But let's just go ahead and just parse the SAM on all the endpoints. And so I'll go and do that. So here we go. So it's going to do that. And the SAM is kind of a registry hive, so it's going to look at it and parse it. And if I just look at some of the results, and so this is the type of information that we get. So it's a forensic analysis type artifact that parses the SAM, and we get information like last login date, when the password was reset, and which, if it's never been reset, it's kind of like the first time that it logged on, and then you've got the machine and the username and the account and all these kind of things, right? And then you can see, for instance, if the guest account ever logged in, things like that. So that's going to basically tell me all about these things. So I'm going to process that again and just have a look and see and see about this where let's say parsed v dot username matches what was it called? Win support. Win support was that interesting account name, right? So it's already showing me which machines. I know they only logged onto one machine already, but I've got a date, where they logged in from, and so I've got a little bit more information here. But I want to know when the account was first created. If I look at the let me just look. So let's look at that machine specifically. So here's the machine that I'm interested in, right? So I'm going to right click it, clipboard, and then search for it. And now I'm going to be able to see that specific collection. So I'm going from a hunt to a specific, specific thing. And this is the SAM, right? So, so now I can start to look at that machine specifically. So the next thing is to try and figure out, like, when did this account come from? Like, when was it created? And you can see that the SAM is not exactly telling us that. It's telling us, when it was last login date and so on. And so a nice way to know when an account was created is to look at the birth time of the home directory, right? Because if we go to the VFS and then start to look at that machine, right? So here we are. So, we're going to have C drive, right? And then we have users, right? So when when an account is created on a machine first time, then it's going to create the the home directory for the user, right? So so here's the Win support. It's in the next page. Yeah. So here's the Win support directory, right? So, and then that's the first time the directory is created. So that birth time here is actually when is good approximation to when the when the account was created. So I've got a bit of a timelining here. So that's kind of interesting. So okay, so so we can try and extrapolate that to try and get the creation time for all the users on the domain, right? So we do the same thing. We want to get that birth time of that account. So how do we do that? How do we get timestamps of a particular machine? So of course you've seen how we can do it interactively, but it's not very scalable. We want to do a hunt. So what we want to do actually is we want to do a hunt using the file finder. So the file finder. So actually the purpose of this hunt is establish first user accounts creation, whatever, like something like that, right? And what we're going to do here is we're going to run the file finder. And the file finder is it's just a very basic one, but it's such a powerful tool because it allows us to do anything to do with files, right? So we could use it in different contexts. So like finding files, obviously, but in this case, what we want to do is looking at the birth time. So what we really want to do is we don't really want to get any files. We don't want to download them. We don't really want to hash them. We just want to list them, right? And that's really just kind of like the default, right? So if we go ahead and do that, then what it will do is it just does this very simple hunt. And you can see that the globe that we gave it was like C users star, which would be like the home directory of all the users. So when we do that, it basically, that's just kind of what it does, right? So it shows us the birth time of all the users. So if we, so now if we sort it, then we can see when the directories were created, on all of these machines, right? And then we can find out, so we can see like, where are the recent, users. There was a question, sorry. Yeah, okay. Yeah, so that is a way of, so now we can actually go and let's filter it using the table, Win support, and we can see, where that machine, where that user, let's go here, oops, calculate. Yeah, Win support. Support, and then we can see, well, did we see that users? We should see it. We can it's got a limit of 50. That's why. Where OS paths matches Win support, because it's only showing the first 50. Okay, so then we've got the birth time, right? How long does it take when threat hunt file finder when you have 20,000, 30,000 devices? It takes about the same amount of time because it just goes out and then it comes back. So it takes about the same amount of time. I mean, here it took, a few seconds, and it will take maybe a minute or so. Yeah. All right. So that's the next artifact that I would use, right? So that's kind of cool. So now we are already getting a bit of an idea of this Win support, user account. Seems a bit weird. It's pretty recent. If we look at when it was created, it's fairly recent. And on a real system, it would be quite, all the users would be like, so that was, 2 hours, 21 minutes ago. But then if we just clear that, so comment it out, then everything else is a lot longer before, right? So they've created like the administrator accounts and the users, all users, they're created like, they come with the system, right? So if we just like sort it, then then we can see this one's it's pretty recent, right? So Win support is like kind of the latest one, right? It's pretty recent. So it's been created really recently, right? So that's already kind of interesting to us, right? New accounts. And so, okay, so we're already like starting to suspect it. So then the next thing that I will do is I would want to know like, how does this user get used? Okay, so usually on Windows, people use RDP to get in. So I might want to know like about RDP activity, in the network, like who's logging into which machine. So to just get an idea, right? So I'm still scoping the environment. I don't really have a patient zero yet, but I'm just checking things out, right? So I want to look for RDP here, and so I'm just going to search for RDP, and then I have this really handy, artifact here that basically it's an event log artifact. It just looks through all the event logs and it just surfaces RDP logs. So it's pretty easy. It's pretty straightforward, but it's actually pretty effective, right? So there's a number of different things that it looks for, but it's just kind of like very, it just helps to bring out the important information kind of thing, right? So, so off it goes, it goes off and it's gonna look through the environment, and you can see that it has various fields here, the username, and then it has the type of thing it is, like there's a connection and there's another connection, and then there's log on successful, which actually is kind of what I'm looking for. Right? I'm more interested in successful logons, and I want to know. So the first thing that I will do is I'll be like, okay, I just care about successful logon. So I'm going to do a where, right? Description matches success. Because in a normal environment, there'll be a lot of RDP that are failing, because people are trying passwords. And that will just give me immediately things, the connections. So let's try that as a first, as a first example. And that, so we've got some initiates and log on successful. So we can actually just log on. That's probably what we want. So you can see all the successful logons that occur, right? And you can see a whole bunch of usernames and the source IP. So typically, when users use different machines, they kind of use the same kind of machines all the time. And when they break out of the habit, so they do something unusual, then it means something interesting, right? So like, let's say the username administrator typically goes to, these machines. So, maybe they're coming from this machine and they're logging onto another machine or whatever. So, you might have, so that might be a bit, different, right? So if we just showed like the username and maybe the FQDN. So that's the machine that receives it, and then you have the source IP. So these are, first of all, I'm just kind of like cleaning out the all of these fields that I don't necessarily care about too much at the moment. I'll just keep the client ID just in case. ID. Okay, and then so that would just kind of like clean it up a bit, right? So it's already kind of easier to see, and there's a lot of records, but I just want to now group by and I just want to see unique combination of, like, let's say username from source IP, let's say source IP. So that's a unique combination of where does this user typically come from, right? So, and then we can see immediately that we've got some fairly unique, combination. So administrator normally comes from that, and then suddenly this Win support pops up again, and it's coming from the same IP address. So it's already kind of unusual, right? So I'm already getting more evidence that this, Win support is also interesting. Sorry, there's a couple of questions. Yeah, I'll address them later. Okay, so we're getting more of information, but what's interesting now is that now we have this Win support, is that we can actually go in here and let's just remove that again. Actually, we'll just do another table. So we go star, where user name matches Win support. Okay, so let me just look at what this particular account is doing. So I'm just post-processing the same data that I've already collected. So I can now get an event time, 2 hours, 26 minutes ago, this user account logged in. We can sort it to find the earliest time, 2 hours, 27 minutes ago, right? So that's when they connected. So that's the first time that we're seeing activity from this user on the environment 2 hours ago, right? So that's already kind of unusual, right? So that's kind of weird. Okay, so which machines were affected? We already know a machine has affected this machine, right? Because this is the one that saw that username. So already we've got that information. So that's the earliest time. So that's cool. So now we know that this machine, let's find. So now what we've got is let's look at all the machines that are affected here. So we're going to group by client ID. Okay, and we already know there's only one machine, right? So there's going to be one row here, which is that machine. But what we're going to do now is we want to actually label that machine now, because we are now focusing on that machine. We know that machine is going to require more, investigation. So we can actually label it here straight away in the notebook. And what we are doing is we are adding the label. We're going to say, suspicious. Okay, because we're not really sure, whether it's suspicious or not. And what that will do is that when it renders this table, so all the rows that match, then they will, be labeled. So the client will be labeled. So that only that client, because there's only one row here, so that only that client becomes labeled. So this is a way of labeling machines as you're going along and doing, more post-processing, narrowing things down, identifying things. And then when you're ready, you're like, just label those things. So now if we just look at show all, and we can look for the label suspicious. Okay, so that machine just floats out. So now we can start to investigate it, do hunts on it and things like that. So now what I'm going to do is I'm not going to do a hunt across everything. I'm going to just look at that one machine because I'm focused on it. So now I can do more, more expensive things on it. So one of the things that I like to do is in the first thing, and a lot of people like to do it, is to just look at all the different event logs and run Sigma rules on it, right? So we can see quickly. And it's basically like a shotgun approach. You just say, just show me what's there. And the tool that a lot of people like to use is the Hayabusa tool. Hayabusa. So in order to get the Hayabusa tool, you have to go to the artifact exchange, because it's on the exchange, that artifact, right? So it's not built in. So you see it's not there, right? So before I do that, I need to go to the artifact exchange and download my tool. So you can run, this is going back to, the content talk that Matt had before. If you click that little thing here, you're going to go to the Velociraptor website, and we go to the artifact exchange, and over here we have a link here for to be able to get the the zip file. So we can actually do it manually, or we can just run a server artifact that just hoovers up everything from the exchange, as Matt showed that before actually. So I'm not gonna go too much about it. So again, I'm just going to do that, collect the server artifact, and this just says just bring it all in, import it all in. So it's going to come in. I think there's a few hundred artifacts in the exchange, and so here they are, right? So it's done. So now I should be able to see my Hayabusa. There it is, right? So I can now use it. So cool. So that was just a bit of a segue. So now that I have that set up, I can go ahead and run that Hayabusa tool. And so it's actually it's a tool, and it's it will go ahead and download it from GitHub and unzip it and all these things, and then and then it will deploy it to the endpoint, run it. And the thing about Hayabusa is it's really useful, but it's quite a heavy tool, so it has a lot of rules, and it takes a fair while because it's got to look through all the event logs, and then it tries to match the Sigma rules that it has. It comes with a bunch of Sigma rules against the the event logs, so that's kind of what we want. We just want a shotgun approach, so it's like least effort, but but it is kind of expensive, so I typically like to kind of narrow it down a bit, and it's going to take a little while. So while it's doing that, we can think about other things to do here. Okay. So we can look at, so we've got the RDP auth. Okay, great. And yeah, and then, this one, you see it's downloading it. It's going to run it, and it will, produce all the rules. So here we go. We're starting to get all the rows back. Okay, so it's done. All right, cool. Didn't take too long. All right, so it comes up. The first table is it's not that interesting. I'll get rid of that. And over here, we have the results, right, from the Hayabusa results. So the first thing that you'll notice is that it actually has a bunch of, so it's got 1,700 rules, 1,700 matches. So it's a lot, right? It's a lot of false positives. So the first thing that you can do with Hayabusa is to look at the level. So if you sort by level, that there's different levels of the of the rules. Some of them are high level, some of them are low level, and so on. So if we just switch over to okay, if we just, so we've got, these are the high ones, and immediately we can see straight away that we've got some interesting stuff going on here. So there's some PowerShell stuff, and then we've got Explorer stuff, and so on, right? So straight away we've got things that are surfacing with, and that's the beauty of Hayabusa. It just brings out things straight away, right? So here, for example, I can see that I've got some PowerShell running here, right? PowerShell ISE. So that's already sort of interesting, right? And then these are the high ones, right? These are probably false positives. Right. Okay. And so one of the so what we can also do is just group by the rules. This is what the rule title, because that also shows me the unique rules that are running that are detected, so that reduces the number quite a lot. So like now we've only got 92 instead of 1,000, 1,700. So again, we're going to look at the high to medium, the critical ones, the high ones. So log cleared, and then we've got suspicious execution of Windows Error Manager, and then we've got a usage of renamed sysinternals tool. So that's quite interesting. we've got a proc dump, right? That's also quite interesting, and it's actually running off something called PD. The executable is called pd.exe, but it's really proc dump. So that's already quite interesting. Someone is trying to dump process memory, and they renamed the tool to pd.exe, and it's actually a sys internals proc dump tool. So that's already quite weird. And again, look at the other red flag. The Win support user again pops out, right? It's actually interesting already, right? And then we can see, you know, all kinds of interesting things like, you know, this is it's trying to dump LSAS, right? That's already quite interesting. So we've got all kinds of interesting things going on. And this rule is also interesting. Someone's disabled Defender, all already quite interesting, right? Potential tampering with IDP related registry keys because somebody ran this command which turns on the keys, right? So these are all Sigma rules. Now Sigma rules are actually pretty easy to bypass because they're pretty brittle, but they do help detect those really low-hanging fruits, like in this particular attack, right? User added to the admin group. That's a big one, right? And again, we can see that the timeline is going to be, you know, similar as well. Okay, so Hayabusa sort of just tells us, you know, quickly what we are doing, right? So what we can actually do next is let's look at some of the files that are on the machine, right? So we already know. Let's go back to the time. So we know like the time was like 2.5 hours ago. That's when things happened, started to, you know, go wrong. So we can just quickly just get the MFT, right? But we don't want to get all the MFT. We only want to get the data, things that have changed after, you know, let's say 2 hours ago. So okay, so that would make it. So down here we've got 0, 9, 13, 14. So we'll go up to 0, 9. So this is UTC, right? So 0, 9, 13. Let's say 12. Okay, so that's like maybe 11. I don't know. So it's a little bit like that, right? So so now when we do that, that will pass the MFT and show us all the files that, you know, have, you know, been created or interacted with, you know, after that time. And so we already can do that. And then the other cool thing that I like to do is prefetch. That's a very you know, pretty standard one because it's easy to know, and it tells us a bit about what executables, you know, ran. So I do that as well. And then, you know, maybe also the USN. So just do that. So no, not the copy one, the other one. So the USN tells us about files that have been changing. But again, we don't care about files that changed, you know, more than 2 hours ago, because you know that this attack happened, you know, 2 hours ago. So so what we could do is just limit it to, let's say, the last, you know, day or so, right? So it's not too much, right? Okay, so then we, you know, that kind of narrows it down a little bit. So let's have a look at some of the MFT. Calculate. Okay, so here's our data, and you can see that, you know, there's a bunch of you know, files here. And this is where, you know, the detect raptor is going to be useful. Let me just start, comma, and then let's look at, you know, the time. Let's look at created time. This one. Let's just narrow it down, and let's remove the limit. So that already shows us, you know, a little bit about what files are, you know, created, you know, on this machine. And then, you know, so we can take a look and see, you know, And then the other thing, so while this is happening, you can see that there's a bunch of edge activity going on. That's also quite interesting. So something's happening here around edge. So that's the administrator, browsing. So there's always files happening around edge. But let's say what okay, you see there's some interesting stuff going on here. What is happening around the suspicious user? We're in support. Okay, so now we can filter that out, and straight away we can see, okay, so the user logged in, so that's not surprising. What else is going on with that user, right? So then we have some things happening here. What else can we see? Oh, that was it. We saw something here. So we see that they downloaded some files, right? pd.exe. That was kind of interesting. That ties up with this process dump that we saw before, right? So that's kind of interesting as well. And you can see this dump creds.ps1. It's also quite interesting. Straight away, we've seen some interesting scripts being downloaded into this user's home directory. So already we can now go ahead and try and fetch those files, right? And we can jump in with the with now that we know where to look, right? It's going to be on the desktop as we've seen, and I can just like recursively refresh that thing, and then go into the desktop, and no, was it documents? Where did they download it to? Oh, downloads, sorry, in downloads. And here I've got my binaries already. So that's kind of interesting. So we can collect that dump creds. That's already quite interesting. I look at the preview here, and immediately I can see, let's just convert it into text. There's a script, that looks quite interesting. This command here, set MP preferences, that disables, Defender. And then we've got the dump of LSAS. So again, this was what we saw again with the Hayabusa output. We saw that in the event logs. That was kind of interesting as well. So it corroborates, right? It all kind of works together. And, this is the script that they probably wanted to run or were running. So that's also quite interesting. But now we get to a question of, well, how did they actually get on this machine? Like how did we know that the user logged into it? And the user suddenly got created, and where did it come from? Right? How did the user get there? And this is often the interesting part about these kind of investigations, to figure out the initial compromise vector. How did the user get there? So let's go back and see. Let's do a process listing, right? So we know that the user, used ISE, which is a PowerShell ISE. So we can go for maybe a PowerShell ISE artifact. We have here. So this artifact from the Exchange, it basically goes and searches for autosave files, and then we also have some, PowerShell. So we can do that one, and also we can do anything to do with PowerShell, right? We've got so we got the autosave, but we have the console, the readline, PS readline. That's a useful one. So that just tells us the history, so we can see what they typed, kind of thing. So let's grab that. So, with this autosave one, we've actually got, so this one is when they added things in PowerShell ISEs, and it's autosaves the editing window. So if they're working on a script while they're, trying to build their not tool, but their attack kind of, sometimes they write it into the script. And so we can see, what they're doing here. So we can see what they've done, and the read line is also similar. this is the shell history of PowerShell, right? So as they are typing into history, we can see there, it's basically the same as bash history, right? So it's not always there, but if it's there, it's kind of interesting, right? It's good that, we can see it, and we can see, this is the administrator, user, and yeah, we don't have one for the, no, so they use PowerShell IC, so we don't have anything for them. So that's also helpful. The next thing we could do is maybe a PS tree, right? So with PS tree, we're going to see all the different processes. And this is where it becomes interesting to see. So we know with PS tree, we can see over here the call chain where, where each process came from. So this is a good place to start scanning for, we know they ran PowerShell. So let's see if we, if we have any PowerShell processes running, right? So we have a bunch of PowerShell processes, running here, and we can see this is quite an interesting one, right? We can see them running. So this is the interesting user, right? So they're running curl, and and then PowerShell, right? And yeah, and so we can see, like, the processes are still running, are still alive. Okay, and then we can see here actually that they're setting up some, installing some services, right? So this is going to be the next part, like some backdoors or whatever. And this is where they dump the LSAS, so we know that. So now we're getting more of an idea of like what's going on, what happens on the system. Now, but we still don't know where they came from. Where did they come from? So let's look at the prefetch that we collected earlier. And prefetch is a nice source of evidence because it tells us about when binaries ran, right? Different binaries ran. So so if we can look at the times, we can actually limit the times. Then we can see, which times are. Let me just actually collect the timeline one. So this is another example. This timeline one actually just shows it in a slightly better way. So now we can, time bracket it. So we can say, when did this occur? So we can look at the more recent ones and go, and go from there. And quite quickly, we should be able to see all the interesting executables. Let's see. Okay. So this is our, pd.exe that ran, right? So this is the suspicious one. And what happens before that? So a little bit before that, well, we had Notepad, we had the PowerShell. So we know about these things. And then let's go back a bit more. We have some WordPad activity, so that's also kind of interesting. We don't know who's running these things though, so we don't know the user that started it. But anyway, this one is interesting as well, net.exe, because that is in reg.exe. So reg.exe is always interesting to see because it's kind of like a command line tool. It's used in scripts, but generally not used that much. Because it's like a command line tool, and most like a proper program would use the API, wouldn't use the command line. So it's always interesting to see that in an edge and so on. So anyway, you can see that it's kind of interesting. We can look at all these different things. But what I'm actually want to see here, so we've got, see if I can find it. So this is interesting, but it doesn't tell me a lot of information about, because I don't know anything about the command line. I don't know who ran it or why. So this is why prefetch is not super perfect. All right, so what else did I wanted to show? Okay, so let's go back to our Hayabusa, and Yeah, and if we look at that result, then we could see. The notebook. Yeah, and so this is where it's actually telling us a lot of information here, but it's coming from logs. The interesting thing is where we got. Let's look at the high ones. So we can see that they switched off the detector. We've seen the Windows Defender. We've seen the registry, the RDP commands, and then we can go ahead and see. Let's see what else. Yeah, the dump memory. What else? Yeah, created this DNS query. Got what else? Oh, so this one's interesting, right? So the service is installed. So we've got a service installed. That's also interesting. So this is the kind of thing we basically look through and see, what would be. That's when when the user logged on, and we're building this timeline from that. Let me just see what I'm supposed to find here. Yeah. What else can we collect? Services. So we know that there's some services created. So let's see when were they created. So those event logs. Yeah, services. So basically just kind of collecting all kinds of, these, let's see. So we looked at let's look at the US. We collected the USN, we haven't looked at it yet. So let's look at the USN. So the USN is kind of, tells us whenever something changed on the system, right? So if we search for any file that ends with a prefetch, that will actually show us where. Sorry, let's just look at all the USN results. So that just shows us whenever files are interacted. Now, if you've got USN, that's actually really helpful because it gives you a huge leg up in finding, when files were interacted. It tells you a lot about the system. So, in here, for example, like if we want to know when an executable was created, whenever anything to do with an executable was modified, which is always very useful. So we can simply search for something like this, and that will tell us whenever an executable was created on the file. Now we know that the file system had a pd.exe, and so within that time range, it's telling us a lot of information about when files are introduced, when executables are introduced to the system, and it reduces that that list a lot. And if we also search for so here we've already got this is something to look at as well. It's a hard link. Okay, but then if we look at anything in the Windows directory, then we've got this file here, right, which was added to the Windows directory. So that's also quite an interesting one. There's a file that's created. It's called Not Suspicious. So again, we're going to look at that file. It sounds interesting. And then around about and then if we sort it by time, then we start to see what's happening around it. Another really cool thing that we can do is look for something that ends with a key, right? And that's typical for PS exec because it shows where the file ends with a key. There we go. No, hold on. Key ends with a key. Yeah. Okay, so we're running out of time real quick, but I just wanted to show you guys. Basically, we've kind of built up, an idea of what is happening here. But this one is what I was kind of trying to get at, and we've got a PSExec file that appears in the Windows directory. This one is appearing from PSExec. And this is a really useful indicator that PSExec gives us, because it actually shows us where the connection is coming from. And this is the host name of the source of that machine, where the machine came from, where the connection came from. So whenever someone uses PSExec to move around the network, looking for this in the USN journal is really useful, because it tells us, where this is the host name of, of the source machine. Every time they use PSExec to connect, it will create one of those keys. So now we've got a timeline of whenever they used PSExec to connect to the machine, right? So then we can, look and see what they've actually, done during that. So to summarize, I guess, because we're kind of running out of time a little bit. So we've started off from hunting across the environment to try and get some idea about, what the environment looks like. We found something odd about the environment and the users that are, a bit different. And then we found that the users were created fairly recently, and they're local users. So we used the SAM to analyze that. Then we used file system properties to try and figure out when the user account was created or first used on this machine. And then we went into event logs, started to analyze the event logs to figure out where the IDP came from. Then we can identify the suspicious user. Then we focused on that machine that was compromised. We went through the Hayabusa to try and surface very quickly anything in the event logs that is suspicious. And it's kind of like a first pass, very easy. And then once we do that, then we can start to look at other forensic artifacts and timeline and time box them based on the timelines. The MFT, we can see when files were created. So we could see those PowerShell files being created. We could see the PD.exe being created. And then the prefetch corroborates with that. So we can see those PD.exe executed. So we know that LSAS was dumped. The other cool thing that I would do is also just a bit of SQLite. With SQLite, we can see the SQLite Hunter is actually a very easy artifact to run. If we just run it without any arguments, then it just goes ahead and pulls out all the Chrome history, all the history results, so that right away I can see things that are happening with the fave icons, things like that. But in terms of history visits, and I know that my suspicious, this is our Win support, and we can see quite quickly what browser activity Win support, is doing. So he's doing like, looking around, but then finally we actually can see that they use the browser to fetch, the tools from that machine. So this is the browser artifacts. And if we look at browser downloads, then we can see that PD.exe coming from that server as well, right? So we know now where the machine, the watering hole came from. So these are kind of the artifacts that we're doing, just looking around and trying to reconstruct what the user is doing. One last question that could be asked is that, so we know that this user is compromised, it dumped LSAS, but we also, want to know whether they accessed any information on this machine, like while they were logged in. So we know that they logged in with RDP, so they had an interactive session. So one of the interesting things that, that we might look at is the recent apps. So we can see like what they were looking at, and also link files. These two things are useful to reconstruct user activity in the UI. Right? So when the users are, in the UI, what are they actually looking at? In this particular case, because we know that the user has, interacted with the desktop, then we want to know whether they looked at any particular, things that they shouldn't be looking at. So in, there we go. Did we do the recent apps? MRU. Oh no, that's the macOS one. Recent docs. Sorry, recent docs. So I was meaning to do that. Sorry. So the recent docs. So that looks in the registry to find like the recent, files. So it basically tells us the file extension, and then all the files, the recent files that this user looked at. So in this case, the .doc, he looked at these files: competitive doc, password.txt, the txt files. That's the recent. So it's basically like the ones that in the UI. But it helps to build these kind of cases to say that, hey, that user has actually opened those, those docs or those files. And this link analysis does the same thing. We can see here, essentially where the user has kind of opened the different different files on the desktop. Okay, so anyway, that's kind of like a bit of a scenario that I just went through. We kind of like, brushed a little bit through it. You can obviously, in a real case, you build it out and you cross corroborate a lot of these findings. But just to give you guys an idea about how we sort of start to pull at that thread as we go through. I think that must be time.
Yeah, we're just about time.
Yeah, I don't know when I'm supposed to stop, but anyway, you can keep going, as for hours with this. But yeah, hope it gave you guys a good idea about how to use Velociraptor in a real incident. If you guys have any questions, and you can ask. There's a few questions here.
Yeah, there's actually a ton, Mike. It might make sense if maybe you answer those.
Yeah, later.
Kind of like in your spare time as we go through. I want to break right now so that we give people enough time to go grab a cup of coffee or something.
Yeah, sounds good. Sorry, I went a bit overboard there.
No worries. I said at the beginning of the event, we're either gonna go above or below some of the time allotted. So
yeah, totally.
we'll adjust as needed. Yep. If you want to just give me the sharing permissions back, and I can move
yes.
along here.
How do I do that?
Just end your share.
Stop share. Yes, that's right. Here we go. Cool. Thanks.
Okay. And like I said, I want to give enough people time to make a cup of coffee, go grab something to eat, use the facilities, whatever. So how about we break until 11:05, which is a little bit past what we said on the agenda. 11:05 we'll reconvene. I see Simonor is already logged in and ready to go. So we're going to be ready to kick off the next section of the event. So thanks, everyone. We'll see you in a little bit. Okay, welcome back, everyone. We are ready to get started with the next presentation for VeloCON 2023. And I'm really excited about this one because this is we're doing a first here for VeloCON. This is our first presentation by a woman. She's actually the first of two ladies that we have this year giving us presentations. So really excited. Before I hand it off to Simonor, let me just give you a little intro on her. She's coming to us from Imperium. She is a former SOC analyst and incident responder. She has experience in building and managing security operations centers and security automation. These days, she serves as a product owner at Imperium.io. She is dedicated to creating more effective SOCs that proactively defend against cyber threats. So without further ado, Simonor, please take it away.
Hello, Carlos. Is my voice clear?
Yeah, you're coming in just fine.
Okay, let me share my screen then. Today I will talk about empowering SOC analysts with Velociraptor and revolutionizing live response and automation. Actually, as Carlos mentioned, I'm a former SOC analyst and incident responder. Nowadays, we are building a product called Imperium at Imperium.io, and our motivation is to design a SOC platform to help to create more effective SOCs in the world. So today my agenda is like this. I will mention the live response and how Velociraptors bring new features at this area and how we integrated Velociraptor in our product. And I will talk about a playbook and some use cases, and I will share our roadmap at the end. As you may all know that there are traditional approaches in incident response area, but they have limitations because in those environments, like we say, big companies, there are so many clients or endpoints. That's why it often involves manual task or time-consuming tasks. That's why we need to adapt the new cyber attacks in our nature. That's why we need live response tools like Velociraptor. And live response is for us the ability to access and analyze digital evidences on endpoints. And this the thing that SOC analysts want, actually, because SOC analyst has many guides or many screens in front of her or him. That's why we need a single glass of pane in our security operations center to effective incident response processes. And Velociraptor gives us the amazing thing, the VQL, because VQL gives us to adapt our methodologies very quickly and very flexible. Also, there's a nice community around there because there are so many artifacts in artifact exchange area. Also, I am a big fan of Discord Velociraptor's server, and we have so many shares here. Also, the Velociraptor's isolation, I mean the remediation and quarantine artifacts, is a big plus for incident response processes. As you can see in Velociraptor's interface, we can actually execute PowerShell commands, CMD commands, and bash commands or VQL commands in there easily. And this is a great thing for SOC analysts to achieve and to reach the endpoints, this kind of, and execute the right commands and give results. So these are in Imperium, we like to help SOC analysts, and we designed our product from a SOC analyst perspective. And you can see our high-level architecture architecture here, and in Imperium DFIR module we used the power of Velociraptor here to hunt cases or to respond cases easily. And I will share some screens about our DFIR module, and that's why because our mission is here to enable swift resolution of security incidents and the close response gaps today EDRs have. As you may know, the security operation and orchestration platforms mainly talks with each other around with recipes, and in Imperium, we wanted to change this because in SOC platform, mainly we need endpoints and we need endpoint logs, we need endpoint processes. And with Velociraptor, we designed to speak with processes for the incidents or cases. You can see our modules screen here, and there are agents part here. You can see the Velociraptor agents here, which is installed on endpoints, and I will share the details here. So we use the power of VQL here, as I said. For example, there is a agent here like Fedora server, and we can use the VQL as select info.systems. We can check the all information about the client that we want, and also it supports to isolate here with the in Velociraptor there is Windows and Linux and macOS remediation quarantine parts, and with it's prepared with a label. So here we need to create, set or remove labels for endpoints, and we use the server APIs features here to isolate, I mean the quarantine, and we call as isolate here, and we can easily isolate or remove isolation in this part with Velociraptor's label design. And this is the part of the terminal execution in Imperium. You can use the Velociraptor's terminal execution feature here. You may write the wanted command here, like get computer info in PowerShell, and we fetch the results from our Velociraptor server, and right here this we prepared this screen to use the artifact system.flow.completion, and we check the environment variable here to check the PowerShell or CMD or Bash artifacts. Also, you can run artifacts from the screen easily. For example, for Windows endpoint, we have 3 artifacts here. And when I run the Windows network listening ports artifacts here, I can see the results here and with specific clients. Also in the screen, we show the CPU usage and RAM usage because it's important for endpoint area. And this in the artifact basement, there is a artifact generic.client.stats, and we used this artifact to display this graphics. Also, with a server API monitoring feature in Velociraptor, we can easily see the which flows are finished and or which flows are continuing, and we check the flows and flows states from Velociraptor, and to give SOC analyst to see the task or share with other analysts to see what's happening this endpoint and who investigated which kind of artifact. Also, in this after the execution of artifact, some cases it fetches and collects some files in Velociraptor. For example, for a Linux endpoint, there's a Linux network packet capture artifact, and from with VQL you can check it easily. And from uploads, you can use the select star from uploads here, and you can see or download or share the pickup file with other people. So the other important part, the Velociraptor that we used in our product is designing or developing a Velociraptor app. And we have our marketplace, and our team developed a Velociraptor app here, and it used the Velociraptor's APIs features. This brings us the centralized incident response and orchestration, or there are plenty of tools and technologies in a security operations center, and you can easily automate it or integrate this kind of technologies with Velociraptor in your playbooks. All you need to is do downloading the app and configure your credentials. After that, we have some actions here that Velociraptor brings us, and after that, you can automate and dig deeper to endpoints or servers or anything in your environment. So this our playbook design gives us manual, automatic, or semi-automatic playbooks, and we can use input actions like APIs, webhooks, SSH, or other methods. Also, we have some filtering and decision utilities for this kind of decision-making capabilities. So this is a simple playbook that I prepare for this demo. For example, you get some alert on your casebook or on your incident area, and we have automatic trigger or label trigger or event trigger options, or you just want to manually attach a playbook to case or incident or event. So that's the first point, to get and to check which endpoints we have Velociraptor agents. After that, we filter the names or the specific endpoints or specific servers that we need to execute this playbook. And for example, after our incident responses procedures, we need to collect the Windows system startup items. With Velociraptor, we check this artifact, and we get this artifact results in this part. After that, we can format this info easily to check the file names, file hash, or program paths or file paths. If this the file path is the match the thing you searched, you can easily get the artifact Windows remediation quarantine, and you can quarantine your endpoint, and you can end your playbook. So our first use case is a rapid ransomware response. For example, you get a ransomware attack that targets your network, and you want to deep dive the incident, and you want to learn the IOCs. So Velociraptor's role here to deep dive into a compromised machine and collect related artifacts, and your SOC analysts or incident responders determine the IOCs, and you can scan or hunt for IOCs for other suspected machines. So what imperms or what automation playbooks gets here? For example, You can automate remediation tasks for a specific group of endpoint here, or we have databases to collect other previous events or incidents from other machines. You can easily sort and correlate entities for previous event cases with a compromised machine, or you can search is there any traffic from a compromised machine to another machines. Another use case is about advanced persistent threat APT hunting. So you know that you have targeted by an APT in your company, and you have all the threat intels, you have IOCs, you have techniques, etc. And Velociraptor's role here collecting artifacts for suspected endpoints, and Imperum's roles here to fetch artifacts results and send it to the FIR teams automatically. And after this thing, the FIR teams can investigate the files or artifact results, also search and correlate entities for previous events and case, and run a predefined incident remediation playbooks for determined case. For example, at the second step, you determine that there is an entity which can be related with APT group, and automatically you can run predefined incident remediation playbooks for these cases. So another case can be about vulnerability assessment. These days, you know, there are plenty of vulnerabilities, and sometimes organizations doesn't know that they have that program or the specific version of the vulnerability, and they need to check that is there any problem about this vulnerability in our endpoints. So in Velociraptors, with VQL, we can prepare an artifact for this specific vulnerability and schedule hunt for critical servers. After that, in Imperums, we can fetch results and create cases for this specific critical servers. And with automation and with playbook design, we can automate all communicating and page management procedures in playbook steps. Also integrate with other vulnerability management technologies that you use in your company. This brings us to effectively respond this kind of use cases, and also it's reduce incident response mean time, and gives and empowers SOC analysts in this kind of cases. So our roadmap at the end of this year to show the community edition to community, also design more real world DFIR use cases with the help of community also. We need sub playbooks here to automate repetitive tasks of forensic examiners' daily tasks. You can use sub playbooks to get rid of this kind of repetitive tasks. Also, we want to add more actions for our app. Also, integrate Velociraptor with our XDR module to automatically run Velociraptor's agent deployment or isolation features with a single button from a single event. Also, as I mentioned, automatic Velociraptor deployment for critical cases is another roadmap point for us. So today, that's all in my presentation, and I would like to answer your questions, and you can contact me anytime if you have questions.
Thank you so much, Simanur. If anyone has any questions for Simanur, please throw them into the Q&A box below. I'll give people maybe just a few seconds if they want to throw something in there. But yeah, just a wonderful presentation. Does anybody have anything for Simanur? Okay. Well, thanks a lot, Simino. I really appreciate it.
Thank you.
If we do get any questions, we'll be sure to filter them over to you. All right. Now we have a few more minutes before our next presentation. So I'm going to give our next crew a little bit of time because I think they're having a couple of some technical issues getting into the Zoom call. So in the meantime, I'm going to run a quick audible here and just kind of show people kind of our presence at Black Hat. Yeah, we were there this year back in August. It was a really awesome time. There was the first time Velociraptor has had any type of presence at Black Hat. Rapid7 usually does have a booth there and usually has a whole ton of events going on. But this year was special because we actually did throw a whole lot of effort behind promoting a Velociraptor and really making a big deal out of Velociraptor. You can see here, this is some of the displays that were all around the conference area at the Mandalay Bay Convention Center in Las Vegas. It's always nice to see the Velociraptor logo, out there. And then Mike himself, our one and only Mike Cohen, actually gave several presentations while he was there on the actual floor of Black Hat. Mike gave a couple of kind of in-depth trainings and kind of workflow presentations on Velociraptor. But the big thing was Mike actually had a 4-day in-depth workshop that was held there. I think we had like 16 people show up to that training, Mike. Is that correct? It was just an awesome time, really good set of content that we were able to dish out. I don't know if Mike, if you're currently on, but did you have any kind of thoughts or anything that you wanted to add from your time at Black Hat? You might not be on the webinar right now. It's all right. I'll ask him later. Let's see. Is are Falgun and Julia on? Yes, they are. Okay, awesome. So I'm going to go ahead and hand it over to you guys. Like I said, Simonor was the first woman that we had present at VeloCON, and now we're going to have our second woman present, Julia Pollock. I hope I'm pronouncing that name correctly, who is also going to be here with Falgun Kulkarni. I think they're going to do like a tag team, if I'm not mistaken. So just to give you a quick rundown on Falgun and Julia. Falgun, and they both of them, by the way, come to us from Aon. Falgun Kulkarni is a DFIR consultant at Aon. In this role, he has gained a wealth of experience investigating cybercrime cases with expertise in memory analysis, malware reverse engineering, and host-based analysis. Falgun has helped numerous organizations effectively respond to cyber threats and safeguard their assets. He holds GXFA, GCFA, and GCFE certifications. And then Julia is a DFIR software developer at Aon. She has experience investigating business email compromise, insider threats, APT intrusions, and of course, ransomware. Julia enjoys finding ways to automate her work, contributing to internal tools, and having jam sessions with her friends. Julia holds a GCFE and GCFA certification. So Julia, I'm interested to know what instrument do you play and can we jam together?
Thanks for the question. I play bass guitar and I'd love to jam with you.
Awesome. We'll have to set that up sometime. All right, I'm going to stop my share. I'm going to hand it over to you guys. The floor is yours.
Awesome. Thanks, Carlos. Thank you all for coming to our talk today. We really appreciate it. Falgun and I are really excited to share our research. Today, we're going to be talking about the Windows Search Index because we believe that it's the forensic artifact you've been searching for. So as soon as Falgun gets these slides up, we can get started.
Yeah, thank you so much for joining. Just give me a minute to get things set up.
I will say if there's one thing Zoom has to improve on, it's the slide handoff process during these webinars. It's not exactly the cleanest.
There's too many apps. Like we're used to WebEx and Slack. We don't really use Zoom that much.
And you guys have some extra time too. So if you guys want to kind of let it go and go into a little bit more detail than you otherwise would have, please feel free.
Awesome. Thank you. All right. I think we're good to go. Okay. So yeah, once again, thanks everyone for coming. We're really excited to give this talk with you. So let's get started.
Right. Hi, all. I am Falgun Kulkarni, and I work at Aon, delivering Strauss-Friedberg's incident response and digital forensic services. And in my role, I work on multiple cyber incidents such as ransomwares, threat hunts, and APTs. And I love to come up with novel ideas and perform research to improve DFIR as a whole.
And I'm Julia. I'm a software developer. I focus on DFIR and threat intel. And I work closely with Falgun and the rest of the DFIR team to help build tools that make their jobs a little bit easier. And if you're not familiar with Strauss-Friedberg, we work on a wide variety of cases. We work on everything ranging from large APT intrusions and ransomwares to small business email compromise cases and purely digital forensics cases for individuals. We're lucky to be part of a really talented team, and we're also lucky to be able to perform the kinds of research that we're here presenting to you today.
Right. So why should you listen to us? We have been researching Windows Search Index thoroughly, and we have a good understanding of this artifact. We were amazed by the wealth of information we could recover just from a single artifact. We wanted to share those insights with you to help you enhance DFIR investigations. So by the end of this talk, you will be able to understand how Windows Search Index can help you answer questions associated with files and folders on a disk, metadata related to non-existing files, as well as historical activity related to a user's internet browsing activity. So let's get started by setting the agenda for this talk. We begin by introducing Windows Search Index and how it works. We talk about how the database is structured and what data is stored in the Windows Search Index database. We quickly introduce changes introduced to Windows Search Index in Windows 11 operating system. Next, the most interesting part, and I'm sure you're going to love this one, which is the forensic value held by Windows Search Index artifact. And last but definitely not the least, we showcase Velociraptor plugin to parse Windows Search Index efficiently and at scale. So before we move on, I wanted to take a minute and explain what a forensic artifact is. So Windows operating system introduces features which are aimed toward enhancing user experience. So let's say, for example, jump lists can allow a user to switch between multiple files quickly, and prefetch can shorten the startup time taken by any application or program. But on the flip side, jump lists can also be used to prove file knowledge as well as file access, and prefetch can be used to determine whether a program or an application was executed or not. So similarly, Windows Search Index exists on a system for users to be able to search for multiple files, but then it can also be used as a forensic artifact. So let's get to know more about Windows Search Index.
Okay. So with that paradigm in mind, let's talk a little bit about how Microsoft typically markets this, the Windows Search Index to the average consumer. So the way that Microsoft wants you to use the search index is to use it as the search bar that you can get by pressing on the Windows key on your device. You can use the search bar to search across files on your system. You can use it to search across your web history, and you can also use it to search the web. Different apps will also implement the search index in other ways. So for example, Microsoft Photos will use the index to track changes to your files. If you are searching for a message that you maybe drafted last week and you don't remember where you put it, you can use the Outlook search bar, which on the back end is also using the Windows search index to search through the messages on your device. Cortana also uses the search index to provide search results, and there are many other apps in the Microsoft Store that will implement the search index in other ways. So let's talk about how this actually looks in practice. So let's say you created an invoice last week and you forgot where you put it, but you remember what it's called. So you search the search bar for invoice.xlsx, and then the search box is going to query the Windows search index that exists as a database on disk. Before all this happens, the Windows search service is periodically extracting information from files and index locations, and it's cataloging that information in the Windows search index. So the Windows search index will find the record of that file, and it will tell you, hey, your invoice is in your documents folder, and you will be eternally grateful for how helpful the Windows search index is.
All right, now that we know how Windows search index works, let's get to know what data is stored and how it's structured in the database. So basically, files and folders from two directories, namely C users and start menu programs, will be indexed in a database. Now, there is one exception here. Files and folders from app data directory will be excluded by default. And this database can be found at C, program data, Microsoft, search, data, applications, Windows directory. So let's see how this database looks like. Beginning from Windows Vista until Windows 10, the database sits in an extensible storage engine format, and the database is named windows.edb. An important point to note here is the Windows Search Index service will be enabled by default only on the Windows endpoint operating systems and not on the Windows Server operating systems. Windows.edb file contains a lot of tables, but we have identified 3 to be the most useful ones. They are system index gather, gather path, and property store table. Now, property store table is one of the most important tables, and we will be referencing it a lot in the further slides. And if you want to know more about these tables, we also have a blog post, which we will be referencing in the end slides, and you can always refer the blog post for more details on these tables. So let's get to know how windows.edb file looks like. When viewed with Nearsoft's ESE database view, we can see that all the ducks are in a row, meaning that each entry or each record will have a separate row, and every column represents a unique file property. But let's consider an example here. Let's say you are in a DFIR engagement and you are analyzing a Windows 11 operating system. Now you want to parse Windows search index and you go search for windows.edb file, but you couldn't find one. You ask why? Because Microsoft introduced changes to Windows search index in Windows 11 operating system. So now the windows.edb file is split into 3 SQLite database files, namely Windows GatherDB, Windows DB, and Windows USNDB. Windows USNDB is still being tested upon and is out of the scope of this presentation. So basically, all the data remains the same, but the format is changed from ESE to SQLite. So let's quickly compare how the changes in Windows 10 and Windows 11 looks like. as we can see on the left-hand side in Windows 10 or in Windows EDB file, all the tables are in a single database. But in Windows 11 or Windows Gather DB, we can see that system index gather and gather path are split, and they are stored in the Windows Gather DB database. And importantly, the property store table is now split into two, namely property store and property store metadata. And these tables are stored in the file name windows.db. So let's quickly take a look at how windows.db file would look like. We use DB browser for SQLite to view the windows.db file. And as we can see, all the ducks are not in a row now. So every record or every entry will have multiple rows, and we can see in the property store table, the work ID column represents a unique record or unique entry. And the column ID column represents values which can be mapped to their respective file properties in the property store metadata table. So let's consider an example here. In the property store table, let's take row 1, and we can see that the column ID value is 13. So when we map that value to the property store metadata table, we can observe that 13 represents system is folder. So that's how we know work ID 1 or record or entry with work ID 1 is a folder. And similarly, we can map the rest of the file properties to their respective values from the property store and the property store metadata table. Julia, if you're speaking, you're on mute.
I'm sorry, I couldn't unmute. It like the mute button like just disappeared. I'm so sorry. All right, let me go back. I kind of spoiled the surprise for you all. It's okay. So since Falcon was talking about how the Windows 10 database the Windows 10 database exists as an ESE database, unlike the Windows 11 index database, I want to give you a quick note about ESE databases in particular, because they can be a little bit difficult to work with, especially in a DFIR investigation scenario. So let's talk about why. ESE databases, or extensible storage engine databases, were made specifically for many near simultaneous transactions, or in other words, many database reads and writes happening nearly at the same time. What this means is that they can be dirty or in an inconsistent state because all those reads and writes are happening so close to each other. But the way that this database deals with that is by a mechanism that I am about to describe to you. So in a perfect world, a file would be created, and then the record of that file is immediately added to the search index databases. But like a lot of other databases, in the case of an ESE database, it doesn't work that way. And instead, when the file is created, a record is immediately added to a log buffer, which exists in memory. And that log buffer is pretty small. So once it gets full, the log file will be written to disk. However, if you experience a catastrophic shutdown, or if you perform a live image of a system, those log files may not be written to the database, which will result in a dirty database. And the reason why this is a problem is because a lot of the tools that we use in DFIR are relying on the fact that the database is in a clean state. So either if you run one of those tools on a dirty database, you'll either get inaccurate results because you haven't replayed those logs to the database, or you may not be able to parse it at all and the tool will just crash. Thankfully, however, there is a built-in Windows tool called ESCNT Util, and that's going to help you perform recovery, replay those logs to the database, and then repair it if it's damaged or corrupted. So I want to bring your attention to two commands in particular. /R is going to do that recovery and replay those logs, and then /P is going to perform that repair. There's a couple caveats to this tool. The first one is that you have to run it on an operating system that's equal to or newer than the one where the windows.edb or any ESE database came from. So if you're, for some reason, using a Windows 7 system to perform forensic analysis on a Windows 10 search index database, you're not going to be able to clean it because the Windows 7 ESE engine is just not going to be able to handle this newer version of the ESE database. The second caveat here is that some of you are probably catching on to this, but these log files will also contain record deletions. So if you're doing a true, deep dive into a system, I would recommend analyzing both the dirty database and the clean database, because you're going to get those records in the dirty version that you wouldn't get in the clean version if they're deleted. So if you're not able to parse the dirty database, you can just run the repair without doing the recovery for that first version. Okay, so I feel like that was kind of dense and technical, but hopefully this next part of our talk will be a little bit more interesting. Now we're going to talk about the forensic value of the search index and some use cases. So first, let's talk about the file and folder enumeration feature of the search index, and specifically what it can tell us about files and folders that exist on the system. So just to recap, whenever a file or folder is created in an index location, that file record is placed into the search index database. And that file record is going to include a lot of metadata, a lot of really useful metadata, including the full path of the file, MAC timestamps of the file, different file attributes like the file type and the file owner, as well as index gather time, which is the time at which the record was either created or subsequently updated. So let's talk about where this information might be useful. If you are familiar with incident response engagements, you might know that threat actors like to drop malware and stage files in subfolders of C users, so any user folders. Thanks to the search index, you can enumerate those files that exist in C users star. If you are investigating a user that may have wittingly or unwittingly downloaded malware or some sort of malicious files, those files are likely going to end up in their downloads folder. And thankfully, you can also enumerate that folder using the search index. Next, again, if you're familiar with IR engagements, you might know that threat actors like to create malicious startup tasks to gain persistence on a system. And those startup tasks will likely end up in this start menu programs startup folder, which is also indexed by the search index. So you can enumerate them there as well. Lastly, if you're investigating a rogue employee who's maybe created or deleted files that are important to an investigation, we'll talk a little bit more in depth about this later, but you may be able to enumerate deleted files using the search index. And some of you may be wondering, like, why does any of this matter if I have access to the system, right? If I can see the files on the system and the search index is just telling me what I already know. Well, what if you have a triage collection of the system and you don't actually have all the user files? You can use the search index along with other artifacts like the MFT to prove existence of files on the system without actually having access to those files. Okay, so let's move on to another feature of the search index that is really helpful for DFIR, and that feature is auto summary. Auto summary records partial file contents, and you may be thinking, like, this is the perfect feature for DFIR investigators. How can this not have been made specifically for us? Well, the reason that this exists is that so that users can search for a file using the file contents. So if you don't remember what you named a file, but you remember what you typed into the file, you can search for it using the search bar or the file explorer. So in this example, I hid the word pineapple in this search_test.txt. file, and I was able to search for it by searching for my keyword in File Explorer. One caveat of auto summary is that the file extension has to match the file type in order for auto summary to record the contents of the file. What this means is that auto summary is using a file extension to understand how to parse the contents of the file. So if you have a plain text file and you save it as a .pdf file, auto summary is going to expect to have to parse a PDF, and it's not going to be able to record the contents of your plain text file. One thing that Falcon and I observed in our research is that in Windows 11, up to the first 1024 bytes of a file may be recorded. And some of you are probably realizing this means that if the file is small enough, you may be able to get the full contents of the file. So let's talk about what files actually have their contents indexed, because it's not all of them. And I'm not going to read out this list to you, but there are some that may be sticking out. For example, if you're hunting for web shells in an IR engagement, .asp files have their file content captured by the search index. So you'll be able to view any sorts of IOCs that appear in that file just by looking at the search index. If you're dealing with a threat actor who is using .bat, .cmd, or .vbs malware, you'll be able to view the contents of those files in the search index as well. Lastly, if you're investigating a maybe an insider threat for maybe a corporate client, or maybe it's a internal matter, you may want to focus more on Office files like Excel files, docx, PowerPoint files, anything of the sort. And thankfully, the Windows Search Index is also capturing the file contents of those files as well. And lastly, I know that you're all on the edge of your seats wondering, like, can the Windows Search Index help me recover deleted files or any information about deleted files, or maybe contents of deleted files? And like many things in DFIR, the answer is it depends. In our testing was a little inconclusive, but we did observe that if we performed a live forensic image of a system, we were more likely to view file records, and they were more likely to persist in the database. However, if we performed a system shutdown or reboot, we were less likely to view those deleted files. However, we did achieve some success recovering those file records using this specific tool called WinSearchDB Analyzer. Even though our testing was inconclusive, the thing that you should take away from this is that if you have access to the Windows Search Index, parse it anyway and see, because maybe you can recover some deleted files or even deleted file contents from the index.
Awesome. Thanks, Julia, for walking us through one interesting aspect of Windows Search Index. And now let's take a look at another important aspect. So at times, investigators may need to discover a user's internet browsing activity, but they may not have the browsing artifacts at their disposal, or they may want to cross-verify their findings. So Windows Search Index can help in that as well. Windows Search Index will index activity conducted using Edge and internet browsers. One caveat here is that activity conducted using private browsing mode will not be indexed. So in Windows 10 or in Windows EDB file, interestingly, the successfully accessed URLs will be stored in the item path display column of the property store table, again, the most important table, and unsuccessfully visited URLs, meaning that if the URL did not exist, let's say, for example, 123 this website does not exist.com, or if the URL was visited without an active internet connection, then those type of accesses will be stored in either activity content URI or activity description columns of the property store table. In contrast, in Windows 11, we observe that irrespective of how you visit a URL, all the visited URLs will be stored in the system link target URL column of the property store metadata table. A quick caveat here is that we observe some of the unsuccessfully visited URLs may not be present in either windows.db or windows.edb files. So now that we know Windows Search Index can also enumerate internet browsing activity, the question has to arise, what if a user deletes their internet browsing activity? Windows Search Index might save your day. So we tested by deleting the browsing activity from the browser itself, as well as by deleting the app data folder of Edge browser. And interestingly, we were able to recover the entire history or the entire session with the URL being visited, the type of the access, as well as when it was visited. Now, how amazing is this information? Like, you don't even need to have any browsing artifacts at your disposal, and you will still get the historical as well as current internet browsing activity. But in contrast, in Windows 10 or in Windows EDB file, we found out that deleted browsing activity may sometimes be present in the database, but not most of the times. An important point to note here is internet browsing activity can also be present in the activity history feature of Windows Search Index. Now, you may wonder, what is activity history? So let's talk about it. Windows Search Index can also tell you when a user interacted with a file and using which application or program. So activity history feature will track file interaction per user. And importantly, if a file was renamed or if it's deleted, which is not existing on a disk anymore, and if that particular file was interacted with in some point at a time, then that activity will still be present in the activity history records or entries. So that's one way you can enumerate interactions regarding non-existing files. Isn't this cool? And the way you identify activity history records is by enumerating the system item type column in the property store table and looking for activity history item string in that column. One important point I wanted to mention is activity history is a subset of the entire user activity. So if an activity is not present in this feature, it doesn't mean that it did not happen. And again, like we mentioned previously, some of the internet browsing activity may also be present in the activity history feature of Windows Search Index. And remember, so let's get to know what exactly gets indexed. So let me give you an example here. Let's say I interacted with a PDF file using Firefox browser. Now, the full path of that PDF file, including my SID or security identifier, the start and end times, which also correspond to the opening and closing time of the activity, as well as the program used in the interaction. And in this example, Firefox browser will be indexed in the activity history feature. One quick caveat: the start and end times of activity history may sometimes differ by a few seconds, so they may not be the most accurate timestamps at times. And remember, I mentioned that activity history is a subset of entire user activity. So you may wonder what exactly or what activity is indexed in this activity history feature. So we tested by interacting with few common file types. If, for example, we interacted with text format files using commonly used applications like Notepad, WordPad. We interacted with PDF files using most commonly used browsers, as well as Adobe Acrobat Reader, and our day-to-day files like Excel, document, PowerPoints, and photos. So that activity will be indexed in the activity history feature. Another important aspect of Windows Search Index is that it will also store data related to Outlook and emails, but that is out of the scope of this presentation.
All right, so let's talk about how this actually looks in practice. How does this look if we actually create a file and view the record for it in the search index? Okay, so we created a malicious looking file, and you can tell that it's malicious because there is an IP address in it. And then we viewed the Windows search index. So first we viewed the activity history. We wanted to see if we could view the file contents. And since it was a small file, we were able to view the entire file contents as well as that super scary looking IP address. And then we viewed some of the other attributes. So from the search index, we were able to view our activity history. So we had the full path of the file that included the user SID. We also had the app display name, or the program that we used to open the file. We had the file name as well as the activity history start and end times, which corresponded to the times that we opened and closed the file.
All right, now let's get to know about VeloCider. So VeloCider is a Velociraptor artifact which uses CIDR, or Search Index Database Reporter, to parse Windows search index at scale. It will parse both Windows 10 and 11 database files. And in the artifact, we have set CIDR's URL to include the latest version or release. So you don't have to change the URL every time we release a new version of CIDR. So let's get to know CIDR in more depth.
Okay, so let's first talk about why our team created CIDR in the first place. During our testing, Falcon and I observed that though the GUI-based tools are really helpful, it's difficult to load multiple indexes at the same time for the purposes of comparison, which is what we really needed for our research. So our team created a command line tool that you can use to parse multiple indexes at the same time. So some features of this tool include the fact that you can parse both ESE and SQLite databases in the same execution of the program. So you can have a folder that contains both windows.edb and windows.db files. And just by running CIDR once, you can get output for all of them. It provides readable output of the search index. So it provides 3 different reports, and you can get them in either JSON or CSV format, whichever you prefer. It's really fast, so it enables parsing of the index for maybe a time-sensitive matter that you're working. One of the reasons that it's super fast is that it's written in portable Rust. It's open source on GitHub, so if you're so inclined, you can test out the tool and create issues or open up PRs. It's under Apache 2.0 license, and if you don't feel like compiling it on your system, you can download a Windows build from GitHub. So how do you use it? So first you call CIDR, and then you give it some options. So you give it the format. You can either do JSON or CSV, but it is JSON by default if you don't provide the format argument. You give it an output directory. So this is wherever you want your reports to land. If you don't provide it by default, they will land in your current working directory. You can ask for help, which will print this help message, and then you can get the version of the tool. And then you give it a path to your input directory. And I just want to emphasize that this is not the path to the actual database, but it's a path to the directory where multiple, or maybe multiple databases will reside. And that directory will be recursively scanned. So you don't need to have them all at the top level of the directory. So let's see it in action. Like I said, you call CIDR, you give it an output directory, as well as a format, and then you give it the path to the input directory. And as you see below, you will get 3 different reports. In this case, we have CSV reports, and the way that they're named is that you'll get the host name of the system, which will help if you're working with multiple different systems. It will help you differentiate the reports. You will also get the type of report, and then you'll get the date and time of execution of the tool. And last but not least, like I said, CIDR is really fast. And in order to showcase this, Falcon and I created this monster directory of many windows.edb and windows.db files, and it was nearly 6 gigabytes worth. And CIDR was able to parse all of them in under 22 seconds. So yeah, we're proud to say that it's a very fast tool.
Right. Thank you, Julia, for introducing us to such an amazing tool. Now that we know how Cider works, let's get to know how VeloCider works. So we begin by creating a copy of the original or live Windows Search Index database on the target machine to a temporary database. Now we do this because Cider will need a database to parse and generate results. And as the live or the original database is locked by the operating system, Cider won't be able to execute it. So that's the reason we create a temporary database and execute Cider on that. Next, we pull the latest release of Cider from our GitHub repository and then execute Cider on the temporary database. Now, importantly, these operations will only happen if and only if the size of the database is less than 2 GB and the free space in C drive is more than 5 times the size of the database or Windows Search Index database. You may wonder why these conditions. Let me tell you why. So Windows Search Index at times can get very big in size. So let's say if we are dealing with a 10 gigabytes of database and we create a copy of that 10 gigabytes database, we are utilizing 10 gigabytes of free space or unused space in C drive. Now that free or unused space may have some forensic evidence which may be valuable for your investigations. So that's the reason we have capped it at 2 gigabytes and check for free space in C drive to be more than 5 times the size of database so that we don't consume all the free space or like exceed or go beyond the free space which is available in the C drive. And I would like to invite you to read the description, the conditions, as well as the warning which are placed in the artifact before you use the plugin, because this is crucial for you to know how VeloCider works and what effect it may have on the target endpoint. So let's get to know results generated by VeloCider. Let's talk about the preparation and execution phase. As you can see, we will be able to observe which database was parsed, the full path of the temporary database. And if the database was in a dirty state, VeloCider will prompt you a warning. It will also provide you with instructions on how you can clean or recover the database. Once Cider executes itself on the database, it will produce 3 beautiful CSV reports. So let's talk about the files and folders report. You will be able to enumerate all the files and folders present in the database or which are indexed from the mentioned locations. Next, we have the Internet History Report, which will show you information about a user's internet browsing activity. And lastly, for the reports, we have Activity History Report, mentioning activity or interactions regarding existing as well as non-existing files. So how amazing is this information? And given the fact that you just need to click few buttons and all the information is available to you from just a single artifact. You don't need to extract the useful data from a large data set. It's already done for you. And I think this will save you a lot of time in the time-sensitive matters like Julia mentioned. Next, for VeloCider, we have 2 options or parameters. So first one is upload results. If you check this option, it will upload the CSV reports generated by Cider to the Velociraptor server. And this is how it will look like. So you get the full path of the report being uploaded and the system from where it's coming or where it is generated. Next, we have the collect Windows Search Index database option. So let's say for some reason you want to have a raw database, and if Cider for the given conditions did not parse the database, you have the option to collect the Windows Search Index database on the Velociraptor server. And this is how it will look like when you upload a particular file or all the files related to Windows Search Index database. You get the full path of the file as well as the system from which it is coming. So let's quickly see a demonstration of VeloCider. We begin by searching for cider. And as you can see, we have a beautiful description, how VeloCider works, the conditions which are put in place, as well as the warning, which I invite you to read before you use this artifact, because that is crucial. Let's see configuring parameters. Like I mentioned previously, you get two options. First one is upload results, that will upload the CSV files generated by Cider, if for some reason you wanted the raw CSV files. Next, we have the collect Windows Search Index database option, and that will collect the database or all the related files if you want to clean a dirty database or if you want to have a raw database for parsing it on the forensic tower. And you can use Cider itself to parse this database. So let's launch this artifact and see or take a look at the results generated by Cider. So first, we start with the preparation and execution phase. Like we mentioned previously, you will get the full path of the database being parsed. And if it is in dirty state, you will get a prompt as well as instructions on how you can clean that dirty database. And in this case, you can use the collect Windows search option to upload the files. And you also get the full path of the reports being generated by Cider. So let's take a look at files and folders report. Like I mentioned, you will be able to list all the files present in the database. Next, let's take a look at internet history report, showing all the browsing activity conducted by various users. Next, we have the activity history report, mentioning file interactions associated with current as well as non-existing files. So isn't this amazing and pretty cool? All you need to do is click few buttons and the beautiful CSV reports will be available to you on your Velociraptor console. All right, now that we know how VeloCider works, let's get to know some use cases of how Windows Search Index can help you in DFIR investigations. So you can even uncover a heist. If you are investigating a rogue employee, you will be able to enumerate the full path of the file in question, as well as partial or full content. And in this case, we know someone bought private jets and Lamborghinis. Man, I want Lamborghinis. Next, we have the activity history report, which can show you file interactions per user. We can also enumerate the activity start and end times, the program used to interact with the file or application, and the name of the file itself. VeloCider can even show you internet browsing activity. And for those who search their crime online, we will be able to catch them. Like we can observe, we will be able to see the title of the web page and when it was accessed, as well as full path of the URL which was accessed. Next, we can also enumerate initial attack vector or access vector. So sometimes employees may download legitimate looking files, but then in actuality or reality, they will be malware planted by threat actors. We also call this drive-by compromise. And if that's the case, VeloCider can show you internet history report and you can enumerate that activity as well. Next, if there is anti-forensics in question, and if a threat actor is really noob and Googles how to do anti-forensics, we will be able to discover that as well. Sometimes exfiltration can be difficult to identify. We have observed that threat browsers to visit the exfil site, and that's how we can enumerate if there was any data exfiltration in place or in DFIR engagements. And remember how we mentioned that you can even enumerate deleted file interactions. So we tested by creating a file, interacted with it, and hard deleted the file, meaning that file did not exist on the disk, and it was also not present in the files and folders report. But interestingly, we can see that we can enumerate the file name, when it was interacted with, the program used to interact with the file, as well as the user who interacted with the file. So isn't this information pretty cool? You get so many details about the file which is not existing on the disk anymore.
Thanks, Falgun, for that look into VeloCider and what sort of information you can get from those different reports. That is kind of the bulk of the technical part of our talk. I hope you enjoyed learning more about the Windows Search Index, and hopefully you will use it in your next investigation. So I just want to give you all some key takeaways that you can get, that you can take away from our talk today. So like we said, you can enumerate file and folder existence using the index, as well as you can also view partial file contents. You can view user activity using the index as well, which can provide file knowledge as well as important timestamps that tie to maybe activity of a suspicious user. Lastly, you can also get internet history, even deleted internet history, using the Windows Search Index, which you can use to also enumerate another part of a user's activity.
And why should you use VeloCider? Because why not? It's fast and easy to use Velociraptor artifact, which can parse both Windows 10 and 11 databases. So you don't have to parse them one by one. It can also show you analysis, or it can also show you important aspect of Windows Search Index, and it can really save you time in time-sensitive matters. Importantly, you get information which you can straight away take and make useful or insightful data from that information. And you can get your VeloCider plugin today. To scan the code, it will take you to our GitHub repository, and that's where you can find the YAML file, which you can use to create a new artifact in your Velociraptor console. We promise it's not a phishing attempt.
And if you weren't taking meticulous notes, or if you fell asleep, then that's okay. We also have a blog post where we have all the information that we presented to you today, specifically about the search index as an artifact. So we also break down some more technical aspects of the actual database structure. So if you don't want to scan that QR code, we also have the hard link there at the bottom. And if you're on Twitter, go ahead and follow us. We're at StrawsDFIR. We'll be regularly posting our thought leadership on that account.
I wanted to thank few people who helped us during our research. Partha Alvar and Carly Battle for helping us throughout the research and developing slides. And Oleg Dolgov, Vitali Reshituk for developing Cider in such a short amount of time. And lastly, I wanted to mention that our research was based on version 22H2 of Windows 10 and 11 operating systems, and Velociraptor version 0.6.9. We do encourage you to perform your own research, but it may differ based on the build numbers. So thank you so much for joining us, and we are open to questions now.
Falgun and Julia, thank you so much. That was awesome. If you're just, I encourage you guys to read through the chat. There's just some amazing comments in there based on your presentation. You guys also have a few questions in the Q&A. If you want to start to address some of those. If anybody else has any questions for Julia or Falgun, please pop them into the Q&A chat box. I see there's a few really interesting questions already in there. So really, you can tell there's a lot of engagement with this presentation. So thank you guys. Falgun, we're going to see you again after lunch.
Yes, sir.
For the other presentation that you're helping out with. But until then, thank you very much. Julia, thank you so much. We're going to give everyone a little time back. I originally had put 12:30 on the agenda as the time that we would start lunch. But I think we'll start a little bit early now. Let's reconvene back at 1 o'clock. So that gives everybody 40 minutes to grab a bite to eat, or depending on where you are in the world, a cup of tea or even breakfast. So please hurry back at 1 o'clock. We'll get started with the next presentation. Thanks, everyone.
I would like to address the questions.
Oh, yeah. But before we go, why don't you address some of those questions now, Falgun?
Yeah. Robert Weibner, sorry if I butchered that name, but yeah. If CIDR does not parse the database due to the conditions put in place, you are able to upload that database. But I would like to highlight that database can get very big in size, so that may cause an issue to Velociraptor server itself. But that won't stop you from uploading the database to the Velociraptor server, irrespective of whether CIDR parses it or not. You can even copy the original database. You don't need to create a temporary database. So that's a functionality Velociraptor will provide to you. If that answers your question. So go ahead, Julia.
I was just gonna address Hilko Bengen's question about configuring the Windows search index to store different types of files, maybe the ones that aren't stored by default. I don't quote me on this. I believe you can go into advanced options of the Windows search index and customize what is indexed. So you can actually add other index locations. And then I believe you can also change the settings so that those different file types also have their content captured. I encourage you to test on your own system if you can do that. I would like test right now live, but I'm on a Mac. But I can test on a Windows machine and get back to you later. But the Windows search index feature is highly customizable. When we were giving this talk at another conference, somebody asked, like, can a user turn the search index service off? Like, yes, they can, because it's a highly customizable feature of Windows. And they also, the databases themselves take up a lot of space. So you can certainly customize them to maybe minimize what's actually indexed. But that's a great question. And I'll try to confirm that and get back to you.
Eric asked, how does the search function work in regard to other browsers such as Chrome? So by default, Microsoft will only index the default or built-in browsers like Edge or Internet Explorer, not record any data browsers like Chrome, Firefox, Brave, etc. Jakes Jansen also mentioned that, is it worth running the esensitive commands in Velociraptor before examining the file? Like Julia mentioned, it depends, and we would encourage or recommend to parse both the dirty as well as the clean version, and we would recommend you to create a copy of a database before you clean it. So that will be on your forensic tower in an ideal situation.
All right. I think that's all the questions in the Q&A. I mean, Falgun and I, you can reach us. We can reach out to us on LinkedIn as well if you have any other questions, or maybe if you have questions for Falgun later. We can get back to you at a later time for anything that we need to confirm. But yeah, thank you everyone for listening.
Thank you so much, all.
Thanks again, Julie and Falgun.
Bye.
All right, folks. Once again, we'll reconvene at 1 o'clock Eastern time, and we'll get started pretty promptly. So make sure you're here back at 1. Thanks. Hey guys, just give everyone just a minute or two to get settled after lunch, and then we will go ahead and get started with the second half of the summit. Okay, we are back from lunch. Hope everybody had a chance to refuel, rehydrate, maybe get up, stretch the legs a little bit. But we are going to jump right into the second half of the summit. I see that Andreas is logged in, ready to go. Okay, and he is going to be giving us a presentation on Velociraptor as a learning tool. Give you a quick summary on Andreas, if I can find it. So Andreas has over 2 decades of experience across red and blue teams. He delivered dozens of security consultancy projects across diverse industry verticals. In recent years, he sharpened his threat hunting, incident response, and digital forensic skill sets and worked many high-profile IR cases. He currently heads up the SOC at an oil and gas company. So ladies and gentlemen, let me hand it off to Andreas Flamino.
Thank you, Carlos. I'm just gonna share my screen. Right. So welcome everyone to my talk, Velociraptor as a learning tool, or how to tame the beast to dig deeper. We already covered the high-level bio, so I will skip over this. The idea of this talk really stems from my personal journey with Velociraptor, and my aim is to inspire and bridge the gap between people who regularly use the tool for DFIR and those who do not and want to get better. Now, what I experienced is that it's easier to become 10 times as effective than 2 times as effective in my job after I started using Velociraptor. Now, this was mainly a factor of becoming more self-starting and more resourceful, as opposed to reactive and being dependent on alerts and findings from other types of tooling. Now, if you don't use Velociraptor regularly and you are a DFIR specialist, I'm confident that you will find this to be true as well if you take the leap and dig in. Now, for those who do use Velociraptor on a regular basis, I hope this talk will inspire you to get other people to use it more and perhaps become more effective as a team. I've organized this talk by describing a senior and associate avatar as guideposts, and we'll share insights from a senior perspective and opportunities for an associate. So let's start with the senior. Now, for me, in planning this talk, a senior associate, I'm thinking of someone with maybe 5 to 10 years of experience. Maybe they're an IR consultant, maybe L2 or L3 SOC analyst. They could be senior security analyst or digital forensics consultant. If this sounds like you, or if this is something you do, the following situations might sound familiar. Now, in the context of IRs, you might come across situations where the affected systems don't have all the corporate security controls deployed. Or maybe you find that there aren't any custom rules in the EDR, or maybe you find that there are way too few logs being ingested by the SIEM. Or maybe you spend out a lot of time rolling commercial tooling out during an IR, and during this process you might have to deal with sales, procurement, change requests, and a lot of other time-consuming activities before you can even get started with your investigation. So the summary here is that in an IR, typically you're dealing with limited information at the beginning of your engagement. Now, when you're hunting, some challenges are that common challenges could be that you're trying to piece together why the SIEM and EDR aren't configured properly. Maybe you have concerns about not having the right level of visibility, or maybe you're frustrated about the limitations the EDRs have when it comes to allowing you to perform a bit more creative pivots. And maybe you often run into situations where you either accept a risk or just get a system re-imaged and be done with it. Now, in doing digital forensics on one image or one system at a time, and you're analyzing forensic images, that can often take dozens of hours. And if you're using tooling to, extract a lot of artifacts in an automated fashion, again, that can take a lot of time. Now, especially in situations where forensic soundness is not a hard requirement, that can be needlessly time-consuming. Now, when I think of the associate avatar, I'm thinking of someone with, maybe little to 5 years of experience, maybe an L1 or L2 SOC analyst. Maybe this person is a fresh graduate, or perhaps a digital forensics consultant with not that much lower level OS forensic knowledge yet. If you are an L1 or L2 SOC analyst, in your day-to-day work, you might have so many alerts that you really have limited opportunity to grow technically beyond the SIEM and the tools that feed into it. Your work as a result might be highly transactional, going from one alert to the other. And perhaps you would like to get a better understanding of the finer details of what's happening on an endpoint. Or maybe you're a digital forensics specialist with, not so much lower level OS knowledge, and you really rely on the tooling to present you with findings. Now, if this sounds like you, these challenges, might sound familiar. You really do not have enough time to properly investigate security incidents, but you also do not have the visibility due to the limitations of the EDRs and other tools that feed into the incidents. And when there's an alert or incident that looks like a true positive, you might have to hand it off to higher levels of analysts in the SOCs or technical support to follow up. And again, they might just scan the system, maybe re-image it, or maybe send it to more experienced people to perform forensic analysis. Now, in both these types of avatars and these types of roles, you might feel somewhat constrained in getting results fast. And you may have accepted the idea that this is just the speed at which things work. Now, if you fall in either of these two avatars or kind of in between, I think that the rest of the presentation, that you will enjoy the rest of the presentation, because I'll share some anecdotes about the transformations that me and some of my associates went through. Now, I'll use this pyramid to visualize my idea about the relation between forensics, threat hunting, and incident response. I'll start from the top because personally I find incident response most exciting. To me, incident response is essentially threat hunting after an incident has formally been declared. And some characteristics of an IR are that you probably have some facts or at least a very strong suspicion about what happened, some type of breach. What stopped happening, maybe a service disruption, what went missing in the case of data exfiltration, or maybe things that got modified in the case of ransomware. Now, of course, these are not exhaustive examples, but you get the idea. You have some facts, and as a result of having some starting points, you should be able to form several strong hypotheses about what happened and start piecing together the details and build your timeline. Now, additionally, IR can be tense, and some people, around you, maybe not you, of course, but they might be very nervous, and things can get a bit, tense and chaotic sometimes. Now, when you're doing incident response, in addition, it's very expensive in one or more ways. So the longer you take to conclude your response to the point that services are being restored, the higher the cost. So be it either in the time that you're billing to the client or the cost of the service disruption or a combination of those. Now let's look at some of the characteristics of threat hunting. To me, the main differentiator between IR and threat hunting in this context is that threat hunting is proactive, whereas IR is reactive. As a result, you may have little urgency to do your hunting because nothing bad happened yet, or at least not that you're aware of it yet. And most of the time, you will not find anything malicious. And so on the downside, this can be a little bit boring, especially if you're hunting in a very well-managed environment. But on the upside, you're building a very solid understanding of what's normal in an environment. So to me, the summary is that threat hunting is the act of proactively looking for bad things through means of performing forensic analysis on more than one host at a time. This brings me to forensics. I think that forensics is really the foundation for any host-based analysis. You need to understand what artifacts you're looking for, and some artifacts that are essential, or some areas that are essential to grasp to some level in detail. Include things like different types of execution, authentication, programs that have run in the past, present, and will run in the future, services, the registry, logging, file management, storage devices, and so many more areas. And it's just to say that OS Forensic alone covers a vast body of knowledge that can take years to learn and many more years to master. Now, let's go back to the main idea. So to me, working it back up to the top, to me, forensic analysis is really the best foundation to start hunting. And being an experienced threat hunter is really essential for effective IR. And to rapidly increase your competence in all areas, Velociraptor can help you a lot. So let's dig in and look at some examples of some key learnings that I had in my personal journey. So the first thing that Velociraptor offered me is that it helped me to become even more self-starting in my job. And unless you give it a task, to collect information from your endpoints, it will do absolutely nothing for you. There are no graphs, no alert, no warnings. There's no enrichment with external data sources, nothing. There's just a powerful framework that is waiting for you to do something. Now, this reminds me of the time, sometime in the late 90s, when I installed Linux for the first time. And I thought that the installation had failed because I ended up with some white letters on a black screen. And back then, a friend of mine recommended a book called Unix Shell Scripting, and I started learning about the commands built into the shell, each of them doing one thing and doing the thing really well. After understanding how some of the basic commands work and how to combine them, I quickly became very resourceful and self-starting. I started writing little scripts, and that later became more complex scripts, and it helped me save a lot of time as a systems administrator. Now, with Velociraptor, I experienced a very similar type of journey when hunting and working IRs. And I remember when someone told me about Velociraptor and told me that a friend of his did, compromise assessments in very large financial institutions with nothing else but Velociraptor. I looked at it and I think, if you learn all these artifacts really well, they probably do one thing really well. And if you know how to combine them together, you're going to get very efficient and creative. So these are some of the artifacts that I started with. So I started, learning about how to collect users, programs, different types of evidence of executions, search through the file system, searching for files, pulling the MFT, searching through event logs, and searching for very specific event logs, and different packs that collect a lot of information at the same time, for example, about persistence, lateral movement, and execution. While learning how all these artifacts work individually, I really deepened my understanding about how things are organized on the Windows operating system, and I experienced a rapid growth. I had the opportunity to hunt across a very large number of systems over a long period and built a very solid baseline about what is happening in the environment, because I interacted with unaltered and uninterpreted data that came directly from the endpoints. I then continued to more complex artifacts and started looking at the source code to understand how they work. I then noticed that complex artifacts all rely on a set of core artifacts and functionality to combine, refine, and answer more complex questions. Now, as my competence with the basic artifacts increased, I experienced a growth in confidence. And that's really when the competence and confidence loop started. And I noticed a step up in this loop with each investigation. Now, the confidence-competence loop is a concept from modern psychology, where you have the confidence to try things, observe the outcome, and then learn from it, which in turn then builds your competence, increasing your knowledge, your ability, and your skill set with each cycle that you go through. Now, the next thing that it offered me is that I became much more resourceful. Specifically in the context of DFIR. So after a while, I started asking more complex questions by using more advanced artifacts. And at times I would notice that some artifacts would return nearly what I needed, but there was something missing. And at those times, I remembered that another artifact performs an operation that I missed in the first one. So that's the time when I started creating modifications in existing artifacts to end up with new or modified artifacts to arrive at the answer that I was looking for before I made the changes. Now, I also experienced that when I explore artifacts that I haven't used before, I would learn new things, get new hunting ideas, and learn about forensic artifacts I'd never explored in depth before. Now, some examples, some easy examples are adding hashing functionality to particular artifacts, or maybe I would be using a particular artifact that pulls some data from the registry, but maybe it wouldn't return any data that I expected. And then I would do some research and find out that either a particular security feature or a convenience feature was turned off, or maybe that it was different on the version of Windows that I was using. So that really, helped me deepen my experience and knowledge further. Additional things I would do or have done are implementing enrichment using threat intel sources, for example, from VirusTotal or our private MISP instance. Now, when I got comfortable with this, my ability to get results became mainly limited by my time, depth of understanding, and creativity. And next, if I really ever get stuck or ever really get stuck, I would go to the Discord channel, and I would then first use the search function to see if my question has been asked before. And if it hasn't, I would ask my question and usually get my question answered within minutes. The thing I really like about the community is that it brings practitioners together from many different backgrounds and experience levels, and even some very esoteric questions can be answered, and often, in a very short amount of time. As a result, my knowledge compounded quickly, and this is, an experience that's very pleasant and in stark contrast with some other host-based tooling support channels. I've had several experiences where I would ask a very detailed question that was not covered in the documentation, and maybe I would get a response after a few days telling me that I'd have to engage professional services, or maybe be pointed to the documentation that I already read and that didn't cover the answer. The next thing that I really like about working with Velociraptor is that it helps me really understand boundaries of other host-based tools. So after going through this loop of building confidence and expanding my understanding, I really started to pick up speed and assembled a lot of tools in my tool belt. Now, my range of questions to ask the OS expanded rapidly, and when faced with commercial toolings, I noticed that all of them have a very clear and firm boundaries in terms of functionality compared to Velociraptor. As an example, there aren't many host-based security controls that I know of that allow me to do things like, request the MFT for one or more hosts for a specific time window after seeing some suspicious-looking executions in the user assist hive, or pull back all service or scheduled task definitions from all hosts and quickly establish how common they are, or hunt for files matching specific regular expressions in specific folders and then pulling back the hashes, or do things like hunt for IOCs across specific Windows event logs, or maybe different application logs, or in some situations, even every single file on the system using Yara. Or do things like pull back a list of all the Office documents that had macros enabled by the end user. So after I worked with Velociraptor extensively for a period, I started to really appreciate how much power and flexibility you have to ask very big questions in a very broad sense and get very quick responses. I also started to appreciate how most commercial vendors do a great job at doing what they think is important. But when you want to create a solid baseline or do a deep investigation, there are questions that are interesting and perhaps crucial during your hunt or response that are not covered by your EDR, XDR, next-gen AV, etc. So once I understood these boundaries well, I started to deeply understand how well Velociraptor and good EDRs can play together. Specifically, Velociraptor, can do more of the heavy lifting, and you can ask very specific questions in a short amount of time, and then have EDRs take care of the real-time monitoring and the enrichment on the other hand. And this is also my preferred way of working during IRs. So in several IRs I worked on, there was limited or no EDR coverage at the start of the engagement. And I would very quickly get a solid overview of what the adversary did using Velociraptor, at the beginning of the engagement. And then I used those findings, that information to start building my timeline. Now, while the picture of what happened during the intrusion shaped up, the EDR would, typically a lot slower be rolled out, and we would have real-time alert monitoring and events. After services and internet connectivity were restored, the EDR would then give us the confidence that we had not missed anything and that the attacker wasn't coming back, without having to run the same types of Velociraptor collectors repeatedly. The next thing I really love about Velociraptor is that it allows me to stand on the shoulders of great researchers and developers. So once I developed a solid handle on the go-to artifacts that come with Velociraptor stable release, I arrived at a point where I would feel exhausted in my learning phase and plateaued a bit in my development. So that's really when going to the artifact exchange gave me many new ideas. And as I dove into newer and more niche artifacts, I found that many do things that I know little about. And for example, some artifacts leveraging third-party tools are some examples, like, interpreting the output of the Hollows Hunter or Malfind, and the surprising results that it gave me when running it across hundreds of systems. Now, every time when this happens, there is an opportunity to go into a new rabbit hole where an expansion of knowledge is waiting to unfold. And there have also been several situations where I run out of ideas to hunt for during an IR, but I was absolutely convinced that there was more to find. And, then if I'd go to the artifact exchange, I would come across specific artifacts that hadn't been relevant until that situation, maybe because they provided some context about specific attacks, or analyzed specific forensic artifacts or specific applications or context about vulnerabilities. And all of these opportunities, or in all these cases, I had the opportunity to benefit from the knowledge, research, and creativity of other practitioners who know a lot more about those areas than I do. Log4j was, for one excellent example of just after how the vulnerability was given a CVE and became widely known and exploited. It very quickly had an artifact released on the artifact exchange that helped you find vulnerable libraries. And if you are responsible for protecting an environment throughout that time, it became widely known. You might remember how it took vendors days, and in some cases over a week, to identify which versions of which exact software were vulnerable. Yet the initial artifact that was released and the variations that followed it were very quickly able to help me identify which of our software was vulnerable, so we could take preventative action without having to wait for vendors. So this comes to the conclusion of the key learnings for me as a bit more senior. I really, I want to say that the journey of executing my first single hunts to getting to a level where I can confidently pick between 10 and 20 different artifacts during a complex incident response engagement has been a very enlightening one. And I really enjoy the rapid increase in the ability of becoming to or ability of finding actionable facts that it offered me. And every client where I delivered IR projects has acknowledged that we can the value that we can bring with it. And over time, I feel that rapid response becomes really easy. And there've been many engagements where I come on site, and then within the first day, there are so many different findings that I could uncover with Velociraptor. And yet, the more I learn, the more I get done with Velociraptor, the more I realize I have so many more areas that I can dive much deeper to, and that to me is like truly exciting. So moving on to the key opportunities for the associate. So as an associate, some or maybe many of the previous examples might still go over your head. However, the hierarchy of host-based investigations is still a useful concept. When you're starting out, at the very beginning, I think the best place to start is the foundation. So focusing on digital forensics first and threat hunting second. Now, some good starting points could be study material you have, or maybe a course or some books that you order online. And I think you should, just like the senior, start by learning the core artifacts. And when you do, it's extremely useful to learn what each returned row means. And if you can't figure it out immediately, Google it and you will find it. Now, here are some of the commonly needed artifacts that you should be able to find fairly quickly. So you should be able how to interact with the Windows registry. You should be able to query AD and local user objects on your system. You should be able to understand the MFT format, be able to search for all sorts of files on your system in using many different types of search queries, know how the recycle bin works, how to check for installed programs and programs that ran in the past, look at service definitions, scheduled tasks, and other potential persistence mechanisms, and also learn about how network sockets are being used by programs. Now, it's my experience that if you write down what you learn from the perspective to explain it to others later, you will remember things better. And after learning how each of the core artifacts work, you can explore how to logically follow one with another. You can also just search through the available artifacts in Velociraptor, read their description, and just see what comes back. Now, chances are when you go through this journey, you will find some artifacts that you like a lot and pique your curiosity more than others. And I highly encourage you to follow your curiosity and develop your unique ability so you become really good at it. Now, in larger IR teams, for example, you'll typically find that everybody has their own key strength that nobody else in the team has quite at that same level. And this is really your opportunity to find what excites you and develop yourself in an area that piques your interest. Now, your learning process should be fluid, ever diving deeper, or maybe hunting in a broader scope while developing your abilities of being self-starting and resourceful. Now, those qualities of being self-starting and resourceful are some of the most valuable skills you can develop, not just in your cybersecurity work, but also in life in general. Now, being self-starting can mean that you can develop your own hunting idea or your own gut feeling about what might be a key artifact to pull or to request from the endpoint. Being resourceful means that if you get stuck, you can by yourself think of ways to get unstuck. You can find resources that can help you further. And most of the time, that will mean that you can find the answer yourself. And sometimes it means that you ask someone who is already an expert in a certain area for pointers. Now, note the key word here, pointers. I think you can learn a lot more if you try to avoid asking for the entire answer. Not only because you learn less if you ask someone for the entire answer, but also because you might figure out better answers if you do the work yourself. Now, when you become more self-starting and resourceful, your mindset will truly change, and this will truly set you apart from people who know a handful of defensive security tools well, but only know how to react to alerts that are triggered by the tools that they use. So as you go through this process, you're really building a solid foundation to expand on. And this is really an excellent starting point to continue to threat hunting. Now, if you're lucky and you might work in a team where they already use Velociraptor. If not, perhaps it would be a good time to suggest your team members to start using it. Now, this will be a lot easier if you can already demonstrate to your team members what you have learned by yourself and how you can get a lot of actionable data, actionable artifacts from endpoints in a short amount of time. Now, assuming you can use Velociraptor in your team, this is your opportunity. You can use this opportunity to become a better security analyst and threat hunter. So if you are running Velociraptor in your environment, you could start with some of the following tasks, like qualifying findings from other tools such as EDR alerts or SIEM dashboards. And the talk about SOC integration that we saw this morning was a really great example of that. Or you could look at service definitions for newly created services, programs or scripts that are executed through new and modified scheduled tasks, and encouraging yourself, or if you're working with people in your team, or if you're learning yourself, look up what each new or modified service is used for, or at the very least, understand what kind of vendor or context it belongs to. Or you could do things like evaluate PowerShell and command.exe logs and understand what the commands do, and then look up the commandlets that are unfamiliar to really build out a mental map of what types of scripts are running in the environment and what type of tasks are being performed by administrators. Now, the increasing, another thing you can do is just increase the contextual awareness of an alert by being able to quickly pivot and answer questions directly on the endpoint, or with information coming directly from the endpoint. I've worked with different EDRs, and in after working with Velociraptor, I kind of feel a little bit handicapped if I'm only looking at the EDR, because there's so many features or so many things I can do with Velociraptor that EDR simply do not do. And that's sometimes a bit difficult. Other things you could do are perform focused hunts for TTPs that you have shortlisted in your threat intelligence or your threat intel driven hunting strategy, and provide summaries on findings that stood out or new things that were learned. In the beginning, if you are just starting out with Velociraptor, I would start refining the results that come back in your notebook in 3 phases. So in the first phase, I think it's really useful to pull back data into Excel using the CSV export function, and then just use Excel to start color coding, filtering, sorting, grouping, and doing some searches across columns, using regular expressions or using searches on specific columns. Now, once you're familiar with that approach, and you do it on a regular basis, you will come across artifacts or specific hunts that might pull back really large files. So maybe you're dealing with tens of thousands or just thousands of rows, and that can become a bit hard to manage. So I think that's really the ideal time to start learning some basic VQL statements, to sort and count and refine your result set and reduce it, to a smaller result set to get the answers that you're looking for quicker. Then once you've done that, I think in the third phase, you could expand your VQL knowledge and do a lot more creative filtering. In that phase, you might start using a lot of regular expressions and substatements in your queries. And here's a good pointer. Your ability to unleash the power of Velociraptor really increases dramatically when you start to add ever more creative VQL statements in your notebooks. So once you reach this level, you should be confident enough that you can start finding things that warrant further investigation and start assisting with IRs. So one way to get to that point could be to just raise your hand if if the team you work in is responsible for handling IRs, and just say that you want to contribute and help out. If your team does not do any IRs, maybe you can do IR challenges where you can either bring your own tools or you can download the VM and do it on your own in your own environment and do your hunting and response there. Now, this is really the phase where you should develop your fluidity and your creativity in quickly assessing a situation and understand which collections quickly or logically follow one another, right? And it's really the time to build your muscle of very quickly building a situational awareness. Now, once you reach this point, you're definitely on an accelerated path to becoming a senior. So wrapping up, I think that the way an associate can benefit from Velociraptor is very similar to that as a senior. I think the main difference are the starting points, the size of the available body of knowledge, and the understanding to draw from, and the breadth of the contextual awareness that we start with. It's my belief that a curious associate can experience a rapid expansion of growth and exposure if they start by themselves or are given the correct pointers. And after this knowledge gap is closed a little bit, I think the main thing standing between the associate and the senior is really the number of repetitions. Now, the key features that Velociraptor offers to practitioners on any level are development of a very strong proactive mindset, unparalleled flexibility, and speed of execution, and finding actionable intelligence from your endpoints. So this is all I have for you today. If you have any questions, I can answer them.
Thank you very much, Andreas. Like you said, if anybody has any questions, please throw them into the Q&A. I don't think there are any in there for you right now, but we'll keep an eye on it. But yeah, thanks very much, Andreas.
Thank you too.
You got it. All right, so we're moving right along. That puts us right on schedule for our next presentation, which is by someone that I'm sure everyone on this call, or not everyone, but a lot of people on this call are probably very familiar with, and that's Wes Lambert. Wes has been an instrumental member of the Velociraptor community for a while now. And you'll always see him, whether it's on the Discord channel or coming up with various artifacts, kind of on the fly. He's meant so much to the community. So we're always happy to have him, especially on a day like today, where he can drop some serious knowledge. So Wes, I'm going to go ahead and hand it over to you. Before that, let me just give you a little introduction. Wes Lambert has over 10 years of experience defending computer networks through the architecture and implementation of tooling to facilitate digital forensics, host and network-based security monitoring, security automation, threat detection, and more across financial, healthcare, and software verticals. While not at the computer, Wes enjoys Indian food, playing soccer, and spending time with his family. Wes, I enjoy all of those things. So we are like two peas in a pod there.
Awesome.
So take it away, my friend.
Yes, sir. Yes, sir. Let me get this slide sharing set up real quick. I guess I'll have to wait for you. There we go. Okay, let's see if I can just do screen to. Let's see what this does. If I can get it situated. Share. All right, and let me go ahead and go full screen here. If I can get this thing out of the way. Come on now. And there we go. Slideshow full from the beginning. Okay, we good?
It's looking good to me.
All right, cool. All right, again, my name is Wes Lambert, and this is Clawing Your Way to Compliance with Velociraptor. As Carlos mentioned, I have a little over 10 years of experience just doing various things in enterprise security monitoring, host-based monitoring, security automation, threat detection, defer, a bunch in engineering, some in actual response and that kind of thing. But overall, I'm an avid open source contributor. I'd like to contribute a lot back to the community, especially the Velociraptor community. You can see a few projects here on the slide. The Velociraptor Docker image, and then some other integrations with Velociraptor and kind of getting into SOAR over there. I also put out the Artifacts of Autumn thread last year about some awesome artifacts that you can find on the Artifact Exchange. So if you haven't checked that out already, again, it's on X or Twitter. And then you'll also see some stuff there in the Artifact Exchange from me. So that's a little bit about myself, but I want to talk a little bit today about compliance. Okay, and I know some of you might think, it's boring, right? I mean, not always, right? I mean, it's kind of a necessary thing, right? A lot of us have to deal with compliance in the enterprise, whether it's for maintaining strategic partnerships, like, basically meeting business requirements so we can do business, or really just maintaining a more secure posture overall and being able to adhere to some kind of standard to do that or some kind of framework. And Velociraptor is really well known, as you guys might know, about its DFIR and its kind of threat detection or monitoring capabilities. But a lot of folks really don't think about it, at least, I haven't heard a lot of folks talk about it. I've heard a couple talk about it for compliance purposes. So that's why I wanted to put this talk together and work with Mike to see what we could do as far as seeing how we can highlight Velociraptor in that area. So first, I want to talk a little bit about compliance for, some folks might not be familiar with certain things. So I just want to go through a basic intro here. And the first thing that we'll talk about here is going to be HIPAA. Obviously, well, if you don't know, it deals with the protection of healthcare information, protected health information, personally identifiable information. So there's, a lot of, work around there just as far as, what we need to do to secure those systems. Additionally, whoops, went backwards there. Continuing from there, we have, let's see, PCI DSS, right? So we're talking about cardholder data, and we're talking about digital transactions and payments. And I'm just going to stop my video here just for bandwidth purposes. And then we also have, we'll continue. Sorry, it's getting a little slowness here. We'll just give it a second. GDPR, right? So we're dealing with like privacy of our data across social networks or platforms in that manner, dealing with accountability of that data and all the laws that go along with that and the kind of European space, right? And then aside from GDPR, we have NIST. So a lot of you probably are familiar with NIST as far as protecting either federal contracting systems or federal information systems, or just in general, a lot of folks use it for their, their compliance purposes to have a model to work from whenever they're trying to secure their systems, right? So those are just a few of the frameworks and standards that, you might see. Next, we'll talk about, some benchmarks or some implementations of these. And just give it a second here. And sorry, it's getting a little slow here. Here we go. We'll talk about CIS first. And CIS, the Center for Information Security. So what this covers is 25 different product families plus so different OS, different operating systems like Mac OS, Windows, Linux, and it applies really to those, PCI DSS, NIST, and those kind of frameworks. And it helps us to secure our systems and adhere to those frameworks by publishing a set of benchmarks that we can go off and read through and implement in our own environments. And another one is going to be STIG. It's going to be more tied towards government, right? Like DoD or DISA security requirements are really going to govern what's in the STIG. And it's like kind of, it's a lot stricter probably than the CIS benchmarks, a lot more involved there. There are a lot of tools for each of these that you can go through and compare your overall posture. But these are just two of the ones that I wanted to mention off the bat as far as benchmarks and implementations of those other frameworks or standards. Now, continuing from there, we also, want to dig a little bit into the CIS benchmarks themselves. So here's just an overview of the process there of how they actually come up with a CIS benchmark. It's really that community involvement and everybody agreeing on, what the scope is and what the standards are. Everybody gets together, they discuss this, and then whenever they have a consensus, then they publish the CIS benchmark, and then we have that benchmark available to us for a particular Linux OS or a particular Windows OS, and then we can go off and leverage that. And from there, we have something like this benchmark right here for audit system integrity. And this benchmark right here, you can see we've got a few different things such as the title, right? What we're talking about. We've got the profile. Where does this thing apply? Is it for just general information systems? Is it for corporate networks? Is it for like military networks or really sensitive networks? We've got a description, right? Like what does it do? Or what's this all about? So this description in particular talks about some Windows event IDs that might be concerned with this particular setting or this, this benchmark. And then some rationale, right? Like, why is this useful to do this? Why would we want to look at these events? Why would we want this control in place, right? And then we also have the impact as far as, if we're not looking at this, how could we be impacted? How could this negatively affect us? Okay, so overall, that's just an overview of the, the frameworks, the implementations, and CIS benchmarks. So we'll continue from there talking about compliance and how it might apply to Velociraptor. So, let's talk about compliance in a nutshell. So the first thing, that we do is read some docs, push a bunch of extremely technical controls to servers and workstations, right? We do that, we just do that immediately. We make a bunch of teams across the enterprise, across the organization, really, really mad, including our own team. We're mad at ourselves. Everyone's really stressed and everyone's really tired. The auditor checks a box. And then our enterprise is impenetrable, right? Like security is done. We all go home, nothing left here, right? Right. This is how we implement compliance, right? No, not at all. Not at all. So what we really want to focus on here, obviously compliance, as you might have heard, is not a one and done thing. It is a life cycle. And this is just an example of a life cycle here that I have. This is from some F5 documentation. This is not a definitive life cycle by any means. This is just an example of how you might orient compliance and continuous monitoring in your environment. So the first step being observe, right? Like taking an observation, looking at what telemetry we have, how what our network currently looks like, what is the configuration now, and then kind of going from there. Seeing what systems we have, classifying them. Maybe we have certain data levels that we need to classify particular systems for, like production systems, cardholder data systems, right? Things that involve digital transactions. And then we need to demonstrate our compliance with the particular standard or the framework. right? We need to show that we actually have this stuff in place, these security controls, and then we have to be able to maintain them, right? We need to be able to adjust them later on. We need to be able to continuously monitor and make sure that these things are happening. All right, and then continuing from there, I talked about continuous monitoring. I think one of the most overlooked things, and a lot of people try to go into a bunch of other really fancy things, but one of the most important things that you can do in your environment is maintain a comprehensive asset inventory. It's absolutely critical, right? As far as identifying rogue devices on the network, Jim Bob's server in finance, right? It's in some back closet. It's been processing transactions since who knows when. Everybody forgot it was there, but it actually runs the business. So it's very important. This is like probably the most important step, maintaining the asset inventory, and then continually classifying and trying to understand the systems as you need to, right? As they come up and as things change within your organization, maybe your network structure changes, comparing the previous state against the current state, right? I mean, we need to see the old versus new. Is it better now? Is it worse now? Are there new systems that aren't configured appropriately? And then addressing these deficiencies as they arise and accepting risk as necessary, right? Overall, we really want to move towards that more secure posture just by implementing all these steps. We just want to get better than we were the day before, right? Or at least maintain what we had before. And it's really why we want to implement that continuous monitoring. So, you know what? Let's make it happen, Captain. All right. But before we get started, we need to have a way to take those benchmarks and translate the recommendations from CIS to something that's usable by Velociraptor, right? So how do we do that? Well, we might be able to leverage a little help from our friends in the open source community. And this is where I'd like to introduce the Velociraptor Audit project. This is something that I've been talking and working with Mike through. It's right here at Velocidex/audit, but this right here, this project maintains a set of checks that are converted into VQL. These checks are tests from those CIS benchmarks. They are Boolean operations that result in a yes or no result. So we can figure out if, we're actually adhering to this check, if we're actually adhering to this benchmark standard, or this profile. And then the reports are right there within Velociraptor, right? So we can see that within the UI and be able to act on that and respond accordingly. And so what this does is it really facilitates that rapid kind of identification and comparison of all the endpoint configuration, right? The security configuration against the compliance benchmarks, and we're able to ascertain, what is the state of things right now. All right, so continuing from there, let's talk about how it works. Now, we'll introduce another open source platform you might have heard of. It's a host-based monitoring, and they've made some strides in the past as far as doing some other things with the data from the stack. But it was primarily used for host-based monitoring, but it does have a module called SCA, or Security Configuration Assessment. And what this does is it allows folks that leverage the platform to monitor for compliance against those particular standards and those benchmarks. And you can see the link here. There's just a blog article there. But again, it allows us to check for things like HIPAA compliance, PCI DSS, NIST 853, and lots of other frameworks. So, maybe we can leverage some help from our friends here at Wazoo. Let's dig a little deeper into how we can do that. Now, the SCA file uses a specific file for each OS. There's one for Mac OS. There's one for Linux, different flavors of Linux, different flavors of Windows. So there's lots of different ones that are used in comparison, or the kind of in correlation with the CIS benchmarks. And given the structure of the file, we can easily parse it. We can pull down the file and create our own vehicle-based checks, which is pretty cool. And I'll get into that in just a second. So we have the SCA YAML here. It's just a visual representation, a very brief one here. And we convert this to an intermediate YAML file. And then from here, that YAML file will be converted into VQL. So we have the streamlined process of generating kind of an intermediate form that we can manipulate as needed and review on a manual basis if we need to implement any changes. then we can convert that into VQL. Now, continuing from there, this is what the SCA file looks like. Oops, a little too far there. So you can see right here, it just specifies the policy for Wazoo, the Win 10 Enterprise, so Windows 10 Enterprise. And then you can see some different information like the benchmark for the enterprise, right? And a description, some references. And then it has a bunch of different checks down here and the compliance information. And then if you were to scroll down further, you would see some values and some expected values that you might find for that check and what we're actually looking for. And we can see here in the intermediate YAML, this is used for humans to be able to parse this easily, to be able to modify it as necessary if needed before conversion into VQL. But we can see similar fields here. We can see the source here, the Win 10 Enterprise SCA file, and then the artifact name that we're going to generate from that. And we can see some different things here like the export and some different checks. So this is where we actually implement the functionality. And we see some column expression, the where expression, the test that was actually used from SCA. And we see some other things like some other things that are used in the conversion process. So we can again modify these checks if we need to manually. If we don't want to include a check, we want to disable it, we can do that. We can verify the configuration overall and just make sure everything looks good. So again, set SCA file to the YAML file after it's been converted. This is the converted result, I'm sorry. And then from there, we can run this right if we wanted to generate that ourselves. So we would just run go run in the source directory of the audit project, and then it would generate this YAML file that we see here that can be converted or modified and converted into VQL. Now, continuing from there, we have the actual artifact itself that's generated. And what we can do is we can set a disabled value in that YAML file on the previous slide, and that will remove any checks from being converted over into this artifact. So if we have certain checks that we don't want to perform because of business requirements or other requirements, we can absolutely do that. We don't necessarily have to run every single check. And again, that YAML file is converted into the VQL file that we see here. And that is done by running from the source, the audit directory. We just run make auditor to build the auditor command. And then we can run auditor VQL, then the path to the SCA file, the intermediate file. And then we can throw that in our artifact definitions, or we can collect it on the fly. Lots of different ways we can do that there. And this is just a look at the embedded check here. So right here, this is the actual JSON. So what this is, it's base64 encoded gzipped content. So we had the JSON here, and it's gzipped and base64 and encoded inside of the artifact. And that allows us to really compress it, make it smaller, make it more portable, the actual tests, and we can leverage the native functionality within VQL to actually parse that and look at that further. So if we wanted to look at this in CyberChef, we can do this pretty easily just for a visual representation. We don't have to do this. We can do this all with VQL instead of Velociraptor. But you can see here that we've got the original base64 and we're decoding that. We're geo-unzipping that. And then we're beautifying that real quick just to make it pretty. But you can see the actual checks that are inside of there embedded inside of that data. So that's pretty cool, right? And now if we continue from there, just like to show you something really cool. GeoCities for the win, CyberChef's theme. If you haven't seen that and you're coding late at night and want to hurt yourself, have at it. So enjoy. But just wanted to showcase that real quick. And this, I think I mispasted this, but anyway, this right here, the extracted checks, we can see the command run on the endpoints. We can see the regex here that's used to determine the actual value, the expected value. And this expected value right here, so what's happening is we're running net exe accounts and we're trying to get the length of the password history that's maintained. And the expected value is supposed to be greater than or equal than 24. And then the value right here, you can see it's a command, basically some VQL that returns the value that's actually returned from the command. And then we also have the multiple checks in a single test. You can see the 0 and the 1 here. And this let command match function right here, this just tells us how it actually matched. You can see the command and the regular expression. And then we'll go off and do some caching function there, which I'll get to in just a second. But that is the extracted check there. You can see the various tests that are going to be run, or the checks that are going to be run within the test. And then we have the command match right here. So many checks use similar commands. So one way to help with this is by using the cache function to cache the commands and improve performance. And you can see just a blob down here, the cache function, and you'll see that in the VeloCON editor. But you can see here that you know, it's very good for performance to be able to cache the commands, and then we can compare using regex and actually, you know, reuse some of the stuff as necessary. So that's pretty cool to have that available. And then additionally, what we can do here is when we're ready to collect the artifact, we can collect it via the CLI if we want to. And so what we have here is just, you know, a CLI representation of just running Velociraptor, specifying the path to the definitions, and running a manual collect with the YAML file. And then we can get those results immediately, or we can jump that out to a zip file if we want to. So that's a really easy way to go off and run that pretty quickly and easily. And then we have the collection via the web interface. So obviously, just like any other artifact, we have this in the web interface. We can go off and collect this in an ad hoc fashion. Oops. Or we can you know, run a hunt and collect it across many hosts at once, which would be ideal. And then right here, I mentioned the checks. This is just an overview of the failed checks that we might see. So we can see that, in fact, this password history here was not set. It was not being enforced for the last 25 or more passwords. We can see that TCP/IP services, you know, set to disabled or not installed. I don't know, right? So, but some of these are going to be obviously essential to operations for some folks. Some of them are not, which is why we can apply that disabled field and or that disabled key in the checks, and then it will generate the checks that we want. So that makes it pretty easy, pretty efficient for us to go off and be able to reuse that. And then from there, we can see, you know, we can compare. We see that we had 12 hosts that had enforced password history as set, but then we only had 10 hosts that had this UPnP device host set to disabled. So it looks like actually for some hosts, we do have this, you know, are passing, but we do then have 10 that are not passing. And then we can flesh those out later with just some additional VQL, or just by, you know, specifying our notebooks or results set to include those hosts that do need to be remediated from that point. Now, we also have an all tests view that we can look at. And what this means is that we can get a better determination of what checks, since there are multiple checks or can be multiple checks within a particular test, we can see why a test failed. You know, if one check passed and one check failed, we might be able to see that, or see in a more granular nature, you know, what happened if it passed, what the value was that was returned. Sometimes there's no value, but then you can see the expected value over here. So we know what's going on, we know what it's looking for, and we can go off and address that accordingly. Now we can also see the failed tests overall, and we can see again some more context. We can see the different command that would be run, the regular expression, the expected value, the title, and all that good stuff. And we can also see something that's very useful. Just at a high level, if we don't want to dig through each of these, we might want some context around these events. So this command right here, this command context, this actually is what helps us flesh out that context. And what it does is, from the title, it helps to provide some additional context around, you know, what is actually being looked for. Here, it was trying to match account active no on net user guest, right? And we can see you know, maybe why it didn't match there. We can see what it was looking for originally. So again, it's really useful to be able to have that right there within the UI, quickly, easily able to sort through it and see. Again, you know, that's providing that context, that command context function, and it tells us why did that test fail or pass. Okay, but you know, you might be talking about, what about risk acceptance? You know, I talked about you know, some of those checks that you can disable from the intermediate YAML itself, but this right here we can use through the artifact itself, and we can actually overrule checks during collection if we want to. So we can do that at runtime essentially. And then, if we didn't include something originally, or again, because of business or technical reasons, we can then overrule that check inside of Velociraptor in the UI when we perform our collection. And then also, obviously we can apply any comments as to why it was excluded if we want to add a note there, just to make it easier for other analysts or ourselves to remember why we put that in there. Because, we all know how it goes. Sometimes we don't throw any notes in there. So, but wait, there's more. Remediation can also be applied. So this is somewhat in a basic state, but will be improved throughout as we get through the project a bit more. And all we have to do here is check the remediate parameter within the artifact, and we can actually remediate the configuration. So if the service was supposed to be set to disabled, or the password enforcement was supposed to be set, we can actually do that on the endpoint itself. Okay, so it's pretty useful to be able to do that. However, it does come with caveats. Obviously, you want to be careful. You might want to have tested this beforehand on non-production systems to ensure it works as you would expect. But, assuming, you have tested and confirmed everything works as you expect, this can be very useful to be able to apply those standards, those benchmarks, and better adhere to those standards. Okay, so now that we've gotten through that, I want to just do a very brief demo here, and I'm just checking the time to make sure I'm good. So I'm going to take a second here. I'm going to share a different screen, and then we will go from there. All right.
You got plenty of time, Wes, so take your time.
Awesome. Thank you, sir. If I can type, I'm just trying to get something up real quick. Louise can't type. Okay. Let's get this. Share screen. Move this over. Share screen number 2. Yeah. And if you can kindly confirm whenever you see that.
Got it.
All right, thanks, sir. All right, so what we have here is the Windows Audit CIS Win 10 Enterprise artifact here. And this is, obviously we've added this in from our generation. And I just want to show you real quick, actually, if I can pull it up. So again, it's pretty easy. This is just the audit directory here. I've just pulled down the file, and I've run make run here. And then you can see the auditor command here. And then if I just do HR auditor. All right, and then you can run this here, and I'll just run it directly. So just run the auditor command here, and this is using that intermediate YAML that we've parsed initially. Whoops, let's do here. All right, and now you can see that it creates the artifact, and it's huge in here, so I'm not going to scroll all the way through that. I just want to show you real quick. It's pretty super fast, really easy to do from that perspective. And then I've just imported it here inside of the Velociraptor web interface. We can see here it was generated from the Wazoo SCA project, and we've got that overrule checks parameter here where we can overrule anything if we'd like. We've got the remediate parameter, or if we want to remediate it. That's awesome. And then we've got that command, that caching I talked about before, right, where we're caching those similar commands, and then we're matching, and then we're building that context around the particular test and around the generation. And now if I were to go off and actually collect this, you would see here, because I did not want this to fail, I will show you some initial results here. All right, so this is the results of basically all these different clients here, these 12 different clients coming through and running this particular hunt. And now what we can see here, if we navigate back over to the notebook, is we can see an overview of the different results, the failed checks here. We can see that we've got the client ID, the FQDN here. We can see the different checks that failed here, including the enforced password history, rename administrator account. If we were to scroll down, we would see the failed tests that correspond with these checks. And we could see, even more information about, what was happening here. But what I want to dig into here is just show you the count real quick. So if I were to actually go in here and modify this, take just a second here. And if I were to do just a little slow on me, counts, let's count, title. All right. Now we can see here, I just want to do a quick group by just to show you guys just a quick number of each one of these. We see that we have 12 of these here where we've looked for that password history. It's set to 24 or more. You can see that pretty much all 12 hosts have the same results here. Now this one implies the password history here. So if we were to actually run the command, if I pull up the net.exe account command here, let's see. Pull that over here so you can see that. Nope, that's bad. Come on. A little bit more. All right, cool. All right, so if we were to run net.exe accounts, we would see that the minimum password age here is 0, right? Or I'm sorry, where's the password history? Length of password history maintained, none, right? If we were to go in to the local security policy, just on this local system, we could also see that the enforced password history setting here is set to 0 passwords remembered. So, maybe we want to modify that. Let's see if I can drag this over here. And if we wanted to make this more compliant, maybe we could just apply this. Okay, so yeah, man, I'm doing the compliance thing, right? All right, let's make this more compliant. All right, and then if I were to run my other hunt here, and come back and get the results, we would see the results here where we actually have the password history. Now we have only 11 hosts. And if we wanted to dig in and see which ones we could do that. And what I'm going to do here is just exclude anything where, let's see, password history, where title, let's see, or actually we can just include only the ones with password history. And then from here, times count, let's just do this. Count. All right, now what we'll see here is the clients that actually are not yet patched. So if we want to flesh those out and then go move on to actually go do that on those particular hosts, make sure the settings are applied there. We can go apply that remediate action. Or we can also see that, if we go back to the test, we'll recalculate this real quick. We can also dig more into the test for those particular hosts, but hopefully you can see pretty quickly that, it's pretty easy to, after the first hunt, seeing that we had 12 hosts and then doing on this one particular host, seeing that we've immediately applied that result, we've rerun the hunt or the client is re-enrolled in that. And then we can see that that has now registered as actually compliant for that particular check. And then we can go off and, if we need to look at any other failed tests or review that, we can do that. Or we can scroll down a little bit further and we can see all of the tests that were run and get some more context around the particular clients that it was run on and around the actual check that was being implemented there. And then we can also see some other stats here. If we actually remediated anything here, we can see any remediation actions here. And we can actually see any where the checks failed, right? So if we actually went up here, I think this might change. So we just recalculate this and the other, nope, not that one, this one. And so we actually see on this host, this was the host. We could obviously sort these if we wanted to. This was the host. And the reason these look like this are because I'm running the Velociraptor pool client command. So it allows us to spin up multiple clients or simulate multiple clients. And this is the parent one right here, the parent client, I guess. And we can see that it did not fail on this. This test did not fail, or the check did not fail on this host. So this gives us more of a high level as far as what's failing on each particular host. And then we can also go off and create additional dashboards or create additional metrics, right? One additional thing might be to create a server monitoring alert for checks that fail. Once you're in a state where you're comfortable with that particular check, then or those particular tests and that benchmark, then you can go off and actually have alerting occur, and it comes somewhat as a detection or alerting phase, saying that this host is not necessarily compliant anymore, something happened, or maybe some other host has joined the network and it's not a compliant host. So it allows us to perform that continuous monitoring and go off and reenact or even schedule those hunts and continuously apply that configuration as we need to. So as far as the demo, I mean, that's really all I had, considering, just showing how the compliance stuff actually works in the UI. But, if you do want to check out the repository, it is available here at Velocidex/audit. And there's some great documentation here as far as modifying the checks and running the checks. So we can see the different things about the failed check source, the failed tests, and how we can modify that and make that better in the future. So let me actually flip back to the slides, because I do have those things real quick. But yeah, I did just want to show you that real quick. Current slide. Yep. All righty. Let's see if I can actually get my video back on now without it going crazy. All right. There we go. All right. So for the summary, let me get my head out of the way. There we go. All right. So this allows us now, this this project, this audit project allows us to perform ad hoc security configuration assessments now, right? We can go off and collect that data in an ad hoc fashion as we wish. If we want to do it manually, we can schedule these things to do it automatically, leveraging the CIS benchmarks and custom audit rules. And we can remediate those things. We can remediate the different items as we need to, as we see fit. Again, alerting if we want to perform that alerting through a server monitoring artifact or something similar, we can do that. And then really the next steps, I think, would be to add some additional checks here based on different operating systems, because right now there is just the Mac OS, the Linux, and the Windows in there. But I'd love to add additional checks for different operating systems and different standards, at least for the intermediate VQL or YAML that's available. Additionally, different sources, right? So different things other than just the SCA files. The project was written in a way that we can use not only SCA files, but it can be adapted to other types of sources as well. So that's something that's worth exploring there. And also providing additional metadata, different compliance information, right? If it's like related tags or labels, if it's related to PCI DSS or HIPAA or something like that, GDPR would be super useful to have, as well as other references. And again, I think I mentioned, obviously, alerting for failed checks. Once you get in a state where you feel comfortable with the configuration that you have in place, and then I think from there, there's a great potential for the project as far as helping folks leverage Velociraptor from not only a DFIR perspective, but from a compliance perspective as well. Whoa, go too far. Come on, Wes. All right. So leave this now for any questions. If you guys have any questions, you can also reach me at the Real W Lambert on Twitter. And then I'm also on infosec.exchange. And then if you want to check out GitHub, that's there as well as the audit project. Thank you for listening, and Mike also for help with the project and everything else. So yeah, thanks, guys.
Thanks, Wes. I think there actually is a question in the Q&A if you want to tackle that one real quick.
Okay.
From Carlos. It's not me, the other Carlos.
Yeah, okay. In the case of the regex, is there any way to make them localization aware? Okay, between different language outputs. I don't think that's supported now. I would probably have to leave that to Mike to answer. But it might be possible in the future. But yeah, I don't think so right now. But well, yeah.
Awesome. Yeah, if any other questions, please throw them in there. Otherwise, thank you very much, Wes.
Yes, sir. Thanks, guys.
And Wes, if you can just hand me back, there we go. Sharing permissions. All right, great. Okay. We have reached the last break of the afternoon. It is 2:25 now. Just for the sake of consistency, we'll reconvene back at 2:45, so we don't have to, change up the agenda at all. So we'll give you guys about 20 minutes to go grab a cup of coffee, go grab a bite to eat or whatnot, and then come back 2:45. We'll get rolling again. Thanks. All right, everyone, we're back from our last break of the day. This is the last home stretch of VeloCON 2023. So I hope everyone has their favorite cup of coffee or tea or matcha or boba or whatever will get them through the end of the day. We've got 2 more presentations to go. Falgun is back with us. He previously was here earlier in the day with Julia, but he is back with another member of the Aon team. And he'll be presenting on tracing the footsteps, a bird's eye view of lateral movement using Velociraptor. And joining Falgun is Kostya Ilyukovich, a senior DFIR consultant. Give you a quick background on Kostya. He is a senior DFIR consultant on Aon. His primary role is to lead cyber incident response investigations, such as unauthorized access or ransomware attacks, from initial scoping to containment and eradication. In his role, he has helped many organizations in various industries respond to incidents while prioritizing business operability in the safest manner. He holds a CrowdStrike, CCFR, and GCFA certifications. So Falgun, Kostya, take it away.
Thanks so much, Carlos. All right, welcome folks. Thank you so much for joining us at VeloCON, and we will be discussing how you can efficiently identify lateral movement and enhance DFIR investigations. So let's begin with our introduction. I am Falgun Kulkarni, and I work at Aon, delivering Strauss Friedberg's incident response and digital forensic services. In my role, I work on various cyber incidents such as ransomware, threat hunts, and APTs. And I love to come up with novel ideas and perform research to enhance DFIR as a whole.
Hi, everybody. My name is Kostya Ilyukovich. I am a senior consultant here at Aon, delivering Strauss Friedberg's DFIR services. My role, as you heard in the investigation, or rather in the beginning here, is to lead a various type of cyber engagements, from business email compromises all the way to kind of large cases and matters such as ransomware incidents. And today we are here to try to enhance your investigations. And the way that we'll be doing that is presenting various forensic artifacts that demonstrate lateral movement. We then will be discussing how we took all these separate forensic artifacts and implemented them into one single Velociraptor artifact. That Velociraptor artifact returns normalized results across all these separate forensic artifacts. And lastly, how you can leverage that to create visualizations of lateral movement in a type of node graph. And kind of the beauty of Velociraptor is that it's open source and it's always easy to change VQL as you want it. And as such, as new forensic artifacts are discovered or someone would want to implement a particular artifact into the Velociraptor artifact, that will be done through continuous improvement. To start off, I don't know about you guys, but I'm quite excited to go ahead and enhance my personal investigations in DFIR. The agenda that we'll be kind of following for today is we'll start off with an overview of lateral movement. What is it? How do we identify it? And then we'll pivot over into identifying some key forensic artifacts to identify this lateral movement, covering stuff like event logs, registry keys, as well as remote access tools. Then we will present our brand new Velociraptor artifact. What is the point of it? How does it work? Why did we create it? And then lastly, we'll talk about visualizing this data using the Elk Stack and Grafana, meaning how are you able to integrate all these tools to create some sort of visualization of your data?
Thanks, Kostya. Now let's talk about lateral movement for a bit. So in DFIR engagements, one of the commonly asked questions is how many systems were affected by a threat actor in a network? And to answer such questions, investigators need to enumerate lateral movement. So let's get to know what lateral movement is. Let me tell you a story. once upon a time, there was this beautiful unaffected network. But out of nowhere, one day a threat actor appears and decides to compromise one of the machines in the network. Now, once they gain the required credentials, they can move to any system in the network. And this movement together is known as lateral movement. So let's see how we can identify lateral movement. In DFIR investigations, we utilize forensic artifacts to extract the required information. So let's take a minute and discuss what a forensic artifact is. So basically, Windows introduces features which are aimed to improve user experience. Let's consider an example here. So on the left-hand side of your screen, we can see that a user can use jump lists to switch between multiple RDP sessions. But the same jump list, when parsed, can also be used as a forensic artifact and can get us the required information. So basically, Windows features are utilized as forensic artifacts. Now let's get to know more of such Windows forensic artifacts, which can help us identify lateral movement and that are also included in our Velociraptor artifact. And importantly, we also cover interactive as well as non-interactive lateral movement. Interactive meaning that the user input is required to access a remote system, and non-interactive means that a user input is not needed to access a remote system. So let's begin by talking about Windows event logs. Now, event logs can contain a lot of information which can be helpful in DFIR investigations. So let's begin with security event log. Now, whenever a user logs on to a system, that activity or that event is tracked in the security event log. And thus, it is one of the most commonly used artifacts to identify lateral movement. We begin by addressing event ID 4624. It suggests that a success account was logged on successfully. And this event ID can be found on the destination system. And we categorize this access as incoming access, meaning that a user accessed the destination machine from a source machine, so that the access is coming from a source machine. We represent it by a red arrow. Next, we have event ID 4648. This suggests that a user tried to access a remote system or destination system using explicit credentials. And we categorize this access as outbound access, meaning that this artifact or event ID can be found on the source system. And it is represented by a blue arrow. So basically, if you see a red arrow in the further slides, it means that the access type is incoming. And if you see a blue arrow, it will mean that the access is outgoing. And similarly, we include multiple event IDs from the security event log, which symbolizes successful logons, attempted credential validations, reconnections, and network share access as well. Next, let's talk about the system event log. In system event log, we specifically target one event ID, which is 7045. And this event ID symbolizes a service is installed on a destination system. And to be more specific, we only target PSExec service install, which can be found on the destination machine. Now, why do we include this event ID and specifically PSExec? So at times, threat actors will utilize PSExec, which is a built-in Windows utility, to either access a destination system or execute a remote command. So it can be helpful in determining how a threat actor either access the system or executed a remote command. Next, let's talk about RDP or Remote Desktop Protocol event logs. Now, RDP or Remote Desktop Protocol is one of the most commonly used methods by threat actors to move laterally in an environment. So we include event ID 131, which means that a destination system accepted a RDP connection. Next, we have event ID 1149. It suggests that a RDP authentication was successful. And we also include event ID 21, which means a successful RDP logon. Now, all these three event IDs can be categorized as incoming access, meaning that these event IDs can be found on the destination machine, and the information will also include the source IP as well as user who was associated with the activity. So let's talk about outgoing RDP access. We enumerate event IDs 1024 and 1102. Both of these event IDs suggest that a user tried to access a destination system using remote desktop protocol. And as I mentioned, we can categorize these event IDs as outgoing access. And sometimes threat actors may also utilize WinRM or Windows Remote Management. Again, this is a built-in utility which can be used to access a system remotely or execute remote commands. So we enumerate event ID 6, which means that a remote connection was established from a source to a destination system. And this event ID can be found on the source system, which will contain the information about destination system. Next, we have event ID 91, which suggests that a destination system received a remote connection from a source system. So it can be important in identifying how threat actors move laterally or access multiple systems at the same time. And lastly, for the event logs, we also include server message block logs or SMB logs. Now, SMB, again, is a built-in utility which can help computers talk to each other in a network. And threat actors can also utilize this feature to either access or execute commands. So we include event ID 3000, which means that SMB was used to access a destination system from a source system. And event ID 30806, which symbolizes that SMB connection was re-established. So we can correlate both these event IDs to determine when was the actual SMB connection established. Again, all these event IDs from various event logs can be helpful in determining lateral movement as well as remote command execution.
All right, now let's talk about some registry keys. Particularly, we'll be focusing around the anti-user.dat hives that are found in user profiles. And a lot of the keys that are found and we'll be talking about here are used to either supplement or to enrich either gaps of visibility in your logging, or essentially to correlate against your known good logs just to ensure that something did occur. So first up, we'll be talking about the terminal server client keys. Particularly, we'll start off with the server's key, which contains information about systems that were accessed leveraging the remote desktop protocol. And the information in here, or particularly the data value, would include the host name and the user associated with that remote system. Next up, we have the default keys. These keys also, likewise to the servers, contain information about remote systems access leveraging the remote desktop protocol. And in here, we'll see a value name MRU and most recently useless, which suggests some order of access, with MRU 0 being the latest. Next up, we have the network keys. And these in particular are kind of in and around your SMB activity. So subkeys will contain drive letters of mapped shares. And the remote path actually does include the map share name itself, which you can leverage to determine the destination system that was accessed. Then we have some more Explorer keys under current version. We have mount points 2, which includes the name of the remote share being mounted or mapped on the source system. This could be, again, leveraged to identify some type of SMB access and this would be non-interactive part of the overall artifact. And if you don't have, for example, SMB logs and you're trying to correlate a type 3 logon, you can try to reach the source system and see, okay, well, this activity would explain my other logging that I'm seeing. Then we have map network drive MRU, and the data contains mapped remote shares. And again, it is an MRU list, so it does suggest some order of mapping between latest to earliest. Some more keys found in here. We have the MRU, run MRU. Again, another most recently used list, but particularly revolving around the run utility built into Windows. And it does, depending on how you use it, can contain some critical information in regards to lateral movement, either through SMB or for something like RDP. There is also an MRU list, as the name suggests, so it does have some indication of ordering in terms of most recent to latest. Then we have typed paths. So this is a key. This particular key is related to typing something in your Explorer window, and it may contain information on remote shares being accessed via the Explorer window. And it does have some a quasi kind of MRU listing based off of the URL value, with URL 1 being the latest that was typed. Next up, we'll cover some shell items. Now, similarly to all of the other kind of SMB registry keys that we covered, as we may know, shell items are typically used to identify data access. But what if that data access is a remote system? So that's something that we could leverage to identify some sort of non-interactive lateral movement from a source to a destination system. So our two kind of interests here would be shell bags. So shell bags are populated when a user would interact with Explorer window, particularly on folders, and that's when they get populated, and they're found under the shell bag MRU of both the NT user and the user class.dat file, and the LNK files, which are found under the most recent of your user's app data folder. And in here, we'll see also potentially, if it does exist, remote access that contains either their host name or IP or a share name of the destination system being accessed. Now, one of my personal favorites, and this has definitely helped me out quite a bit, is user access logs. So user access logs, before we kind of dive into it, are found particularly on Windows servers 2012 and above. Why do we really care about user access logs? Well, typically, I don't know about you guys, but when I'm in a DFIR investigation and I have a really key critical server that I'm trying to identify lateral movement, I only have logs for like a week. And at that point, how do I identify whether or not a particular system was accessed by a user? Well, that's when user access logs can become quite pertinent, as the data that's recorded in them, depending on the roles of the server, can be very key to identify some sort of lateral movement and help to point you in the right direction. So in here, in this particular system32 log files, you'll find a couple MDB files. They are just the ESC database, and kind of the first one that we'll talk about is the current one. This contains information on kind of remote access based on the roles assigned to the server itself, but it'll contain information regarding the source system and the username and that type level of access that's related to the roles, and that could be leveraged to identify lateral movement when you do have a big gap in logging. Furthermore, the system identity MDB file will contain information regarding the roles themselves that are assigned to the system. So that could be leveraged to identify, okay, well, what was the purpose of the server if you don't necessarily have a good line of contact with your client? Otherwise, there are also GUID based MDB files, which would contain information and data for up to 2 years prior of the current year. So again, let's say you have a lack of logging and you have quite a big gap in your visibility. You can, if they're available, try and use the user access logs to correlate and try to identify lateral movement that you perhaps are not able to see elsewise in your security logs. And particularly when it comes to our artifact definition, we have a key few roles that we're kind of interested in particularly, and we filtered for them specifically. This would be anything regarding to a file server, remote desktop, web server, or FTP server. The most common one that you'll probably come across is a file server, as nowadays almost anything is a file server, especially when it comes to Windows servers. But regardless, that's typically what you would be expecting to see, at least in some sort of level from a UAL perspective. Next, we have remote access tools. So before we go on, what do we mean by remote access tools and why do we really care about it? Well, as we've seen kind of in the industry as a whole is that threat actors have begun to pivot into leveraging remote access tools to ensure they maintain persistence within an environment. So this might be something like TeamViewer, might be something like Screen Connect, something like Splashtop, but it could also be other tools such as legitimate administrative SSH level tooling, such as WinSCP or PuTTY. And these tools can be leveraged by threat actors to establish, remote connections, either outgoing or incoming into a system, while also trying to blend into their environment. And this is particularly something important where a threat actor might notice that, for example, Screen Connect is deployed within an environment. As such, they would go ahead and deploy their own Screen Connect instances across the environment to ensure that they try to blend in as much as they can. So when it comes to remote access tools, there are already some pretty great artifacts available, both built into Velociraptor and on the exchange. When it comes to our Velociraptor kind of artifact itself, we incorporated the TeamViewer incoming artifact to parse the TeamViewer logging that's left over on a system. And the AnyDesk, there's two kind of competing exchange artifacts right now, the AnyDesk applications and applications AnyDesk log parser. We leverage the AnyDesk at the very current moment, but both are pretty great. Moving on to WinSCP. So this is one of those tools that are legitimately used by many administrators, and we typically do see it used by threat actors to establish SSH connections to destination systems, whether that may be to potentially try to pivot from a Windows environment into the Linux systems, or perhaps for methods of exfiltration, right? They're trying to connect to their remote system somewhere on the internet to exfiltrate data. So in the ntuser.dat file, you'll find a couple keys under WinSCP2, Martin Pericrian software share. There you'll see a sessions key, and all these keys really contain more or less the same data, and that would be the host name or IP of the destination system being accessed, and because it's an ntuser.dat file, you can have the user associated with it as well. The public key is also stored in the sessions information, give you information on the destination system, and the data value would also include the host name of the remote system. We have SSH host keys, contains, again, information about host name and IP of the destination system, the user associated with the activity. Last fingerprints contains information about host name and IP of the destination system. And as if I'm on repeat, CD cache does the same thing, contains information on host name and or IP of the destination system being accessed. So all of these four keys can be used together in sequence to try and correlate when a particular connection was made, leverage WinSCP. For SSH access, let's say a Windows system is running OpenSSH. If you're lucky, the OpenSSH is logging into the OpenSSH operational EVTX log. Now, this log is pretty cool. It contains lots of information in terms of inbound connections. Logged as EID4, it'll contain information on either successful or failed attempts. And that could be leveraged to identify successful authentications through OpenSSH. For Atera, there is a software key that is added into your system when you do have an inbound connection, and it does contain hostname, the email associated with the instance, account ID, and agent ID, and that could be leveraged to identify when a particular connection inbound was made to a destination system. For PuTTY, you'll find pretty much the same information as WinSCP. One of them would be the SSH host keys, and that contains the host name or the IP of the remote system being accessed via SSH. For Splashtop, there is a software key that is installed under WoW 6432 node, Splashtop, remote server client info. That will contain hostname, IP, and email associated with the instance of the source machine being accessed into the destination system. There is also sometimes a event ID 1000 that's logged in your application log, which does contain hostname and email. We've also seen sporadically a Splashtop event log itself, although in our testing, we haven't really been able to concretely reproduce it to the effects that we would be able to incorporate into our artifact, but that's something that's a work in progress. For Screen Connect, there is a event ID 100 that is logged into your application log. Unfortunately, it's not very descriptive. All you really have is that a cloud account administrator connected. That could be used to leverage and figure out that some sort of remote connection was made to the system using Screen Connect, although it doesn't really give you a lot of information on what that host system was that made that connection.
All right. Thank you so much, Kostya, for walking us through all the amazing artifacts which we can use to identify lateral movement. Now, let's talk about the Velociraptor lateral movement artifact and why we decided to build it. So, Kostya, let me ask you a few questions before we move ahead. So how do you parse multiple artifacts and analyze them?
Well, typically I would start running hunts one by one for particular type of lateral movement or exfiltration that I would want, and then I just go through them one by one.
Okay, and let me ask you, were you aware of all the artifacts which we discussed in this presentation?
No, I was not.
Okay, and lastly, let me guess. You also spend time cleaning or extracting useful information from multiple artifacts one by one.
I do. It involves a lot of copy pasting.
Yeah, isn't it efficient? Yes.
Yes.
All right. So let me tell you why we built this plugin. Sometimes investigators may not be aware of all the lateral movement artifacts and they may miss some of the artifacts. So in our artifact, all the lateral movement plugins or most of the lateral movement artifacts are included in a single artifact. So you don't have to search for multiple artifacts or worry about missing some of them. So everything is in one place for you. Next, examiners may need to spend time extracting useful information from various kinds of outputs from different artifacts. So our artifact gives out normalized results, meaning that every artifact result will have same headers or same columns, so that you don't have to extract useful information from each and every artifact. It's already done for you. And lastly, our output is in a format that can be easily integrated into your master timeline, as DFIR investigations most of the time needs to enumerate the entire lateral movement picture to identify what actually happened in the network. So isn't this pretty cool? Like all of the excruciating and hard work is already done for you. You just need to click few buttons. So let's see how this artifact actually works. Like we mentioned before, we include a plethora of Windows Forensic artifact and combine those artifacts into a single lateral movement artifact, which is highly configurable, by the way, and Kostya will be talking more about it in the further slides. Next, we output normalized results, and these normalized results will contain a master sheet, meaning that all the results from all the artifacts will be included in one sheet. So you don't have to stitch multiple artifact outputs to create a timeline. It's already done for you. You also get individual results. If for some reason you only want to analyze security event log results, you can do that as well. And both of the master sheet and individual results will contain normalized columns. To highlight a few, we have event timestamp, source and destination system or IP as per the availability, and the user account which was associated with that activity. So Kostya will be talking more about it in the further slides.
So all the forensic artifacts that we have kind of talked about so far today are the ones that we incorporated into our artifact definition. This was inspired by various cyber incidents that we've covered many times using Velociraptor, and it's usually our first go-tos that we typically like to grab right away before anything starts rolling over and we have a very large gap in our visibility 3 days into a DFIR investigation. It does also include remote access tools that we've discussed, as we've seen a lot of threat actors pivoting over into using them to maintain persistence into an environment. That doesn't mean that we've covered all of them being used. It's definitely a work in progress. And as we see more tooling being used by threat actors, they could be easily incorporated into the definition. At the end of the day, all the artifacts are in one single place, in one single definition. So instead of having to run separate hunts to cover everything, you just have to launch this one definition, and that's all that is required. And it saves you a lot of time. And in terms of what we mean by it's easily configurable, as we'll go through a couple of these slides next, we do have the ability to parse by dates. We have the ability to limit your users to, for example, a particular regex of interest that you want. By default, we disable all the system accounts, and we'll see a little bit more as we go along. But at the end of the day, with the beauty of EQL, anyone can add to their own or borrow the definition and add to it as they wish. So how did we do the whole master sheet? It's a little bit of, I guess, some VQL voodoo, and this was a really cool implementation in my opinion. So essentially, we have different sources for each and every single artifact. So for example, the security log is its own source step in the definition, user access log, remote desktop, etc. And then essentially, we only have one precondition. So that means that all the sources run kind of in a waterfall pattern. And that means that we more or less have kind of a predefined order to our notebook. So what we do is we just hijack the first notebook cell by adding in our own notebook definition. And in there, we basically have one giant chain that combines all the output sources of our plugin as they populate. We do limit each one by 50. So that's something you do have to consider. If you want to only include 50 of your security, but everything else, you can just remove it or just do a find and replace on limit 50 for nothing. And then because we're hijacking that first notebook cell, we do have to explicitly add that first definition for the notebook, that being the security log. So you will notice that in the first source, the security source, there is a notebook section defined, and that's how we implemented that master sheet. In terms of the output, so here we have an example of the output of a master sheet. We only took a screenshot of 2 entries, but we have terminal server registry as the artifact source here. And it gives you kind of this prefix of what are our normalized outputs. And we'll discuss them in a little bit as well. And then if you go, you can also see the individual output for that terminal server registry where we have all our terminal server modified keys. And in terms of the columns that you may have just seen, you'll notice that event time, going left to right, is the first column. The event time depends on what source the artifact it is. So when it comes to event logs, it's when the event was created or generated. But when it comes to registry keys, it's when the key itself was modified, and that's the time that we had decided to use in our event time column. Next, we have the description, which provides a short description to the analyst of the type of activity. And then we also have the artifact source right beside it to specify where the information originates from more concretely. Then we have the source system. So this would be a host name if it is available in the data itself, or a source IP alternatively, or both. If they're both available, that would be great. But sometimes we don't really have that information. And likewise for the destination system, we have the destination system host name if it's available, or the IP if it is available. We would love to have both, but that's not always an option. Then we have a user account, so the user account associated with the activity. So for example, in a 4624, it's the account that logged in. On some event logs, you only get an SID. In practice, we do notice that, especially on systems that, or rather environments that don't necessarily have a proper Active Directory going, the lookup between SID to username is not very consistent. So we do leave it as an SID for now, and that's something that we would be thinking about changing later. Direction, we have incoming or outgoing, just to specify more concretely, hey, this is an incoming connection to this system, and this is an outgoing connection to the system in regards to where that data was parsed. Then we have an additional information column. So in this column, it's a little bit of a kind of a special one. It's a dictionary that just contains additional information about the specific data set that you're looking at. So such an example would be like a 4648. Typically, you have your originating and your destination usernames. So that's something that we, for example, would put into the additional information just so you have both of those username sets available. Or for example, for something like shell bags that we had mentioned where it would demonstrate some sort of non-interactive lateral movement, we have the full path just in case you're interested in it. And here we're going to be kind of going through an example of us running the hunt. So we go ahead and we select it. You'll notice that we have a description on basically every single source that we have built into the artifact, with a couple key notes in terms of, for example, for shell bags, you'll notice that we do say it's very expensive, and in our testing, that's typically the one source that does take the longest of time. So we do have it turned off by default. When you do start to configure it, you'll notice quite a lot of configuration abilities. Firstly, obviously the VTX path, and these get passed down either to sub artifacts that we call, such as the user access parser, or something that we implement just in our raw VQL. We do have system accounts disabled by default. We also remove anonymous logons by default, but that might not be something that you want. You know, anonymous logons can be very important to identify during an investigation. So that's something that you can just switch off right away. You'll see the user account regex that you can use to limit your data set to only a particular set of users that you would be interested in. Obviously, the data after, date before, we've seen them in plenty different artifact definitions, just to make sure that you're not collecting data for 3 years. Then we have the sum glob and some other kind of information that, again, we pass into the rest of kind of the sub artifacts that we call. You'll see a lot of switches for event IDs, just to make sure that, you know, if you wanted to, you can go ahead and remove it from your output. For example, for a 4672, you probably have the respective 4624. Do you really care about whether or not it was an administrative logon? You might. So by default, it's enabled. But if you really don't, you can just go ahead and switch it off, and it won't be reported back to you. So we do have event ID switches for pretty much almost all of the event IDs that we do include. And at the bottom there, you'll also notice that we have the disable shellbag switch, which by default disables shellbag parsing, but that's something that you can include if you so wish. So I'll go ahead and skip through here a little bit. Well, we missed it, but I was trying to show you how fast that the actual artifact could be. Essentially, because we're only parsing the event log, it's very, very quick. Well, the event log and registry. So in total, it doesn't take a lot of time in terms of running on a target system. As we kind of already know, let's say you run an EVTX under, you know, targeted your security log, just parsing 4624s. It's typically going to be very quick unless your event log is gigantic and you have it changed based off of your default settings. But it's very fast. At the top here, you'll notice that we have our master sheet right away at the top. Again, by default, we do have that limit 50 on each and every single source. So that's something just to consider and remove as you so wish. And then as we scroll down, we'll go to our individual outputs. So the first one being the security log. And again, it kind of goes down based off of the source definitions. And all right, I'll pass it back
All right.
to Falcon.
Thank you, Kostya. So now that we know how the lateral movement artifact works, let's take a look at how we can visualize the results generated by the artifact. And here we provide one example or one way via which you can visualize the results. So we begin by pushing the Velociraptor results or the results generated by our lateral movement artifact to Elasticstack. We then connect Grafana to Elasticstack and import the desired index from the Elasticstack into Grafana. Now, why we import index is because Velociraptor, when we push results from Velociraptor to ELK-stack, the results will be saved in a form of an index. So that's the reason we need to import the index into Grafana. And in Grafana, we will be creating a node edge graph of the desired index. So let's see how the visualization process actually works. Like I mentioned, we begin by pushing Velociraptor results to ELK-stack. We can do this by utilizing a custom-built server-side artifact. So you can go to server events and then search for custom elastic lateral movement visualization flows uploads. It's quite a mouthful. Yeah. It is based on the already existing elastic flows upload. The only difference is we tweak the results from the lateral movement artifact to cater to needs to Grafana software's node edge graph. So basically, Grafana needs data in some format for it to create a node edge graph. And that's what this server-side artifact is doing and pushing those tweaked results to Elasticstack. Next, you can go to Kibana, and in stack management, index management, you will be able to enumerate or see the index which we push from Velociraptor to ElkStack. Now, one thing to note about these index is these will be appended by underscore visualization. So that's how you know you can use any of the visualization index to import into Grafana and create visualizations. Next, you go to Grafana, you add a data source as Elasticsearch. You can search for Elasticsearch and it's already built in by default in Grafana. Next, you can give any appropriate name, the URL where the Elasticsearch is existing or is residing. Next, we copy the index, which we just enumerated from Kibana in stack management and index management. And importantly, you need to change the time field name from the default @timestamp to ID. And this is because we tweak the results generated by the lateral movement artifact to cater to needs of Grafana. And if everything goes well, you will see the index OK message and you can start building a visualization. So you can select between multiple data sets, but for this example, we will be selecting from the RDP event logs. Now, once you hit the dashboard console, there are 3 things to keep in mind. You need to change the metric column from count to raw data so that Grafana will be able to ingest that data. Next, you can change the time frame according to your investigation needs. And lastly, you also need to change the format of the graph to node graph. And once all that is done, you will see a beautiful node edge graph into your console. And you can also click on any of the edges or the arrows, and that will show you additional information such as the source and target system, the user account associated with the activity, as well as the description of the activity. So isn't this pretty cool? All you need to do is click few buttons and a beautiful visualization of your desired artifact will be on your console. It will save you a lot of time to manually create the CSV sheets for multiple visualization softwares and save you from some frustration. And that's how visualization works. Again, this is one process, but there are multiple processes which you can use, but we just decided to use Velociraptor, Elasticstack, and Grafana.
All right, now let's talk about the key takeaways, everything that we've already talked about here. So firstly, what did we learn? So we learned various forensic artifacts that cover stuff like event logs, registry keys. We also talked about various remote access artifacts, covering AnyDesk, Screen Connect, TeamViewer. We showed how you can take all those separate forensic artifacts, combine them into one single Velociraptor artifact that could be made highly configurable and customizable as the end user wishes. And lastly, those results all come out normalized individually as well as in one master output for the end user, making it very easy to match it to timelines if you so wish, or it could also be pushed into visualization software, such as using ElkStack and Grafana. But there are many other options out there. And kind of the key visualization we typically always care about when it comes to seeing some sort of lateral movement is a proper node edge graph. For the future, we've talked about a couple of things already that we would like to implement, stuff like the SID mapping, but as other Windows forensic artifacts are discovered, and there are plenty that are discovered every year, we would be circling back and adding them back into our artifact, as well as as we go through investigations. That's definitely something that we would like to keep updated as we move along. We'd also like to explore creating separate artifact definitions for Linux as well as Mac OS environments, and working on the visualization process. As we've already mentioned a couple times, it's not set in stone. A really great tool that comes to my mind right away would be using Jupyter Notebooks and D3D Graph. There's already a really great blog out there that talks about integrating Velociraptor into Jupyter Notebooks, leveraging Velociraptor API.
All right, and you can get your Velociraptor lateral movement artifact today from your nearby GitHub stores. So scan the QR code and it will take you to our GitHub repository where the YAML files exist. And if you found this talk to be insightful and if you learned something new, be sure to follow us on Twitter at StraussDFIR and keep in touch with our latest thought leadership content. We would also like to give shout out to a few people whose already existing artifacts were used as inspiration for building our Velociraptor artifact. And these are the meme sources. Lastly, I would want to mention that we used Velociraptor 0.6.9 and Windows version 22H2 in our testing. We encourage you to do your own testing, but your results may vary based on the build numbers. And thank you so much for joining. We really appreciate your time.
Thank you so much, Kostya and Falgun. Falgun putting in double duty today.
Yeah.
The morning and the afternoon shift. So thank you very much. Really appreciate it.
Yes, sir.
I don't think there are any questions in the queue right now. So you guys are off the hook. But if anyone does have any questions for Kostya or Falgun, please submit them. They've been doing a great job of, after the first presentation, going in and answering any questions you guys had. So I'm sure they do the same after this presentation. All right, we're moving right along here. We are at the last presentation of the day.
Hi.
And we have
Hi.
a familiar face who's going to give us a peek back into the year that was 2023, a little bit of 2022 as well. And then a little peek ahead, possibly to the rest of 23 and 2024. So Dr. Mike, take it away.
Thanks, Carlos. So as is becoming traditional, we always close off the conference, the VeloCON, every year by recapping what we were up to this year and just looking at the kind of development in the tool and the different kinds of things, and it's just kind of a bit of a whirlwind tour of what happened in the last year, so we can be a bit nostalgic and realize what where we how far we've come this year. And so I'm going to go through and just give everyone a quick highlight of some of the features that I found really cool. Of course, there are many more, and we won't take too long talking about them. So let me just quickly share my screen. Yeah, this one. Can we see that? Yeah. Okay, cool. Can you guys see it? Yeah. All right, great.
Yes, looks good.
Cool. Okay, cool. So yeah, so this year, what happened? So the latest release is 0.070, which came out in the last couple of months, and we've had a lot of community engagement, stability, and bug fixes, and it's a lot faster this year than it was last year. So performance improvements around the around the tool. So one of the really cool things that we worked on this year was getting the NTFS parser to be much more solid and fuller feature, and that is really important for a number of forensic type analysis. One of the cool things was that now we handle hard links in the MFT. And a lot of people don't know this, and I guess I probably didn't know about it either. That an MFT entry can actually contain multiple file name streams. I mean, people know about long name and short name, but you can actually have many more names. And the way that the MFT entries work is the file name stream actually contains a pointer to the parent MFT. So we can't really speak of an MFT having a parent, because it's not the MFT that has entry that has the parent, it's the actual file name that has the parent. So that means that because you can have lots of file names in an MFT entry, and each MFT entry can have a pointer to a different MFT entry that's the parent of that MFT entry, but it doesn't have to be, they don't have to be the same pointers. So they can go to different pointers. So what that means is that you can actually, when we are reconstructing the path names, we're going up and in multiple paths. And so we can actually end up with multiple full paths for one MFT entry. And we couldn't do that until this year. And so we did a big revamp of the NTFS parser and MFT parser so that we can do these things. And it turns out that these things are called hard links. So and they're actually quite common. So if you look at the MFT artifact, you'll notice, so it's actually a hidden field. So you'll have to look at it in the row response because it has underscore as the first character. So the GUI kind of hides it, but we are actually showing all the paths that linking to a file. So here we can see Notepad, and you can see how Notepad actually exists in multiple different places, but it's actually the same Notepad and it's the same MFT ID. It's not a copy, it's really just the same file. But we have to, so that means that if we are searching for files in different paths, we really need to consider all of these paths, not just, we used to just report the top one. And so, the more usual thing is to look at, the first one. And so, so that was kind of the, the old way, but it's still shown that way to remove, confusion. But really, we are looking at all of those different hard links, right now. So that was pretty cool. The other cool thing that we managed to do this year was to implement encryption on the offline collector. As you know, the offline collector is used to collect artifacts into a zip file, and then we deliver the zip file through clouds or whatever number of other ways. But the problem is that the zip file contains potentially sensitive information. So it's kind of risky to just have it as unencrypted, because it could be compromised in transit as it's getting to you. So we used to have this zip file password, so we could encrypt a zip file with a password, but that is not good enough because the password has to be like in the embedded config file, so that because it's a symmetric password, right? So then the offline connector could store it with that password. So as of 067, we actually have asymmetric encryption in the offline collector. So and that works it's very easy to use. And so because it's such an improvement in security for the offline collector, and it's actually really easy to use, then I would recommend almost always using it. And so that actually ensures that the zip files are protected, and you really can't decrypt them except for if you have the private key, because it's an asymmetric encryption standard. And the way it works is very easy. You just turn on the encryption scheme here when you're creating the collector. And what that does is it uses the server's own certificate to basically create this collector. So it puts its own public key in the config file, and then when the offline collector collects the thing, it generates a random password and encrypts that password with the public key of the server, and then encrypts the rest of the zip file with that password. And so there's then you can't really get the password unless you have the private key on that server. So the server can decrypt it, but then nobody else can in transit. And so this is the most recommended way. It's really easy to use. Just turn it on and it works. And then when you collect the file, then you end up with basically metadata So it looks like so you have a zip file, and then inside of that you have a metadata file, which is, you know, obviously unencrypted, but it has the encrypted password here, and then the public key of the server. And then the server can then verify the public key, and then it has the private key, and then can decrypt the password. And then the actual data is sitting inside another zip file inside the first zip file, sort of thing. So doing it this way means that the encrypted file is protected. It's actually a pretty cool feature. So you know, dealing with these offline collectors, you know, has really improved this year. And it turns out that because a lot of people use the offline collector, you know, and it's a kind of a popular feature for Velociraptor, but it's actually useful not just for offline collection. So, you know, back in well, quite a long time ago now, about a year ago now, Eric Capuano has actually done a exercise in the Open SOC DFIR challenge, and it was a really cool exercise. It had Velociraptor and it had some data. And back in that time, we didn't really have any way of actually sharing that data. Like, so it was in the server, right? But there was no way to easily export it, and in a way that, you know, that we can import it back. So it ended up being very difficult for him to share that, you know, with the community after the event, and sort of like take a backup of the server, right? So it became apparent that we need a way of actually being able to export and import collections. So we could always export the collections, but you know, we used to basically just export them as a random zip file, and then rely on other tools to, you know, to parse it in an ad hoc fashion. But we needed to have a standard format that we could use so that we can re-import it again. And so this is kind of the thing that prompted this feature, so that you know, when people wanted to export data, they could easily export it in a way that can be imported back again. So now we have a very like structured like zip file with a structure in it, and all the metadata in it, like, for example, what exactly was collected as part of this collection, you know, and the logs, and, you know, all this kind of stuff. So all of the information that we need to essentially reconstruct it is now stored in the collection, and then we can use that to import it again using this server util import collection. We can import it back into the server, so you can move collections from server to server, back them up, you know, that kind of thing. And so we're using the same format, the same internal format for the offline collector, as well as you know, for the exports. Like, you know, if you go in a collection and hit exports, that's producing the same kind of zip file, right? Cool. So that was really useful. That was a pretty huge feature, but you can't really talk about it that much. But client server protocol has been revamped, so we've got much faster client server. So we used to do a lot of work on the server in terms of just keeping stats and reassembling, you know, like statistics of what the client was doing, and that slowed down the server and, you know, slow down the client. So what we've done now is moved a lot of that bookkeeping type work down to the client, so it does all its own stats and so on. And we just kind of on the server, we just write it. So it changed the protocol, and it made it a little bit faster. And so now we are a lot more scalable. So, you know, we used to say that it's, you know, one server for 10, 15,000 endpoints. And I think now it would be much higher than that because of this protocol change. The virtual file system was really bad. So, you know, because it was never really kind of like a core feature. And so we kind of had it there because it's kind of like it was a, you know, a layover from GRR, but you know, but then people actually kind of like it, and they like to use it. So this year we've really kind of invested in trying to make that virtual file system better. It used to be really slow, and because of the way that the data was stored. And so you couldn't really use it for very large directories. Like if you went to the Windows directory and try to like download that would usually kill the browser because it loaded the whole directory into the browser at once. And so if you had like a lot of files, like in the Windows directory or Windows System 32, it just didn't work. So this new design means that we can use these page tables, so we can page the table, which we couldn't do before. And that means that we can have very large, oops, I think this one, yep. So if we can zoom in, we've got a very large number of files in this directory that we can manage, now, so there's no limit anymore. And it can be very fast. And because of this, we can actually do, we can click this recursive download. I mean, you can actually do it for the whole disk, and it actually doesn't take like that long, maybe like 5 minutes or so. So you can actually refresh the entire disk, which we couldn't do before because it wasn't as efficient. So now it's super fast. The other cool things that we invested in this year, the time to improve VQL and made it more stable. One of the problems that we had was that in VQL you can it's essentially a programming language, but you could do certain things that would be really bad, and it was very hard to kind of like explain to people like the differences between certain things and the kind of resourcing implications of those things. And so what we now are starting to do is more and more develop defenses in the language so that we don't fail in a catastrophic way when people do the wrong thing. So one of the examples is the materialize query. So here we have the materialize query, and if you read the documentation, the difference between a let equals and a let less than equal is that a let equal just defines that as, it's like a function definition, basically. It just defines it as a query and stores it into the variable. But when you're using this less than or equal sign, then it literally it's called the materialize operator. We're literally running that query and storing all of the data inside a variable called X, so as the data, as the raw data. And there's reasons for why we want to do it, certain, for performance and things like that. See, this kind of query is difficult to judge, right? Because if the glob is not too bad, then it might be like 10 files, it's probably fine, right? It might be 100 files, it's still fine, but this glob could easily, match thousands of files, and then we're trying to stuff thousands of files into memory. So the point is, this kind of problem, this kind of language feature it's bad when you get it wrong, because then we used to have these issues where people would write a query and then the memory would just go out of control, right? And then and that's running on the endpoint, so it's actually really bad. But it's actually also difficult to determine how many files would match in the first place. So it was really important to make sure that this actually didn't explode, didn't increase its memory use like in an unbounded way. So now what we are doing is that we are storing it in memory to a point, and then at some point we switch to disk and we start writing on disk instead. And we do that transparently, so you don't really need to worry about it. So it's actually become safe to do this kind of operation, which was really, really bad before, very dangerous. And the same thing in a glob, when we're in a group by. So when we're doing a group by, is we're trying to kind of difficult, because we can't predict how many groups there are. So now we also switch to disk-based algorithm, which is slower, but at least it's safer. So these kind of VQL improvements really help. The other really the other really helpful thing with VQL that a lot of people have been struggling with is trying to debug VQL, trying to understand what is going on exactly in this query, and why am I not seeing the columns that I think I should be seeing, or something like that. And so we actually had added the explain keyword, which allows, which is essentially it's like a trace of the query. As the query runs, it tells you what it's doing at every step of the way. And so in this case, you can see that it starts to explain this, and then it calls the clients plugin here. And then the clients plugin starts to send the first row, and then we can see all the data in the row and the types of all the columns, and then it's evaluating the where condition. And in this case, it's rejecting it because this expression rejects it. And if we look at the last seen at, and then, we've got, we've got the time, and that is what was called. So anyway, we can get a lot of information about why a row is rejected. And that's helpful to try and understand, what's happening in the query as you're writing it. Then we have a bunch of GUI improvements, trying to help. Oh, there was some questions, sorry. How many endpoints can Velociraptor handle with 070? So yeah, we recommend 10 to 15. We probably maybe 20 is the recommended thing, but people tell me that they're running about, the largest number was 60 to 80,000, but I think that's ridiculous. So I wouldn't go there, but maybe like 30,000 is probably fine. Also have a plan to improve multi-fronted server. Yes. Some data like user storage info on the homepage still not available. I'm not sure what you mean by users, but we can talk later. Okay, so we added some filtering in the UI. So now the filtering here, and what happens here is this is just filtering the UI. So it does like a temporary table. It creates a temporary table and uses that to do the paging. So basically we can easily, so it's sort of the same as the VQL, but in the notebook, but it can be done on any filter, on any table now. And then we have this built-in hex viewer, which is actually really kind of handy. So if we grab like, if we look at any of the files, so this is a file, oops, hang on, sorry. And then we have a preview, right? So this is our preview, and so we can actually search for things in the file itself. So like user, there should be something. So we can actually search forwards and backwards, and so it's actually really, this is a regular expression match, right? So we can actually search, for any match like that, or we can match, strings, hex strings, and then just go to offsets. But this is really handy for just a quick overview to just see if you download a file, and all downloads now have this, preview type thing, so we can quickly search for it. And in 070, we actually got a very fast client search index. So this is where we can search the clients here, and that's now done in a very fast way, and we have a much more efficient indexing here that works. That goes back to your question, Azim, to especially on multi front end. It's actually a lot faster because we manage, we have much more compact storage. So we can actually report now the total matching clients because we have such a fast index, and we handle a lot more clients, and we have a page table, so we can actually page them, which before we couldn't page to the end. We couldn't go all the way to the end. So if you have, a lot of, let's switch to this one. Show all, then we actually can go to the end, and we can page to any of them, and this number we know how much. So the paging is much better than it was, so it's pretty cool. Okay, and then we talked about some security issues, security improvements. We had a number of security improvements. People were really concerned about, so we have this super powerful, Velociraptor, and it's really powerful, and we can do all these hunting, and that's great, right? But what happens if, one of my Velociraptor admins falls for a phishing scam or something like that, and then their account gets compromised, and you know, you know, their password is compromised or whatever, and then the attacker gets access to the console, right? And that is actually a really serious concern, right? Because it is a powerful tool, and then you have, you know, someone could gain access to the console by, you know, compromising credentials or whatever. And so, so, you know, a lot of people were doing things like they didn't want to have it deployed, but they did want to have it deployed. So they wanted to have it deployed, but it was down, it was turned off until they wanted to have it, until an incident happened, then they will turn it on. And that's it's very cumbersome to work with it. So now we have this thing called lockdown mode. And lockdown mode is super easy. You just turn, it's a config file option. You just turn it on, and then the server is in lockdown. And that means that it cannot actually be, it cannot issue any new collections. It cannot do any new hunts. It cannot do anything, but it can read the old data. And if there's existing hunts, it can still read it, but you just can't, you know, start new hunts without, you know, removing that config option. So it's a little bit harder. So it's another layer of security there. So you know, in an incident, you can turn that down and go into full active mode. But you know, otherwise you can just have it like in lockdown. And then the next level up is, this is more useful for people who have like a shared Velociraptor server with a lot of other users that are not necessarily trusted. And so, of course, because you know, you realize that if you're running plugins, you know, in the server context, so you know, in server notebook, then they have full access to the server. So we can exec v anything, we can run, we can read files. So in the normal deployment scenario, you have, because you might need to do that, you might need to run another tool to do some post-processing or something like that, right? But it's that kind of trade-off sometimes, depending on the environment, is not always you know, possible. So it's possible now to create an allow listing on the you know, in the config file, and that literally prevents certain plugins from even loading. So Velociraptor can't do them anymore. And so when so that is a way of locking down the server. We can also do IP filtering now on the UI. So when you know, when we use Let's Encrypt and there's only one, you know, SSL certificate, then you know, previously we had to have the front end and the GUI sharing the same port, so we couldn't really filter the GUI but allow the front end, you know, to connect to clients, right? So so now you can actually apply an IP filter in policy in the config file to the GUI, so that you know, you actually can't log into the GUI from, you know, certain IP addresses. You have to be in certain IP address to be able to log on to the GUI. So that helps as well. Cool. And we have a bunch of new accesses: SMB accessor, Azure, support Azure, S3 accessor. That is actually really cool. S3 accessor allows reading and uploading to S3 buckets. And so that actually works really well with the offline collector, especially when the offline collector is configured to upload to an S3 bucket, because then you can fully automate this thing where you could basically on the server just watch the S3 bucket, and then when a new collection appears, then you can immediately import it and post-process it, and add it to the hunt, and it becomes part of, so then it becomes like super automated. All right, so that was all, like a lot of the technical. Are we adding RBAC-based permission on type of artifacts such as service and admin artifact can only be accessed by admin? So that is already there. We already have the ability to say in an artifact, you have to have this permission to run this artifact. That's already there. So if you have a particular artifact that says, you know, I need to be able to run a binary, or like, so some of the artifacts, for example, like allow you to run arbitrary commands, right? And that is obviously quite a sensitive thing. So we say you require exec v permission. So you require the ability to run arbitrary commands, basically. So we already have that. So without so that was the technical side of it. But without the community, I don't think we would be here where we are. So I actually wanted to talk a little bit about the Velociraptor community this year and what happened, with us. So one of the things that we wanted to do this year, which was a bit different, was we wanted to know who our user base was, because it was important to try and understand, where should we develop our invest all our efforts, what kind of features are important to the user base, and like people, it's an open source project, so people are very nice, and they always say, oh, well, thank you, but sometimes you develop something that people don't necessarily like or don't necessarily find useful, but instead of people just saying, no, that's obviously that's people are too polite to generally say, like, no, that's not useful, right? But we wanted to get to kind of prompt that feedback, and so we actually had here we've got a Velociraptor community survey, and you can read the report of that here, which I would encourage you to try and we try to get some questions to understand our user base and understand what people need. And it actually proved to be super useful. So we'll do it again next year, because we managed to get quite a lot of ideas about features that people found useful. And we wanted to know whether, who our users were in terms of size. Were we mostly small size or large size? And it turns out that there's actually a big mix. A lot of small companies, but also a lot of very large companies use Velociraptor, and people use it for a number of different focused areas, but I would say almost like evenly. So we're going to continue developing on those things. They're not kind of a waste of time. People do like it, and deployment size varies a lot. Most of the people have small number of deployments. But there's a few people that have extremely huge number of deployments, in the 100,000 range. But like most of the people are sitting at about the 5,000 endpoint range. So this is important for us to work out how much effort we should invest in really large scale, because that's an engineering challenge, obviously. All right. So, and the other cool thing that I thought was really, really sweet was that we got a lot of testimonials and product feedback, which was really cool. And yeah, so it sounds like the community is is happy and coming together. So that's really good. Looking into the future, where are we headed with Velociraptor? And so everybody has their own kind of use case, which is great. But I actually think that we could look at Velociraptor more as a platform, and there's some interesting things that we could do with Velociraptor being installed widely. We can do all kinds of interesting things and treat the VQL almost as a platform. So when you think about it, if we have Velociraptor installed everywhere, what could we do? Now we start to do have a lot more possibilities. For instance, we can ask the endpoint about as Wes was talking about before, about auditing, right? Configuration changes. So even inventory management, all of these things are now possible because we have VQL, which is super flexible, and we can write specific queries of the endpoints, and it's already installed, right? So we've got a lot of interest in doing these little experiments, like the audit framework that Wes was talking about, trying to understand, how could we leverage that to go into sort of similar but different areas, like compliance management or patch management or something like that, right? The other cool thing that we started to see more and more is other projects that are building up on VQL, and that goes towards the theme that we talked about with Velociraptor as a platform. So we've already talked about Matt's Detectoraptor, which is a perfect example of another project that is generating that VQL, automating all of the VQL side of it, and then it actually builds on top of Velociraptor as a platform. And another example is the SQLite artifact, which also was developed this year. And basically, it was kind of inspired by SQL eCMD, which is a popular SQLite analysis tool, and it was kind of inspired by that because that is a fairly automated tool with a lot of these specialized, descriptive YAML files that kind of deal with different types of SQLite, like Chrome history and Firefox history and things like that. And so building on that kind of idea, we have the SQLite artifact, SQLite Hunter, which is here in this repository, which again basically ends up with like a lot of these very automated parsers that just look for Chrome history, so like in this case, when we're talking about let's just switch orgs. So in this one, we can just collect it, so it becomes very easy. You just collect with SQLite Hunter, right? And then we just go. So we don't even need to tune it or whatever. And it basically just goes for, and it just everything that looks like a SQL. So it has all the targets, right? And it just goes and fetches them. So you basically, so it's not just web browsers as well. Like, we've got, other things like activities cage, the Windows EDB, which we saw talk about today as well. So that was cool. And then you basically end up with like all these sources, and we talked about that before, right? And we talked about the the Windows thing before, right? The search index, which is pretty cool, right? So you can see that the search index is not really SQLite, it's ESE. So it's so it's kind of like we had a bit of a scope creep, but it's become sort of like a one size fits all super automated artifact that is becoming much. It's becoming much more usable than just going and collecting 100 different types of smaller artifacts. So anyway, just to summarize, we've done a lot this year, but really to move forward, we really need you, the community, to help us out by asking for features, asking for ideas, brainstorming ideas like, oh, I would really love to have something that does whatever. And we are a very welcoming and open community. We're on Discord and GitHub, and don't be afraid to jump in and have a chat, and have suggestions. These are actually really important, even more so than writing code. If you just have a great suggestion, this is like a great contribution to our project. So yeah, so anyway, thanks for attending the VeloCON. I mean, this is the last talk we've wrapped up, and it was a really excellent event again this year. It was really cool. The great set of talks, and yeah. So these are all the. If you haven't played with Velociraptor yet, I mean, what are you waiting for, right? Yeah. So yeah. Thanks for your time.
All right.
Yeah.
Thank you very much, Mike. I want to echo your sentiments there. This is a great conference. If you don't mind giving me the share permissions back.
Sorry. Yep. Stop.
Just have
there we go.
few more slides to wrap us up here.
Yeah.
All right. Okay, so excuse me, you already did what I was going to do, which is
there you go.
kind of reshare some of the resources here. So we have our website, our main website, which has all of our documentation. We actually refer to it as our documentation site, docs.velociraptor.app. Really, that's kind of like the starting point for anything that you need to find, right? We've got all the other links on there as well, links to our Discord server, links to all our social media. We have our blog on there, our Velociraptor blog, where any new news or stuff like that is posted there pretty immediately. GitHub is the repository for Velociraptor. So if you actually want to give Velociraptor a spin, that's where you'd go to download it. You can download any other artifacts there as well. We also have some documentation and discussion forums there outside of what we have on the main site. And then our social media links, our two social media platforms are Twitter/X and LinkedIn. It's really the best place to keep up to date on all of the news and happenings on Velociraptor. Really, if anything happens, we usually get that out there on Twitter and LinkedIn pretty quickly. So be sure to add us on there. It's also a great way, LinkedIn primarily, also a great way to interact and network with other Velociraptor users. I've met a ton of great people via LinkedIn. A couple of people have reached out to me just today during this conference, and I appreciate the invite. So and everyone here is welcome to hit me up on LinkedIn as well. Our Discord server, as you mentioned, is the same as our website, just /Discord at the end there. And then YouTube, this whole presentation will be, or this conference, excuse me, will be on YouTube. It'll be replayed on there. A few people have asked me, how long will it take before the replay is available after the live stream ends? That's really up to YouTube. This is a pretty hefty, lengthy video, so it's probably going to take a while for YouTube to do all the post processing. I think last year it took us like a good 12 hours, like a half a day before the replay was up there, maybe less, but it will take a little bit for it to process. Excuse me. Once again, please get the we're going to get the survey out at the conclusion of this presentation. A few people have asked me if we're going to announce the presentation of the conference today. It's not going to be today. I want to give people a chance to actually fill out the survey when we set it out. Excuse me. Yeah, so we'll get that survey out probably within a day or two of the conference ending. Want to make sure everyone has time to give us their candid thoughts, and then in that survey we'll have one of the questions will be who you thought the presentation of the conference was. We'll tally up those votes and then we'll make an announcement. If not by the end of this week, sometime next week. Okay, I just want to throw out a couple more words of thanks out to various people out there. I want to thank the IT and event staff here at Rapid7 again for all their help in helping to logistically stage this event. It took a lot of coordination with them to make this happen. It went pretty smoothly, I would say. We didn't have any real hiccups with the technology this year, which was great. I want to thank the executive team at Rapid7 as well for helping to sponsor this event. Our incredible panel of speakers, they absolutely knocked it out of the park this year. I want to thank them all by name. Matt Green, Simanur Gunyesu, Falgun Kulkarni, Julia Paluk, Andreas Flamino, Wes Lambert, Kostya Ilukovic, and of course, Mike Cohen, for all of the wonderful presentations. I know I learned a lot today. I hope everyone who attended learned a lot as well. And then finally, most importantly, I want to thank you, the community. Without you guys, this would not be possible. It has been my distinct honor and privilege to host this conference last year as well as this year. It's just been a pleasure. I've met so many great people through the course of this job, and I look forward to meeting a lot of you guys as well. Please don't hesitate to reach out to me on any of the channels, Discord, LinkedIn, anywhere. Twitter as well. I love meeting you guys and kind of finding out how our community is taking Velociraptor to the next level. I really can't wait to see what the future lies, and I'm sure you guys can either. So thank you again for everyone for joining. We had a great crowd, some great questions, very lively, very interactive and engaging, and I want to thank you guys all again for making this a great event. Once again, my name is Carlos Canto. Thank you all for attending, and we'll see you next year.
Thank you so much, Carlos.